Welcome everyone. I hope you can hear me loud and clear. We are making a start today. Lingaro, Google Next, Cloud, EMEA, Watch Party, all together. I will be later on joined by our top experts. They will join certain sessions on the way. So let me share with you how the day will look like. By the way, you can always post comments wherever you are, either on YouTube or Facebook or Periscope on Twitter. I hope all there we do have coverage now, and I hope I'm audible. Let's see this from someone. Okay, good. So let's begin. I want to share with you bits and pieces how this day will look like. Let me share that in a wider space. So we will cover the topics the whole day. We also have certain blocks. Now it's me, Paweł Manowiecki, Google Cloud evangelist, who brought together the team here and who will moderate the whole day. So I'm looking forward to your comments, looking forward to any kind of hints, and looking forward that you join the discussion. At 9:15, so I'm looking at the clock for 15 minutes, we will be joined by a marvelous team of three. Marek Kaczor, who is our senior architect in area of Google Cloud. So he's the top one. We are checking with him every architecture sent to customer. And two amazing consultants, Michał Herman and Adrian Rzeźnicki. Yeah, tough name in Polish, Rzeźnicki. The first block, so from 9:15 to 11, we will be covering topics of analytics, smart analytics from Google. This will be about the roadmap of the whole suite of products, roadmap of BigQuery, and we will, at the very end of this, so like 15 minutes to 11, we will start discussion live with experts. During the live video, you can post comments, you can ask questions. We will try to, type them in and give you an answer. But the main point of discussing, so watch together with us two videos. I will tell you the names are What's New and What's Next in Smart Analytics. That will be the first video. Second video, Smart Analytics Deep Dive on the Roadmap. Two executives from Google will share that story. And by the way, we are just showing a part of the Google Cloud Next conference. It's just a couple of videos to focus you on the most important bits and pieces. But don't forget to go to Google site for the Google conference. You will find much more, much wider content, which you can watch later on wherever you wish. We wanted to help you to focus, to make it compact, make it quick, and discuss, so that you don't feel home alone. I hope you work from home like most of us. Our food company is very productive, but from home offices. I'm here in my studio. Lucky me to have this nice space to broadcast. And hope you stay safe. Hope you went for your favorite drink and you have it in your palm. So once more, that's the first part of the story, and we will go through these topics of Google Smart Analytics from 9:15 to 11. I will play at the bottom of the stream agenda when what, to get you updated like on the TV channel. But that's the first point. Let's go and see the second point. Second point. Let me show you these faces in closer zoom. Magdalena, and Bartłomiej Kawecki. These two great people from Lingaro are Looker experts. We will go through 2 videos of Looker roadmap, very interesting overview of the vision for next releases, next years. That will be the first video. And second video will be about one of the business cases, one of the deployments in the customer, a big customer who used Google Cloud and squeezed out from Looker the most of all of the possible use cases. That will be the interesting story to see what kind of use cases they benefit from Looker itself, and then from Google Cloud stack as well. And once more, from 11 till 12, we will focus on these topics, like 10 or 15 minutes to 12. We will show up live with Magdalena and Bartłomiej to discuss Looker topics, to discuss these 2 videos. So that will be second breakpoint in the agenda. Where is my cursor? Here it is. Another point on the agenda is a very wide coverage and a very long point in time in the agenda for today, meaning we'll look through videos about making data lake on Google Cloud, making streaming solution for that. Some of the BigQuery nice management functionalities, and the story on geospatial. That will be last point. We will break this long session into pieces. So after 1 or 2 videos, we will break, and together with Marek, Michał, and Adrian, our 3 champions in Google Cloud, we will discuss with you, discuss between us, what do we see as interesting in that story. Going forward, 3:30, so like 15 o'clock, we will be joined by Dominik and Aleksander, Dominik Lewy and Aleksander Molak, our 2 great data scientist guys. They both experience Google Cloud Stack. They both do projects on Google Cloud Stack. And we will watch together and then discuss 2 of the videos about explainable AI. And second one, let me remind myself from my list. Second one will be driving business information in retail using AI. We've selected not purely highly technical videos, which you can enjoy from Google Cloud Conference. We focused on the business case, use case scenarios out of it. And this will be quite interesting point in time. So let's say my small reminder was, don't get stressed out if you're not into data engineering, not into data science. We will capture more high-level discussion, more high-level topics. So you're free to join. But whenever you have a will to ask very tough technical question, we are open also to answer that, as we have a large gremium of experts here. Going forward, we will end like 15 minutes to 5, 15 minutes to 17 o'clock. We will try to summarize that day with Google Cloud Conference. We also will announce the winners. So I will try, this will be like, let's say, our decision without specific rules. The most engaged people discussing, giving us comments and getting into that interaction will have a chance to have 1 hour session with our experts for their companies. That's a really good opportunity to deep dive. If you would be interested in specific bits and pieces and want to convert that into story for your company, you're free to win that prize at today's live stream. In 5 minutes, I will play first videos, but maybe for these who just joined, because that's how streams are starting, you notice it's there, it's live, that this crazy face of Manowiecki is there around, and you join and you want to get to know what the hell is going on, what they will show. So quicker recap on that. Today, from now on till end of the business day, we will cover several topics of Google Cloud Next conference agenda. We've selected specific videos to focus you on the most interesting bits and pieces. Feel free to enjoy the full content of this conference on Google Cloud Next conference website. Today, it's a day for data analytics, databases, and topics around that in this conference. So these videos start to be open and available for you. We have selected, let me see, around about 10 videos, 12 videos, which we will go through the day. And main points of the agenda will cover following stuff as I'm showing here on this picture. I'm trying to capture. Here is the stuff. So that's me, Paweł Manowiecki, Google Cloud Evangelist at Lingaro. I will moderate today's session. First big point is Google Smart Analytics Roadmap. We will go through the newest announcements of Google Cloud, together with a group of fantastic experts, Marek Kaczor, Michał Herman, Adrian Rzeźnicki, the trio. Marek is our architect, so there is no secret for him for the architecture of Google Cloud. And Michał and Adrian are, working 120% on Google Cloud projects, so they are experts here. Then we will go into Looker, 2 experts, Magdalena and Bartłomiej will join us at 11, and close to 12 we will discuss live what do we see as interesting there. At 12 o'clock, bigger part, which we'll cut into pieces, Marek, Michał, and Adrian will discuss data lake, streaming, BigQuery, and geospatial. These kind of videos will be played by us. At 3:30, advanced analytics, AI, but covered from more generic perspective. We will not go into spicy details, together with amazing Dominik Lewy and Aleksander Molak that will be discussed then. And we will close the day. With announcing the winners, because you can win 1 hour one-on-one session with our experts for your company. 3 of the most active participants will be nominated for that award, for that Grand Prix at the end of today's session. So be sure to stay interactive. Whenever you post on any of the channels some comments, we will see them and we can refer to them, and we can answer either deep dive technical question or the topics which we have on agenda on the videos. So without further ado, it's like 1 minute before we start the first video. Let me switch the gears a little bit here. There's just, all is live, all can happen. Forgive us if there will be technical problems, but I hope that will be fairly limited. I hope. Let me prepare the first video. We have a first video. First video will be what's new and what's next in smart analytics. And I share this with you in a bit. Okay, and then we play another video right after, because this will be 15 minutes video, a short cap on the whole landscape, and then a deeper dive. This will last around 45 minutes before we will show up live. Looking forward, stay with us, stay tuned for more discussion. and let's watch the videos together. Share the screen. Share my screen with the voice, and off we go.
Hi everyone, I'm Debanjan Saha, VP of Engineering and GM of Data Analytics at Google Cloud. Thank you for joining us today at Next On Air. This week, we are going to focus on data analytics. I'm going to kick it off with an overview of our portfolio, highlighting some of the new product launches. I'll also talk about our strategic priorities and what's next for data analytics at Google Cloud. Throughout the week, you're going to hear from my teammates about our roadmaps and under-the-hood technical details about our products. We'll also have our customers and partners telling their stories about their data journey with Google Cloud. So let's get going. Big data is in our DNA. In fact, it is part of our mission statement to manage and organize world's information. There are many Google products that handle massive amounts of data. Over the past 20 years, to support these products and their users, we have built a powerful data analytics platform. This platform is now available to all our cloud customers. Our data analytics platform offers a comprehensive set of analytics services, everything from data collections to processing, analysis, and activation. In the last year, we have added a number of new services. Cloud Composer, our workflow engine. Cloud Data Fusion, a visual ETL system. Cloud Catalog, our metadata management service. I'm also really excited to have Looker join our family. Our existing products like BigQuery, Dataflow, and Dataproc added exciting new features. Now, good tools are only one part of the story. Without data, analytics is not very meaningful. And that's why we spend a lot of time making sure data is readily available to our customers. This includes various Google data sources, Google Analytics, search trend, maps, and mobility data. Data from various operational databases in Google Cloud, Cloud SQL, Bigtable, Firebase, etc. Data from external sources, as for example, SaaS and third-party applications like Salesforce, Adobe, and SAP. Ready availability of valuable data is a big reason why customers come to Google Cloud for their analytics needs. Well, we have the tools, we have the data. How do we translate that to drive business outcomes? And do that quickly. That's where solutions come into the picture. We are codifying common use cases in various different industries into solution blueprints. Customers can begin their journey with these blueprints and build custom applications and solutions in a matter of days, not months. This accelerates time to insight and time to value. For example, we have put together this solution blueprint for Google Ads and marketing platform activation using BigQuery and its built-in ML functions, and Looker using a variety of data sources available in Google Cloud. We have many more examples like this. Here is a list of various solutions in various industry segments that we are working on. Solutions are a high priority for us and a major area of investment. Let me now talk about our strategy going forward. Our vision is to build an enterprise-class analytics platform, an analytics platform our customers can depend on for their most demanding mission-critical workloads. And we want our platform to be open, intelligent, and flexible. Let me walk you through this. Why open? Well, our customers don't want to be in walled gardens. They want choice, both first-party and partner services. They want portability so that they can move into cloud easily and migrate out if they want to. They want support for hybrid and multi-cloud. Speaking of multi-cloud, in a recent Gartner survey, 80% of public cloud users indicated that they use multiple cloud providers and will continue to do so. As you know, we are a big proponent of multi-cloud and believe that multi-cloud is the future. That's why I'm really excited to have Looker join our family. It is truly a hybrid and multi-cloud business intelligence platform that runs on Google, AWS, Azure, and also on premises. Looker helps you create semantic models and data API on all your data across clouds and on-prem. You can use this to build interactive dashboards, custom workflows, and applications. I'm also really excited to introduce BigQuery Omni. Many of you use and love BigQuery, our flagship data warehouse. You have asked if you can make it available on AWS and Azure. Well, consider your wish granted. BigQuery is now available on AWS for customer testing, and it's coming to Azure soon. With BigQuery Omni, we are breaking down the data silos. No matter where the data is, Google, AWS, Azure, you'll be able to query it using the same familiar BigQuery UI and standard SQL. Powered by Anthos, it is the first fully managed multi-cloud data warehouse from a major public cloud vendor. Everyone wants to use intelligent services infused with AI/ML. We have some of the most advanced AI/ML technologies in the world. What is unique about our approach is that AI/ML augmented analytics is that we make it seamless. That is, we seamlessly integrated most sophisticated AI/ML technologies into our systems, tools, and processes so that users don't have to learn anything new to take advantage of them. It is a huge plus for the adoption of AI/ML. Let me give you an example. Let's take a look at BigQuery ML. It allows you to build custom ML models using standard SQL with data already stored in BigQuery. So data analysts can build sophisticated models and use them for inferencing using simple SQL without having to learn anything new. How awesome is that? We are taking it a step further. We are using these models to build solutions that solve real business problems, like recommendation systems, customer segmentation, anomaly detection, and forecasting. One of the solutions we are launching this week is anomaly detection. It has use cases in different industries, as for example, flagging fraudulent stock transaction or money transfer in financial industry, detecting odd traffic patterns between a pair of sender and receiver in telcos. Flexible. We have a diverse customer base. They are in different industries, have different use cases and different business models, and they want choice. And they want flexibility in how they use our product, flexibility in pricing models. We want to meet our customers where they are. Let me elaborate with an example. A lot of our customers use BigQuery. Their use cases are different, and so are their access and analysis patterns. For example, data scientist wants to access data stored in BigQuery directly using the storage API. Data analyst likes the SQL interface. Business analysts access BigQuery through their favorite BI tool like Looker and Tableau. We have now added a natural language interface to BigQuery. This is the kind of flexibility our customers are looking for. I'm really excited about data Q&A. All business users, as for example, agents in call centers, traders in stock exchange, will now be able to use the power of BigQuery. It is true democratization of analytics. We talked about a lot of cool things, but those only matter if the platform is dependable. That's why we are laser focused on availability. We just announced 4 nines guaranteed SLA for BigQuery, best in the industry. Our platform offers scalability and security that meet the requirements of the most demanding workloads, and compliance and governance control required in the regulated industries like finance and healthcare. But the best testament to our proven dependability is the adoption of our services by our customers. The largest enterprises in every major industry segment use our analytics services. And it is not just the big enterprises. Customers, big and small, and customers all over the world are using our services in increasing numbers. But instead of me talking about our customers, let's hear from one of our very important customers. I am pleased to introduce to you Vittorio Cretella, CIO of Procter & Gamble. Vittorio, first of all, thank you very much for joining us to share a bit about your data story. Could you introduce yourself first, though?
Sure, and thanks for having me here at the next on-air dimension. My name is Vittorio Cretella. I'm the CIO of Procter & Gamble, and I've been working as an IT professional in the CPG industry for many years. My passion is to create consumer value with technology and data. I must tell you, P&G is the best company in the world to do that. Our aspiration is to serve consumer in the world better than our best competitors in every category and every market. where we choose to compete, and in the process, creating shareholders' value.
P&G is a 180-year-old company, or should I say 180-year young company. You clearly know a thing or two about consumer experiences, and I've gone through a few transformations over the year. So how are you thinking about data analytics in the cloud to deliver even better experiences for your customers and help transform P&G again?
Yeah, Debanjan, our objective at P&G is to understand consumers and serve them better than anybody else. And we do that by becoming a data-centric business. Like many other businesses, we use data for descriptive and diagnostic purposes to understand what happens and why. But where we excel is using data to make predictions, to understand what will happen next, and understand whether a promotion will be successful, to decide product assortment by clusters of stores, to manage spikes in demand across our supply chain, like it happened during the pandemic. And I can name many other examples. Now, to achieve that, we can tap into a very rich data lake environment, and we benefit from the skills of our data scientists and business analysts who create algorithms to solve some of the toughest questions. Increasingly, we turn those predictions into a prescription. So we automate the result of this algorithm and inject them into our transactional and planning systems so that mainstream decisions are automated. Now, the cloud provides us the agility to do that at scale with three things. Number one, the capacity to store big amounts of data on demand. Second, the tools and the machine learning libraries to work on those data. And last but not least, the means to ensure operational reliability and the protection of data privacy. Now, getting there means we need to invest in our partnerships, and Google Cloud, for one, helps us deepen our technical capabilities and supports our needs across the data stack.
Thank you for that. Now, speaking of cloud and Google Cloud specifically, can you share a little bit more about how Google Cloud fits in your data strategy?
Sure. Let me say first that we are in a multi-cloud data lake environment with several petabytes of data across functional areas with many business use cases. Our partnership with Google Cloud started about a year ago with the objective of storing and analyzing our brand and marketing information. And since then, we have been on a journey to migrate all our consumer information in a data lake, which currently is larger than 4 petabytes. The data lake provides one unified view of consumer and allows to orchestrate effectively omni-channel consumer journeys, which means enabling to serve the right content to the right audiences at the right time on the right channels. Now, we take advantage of many great products in your analytics portfolio, and I'd like to call out one in particular that I've been really impressed by, which is BigQuery. And since we started working with BigQuery, the technology performs incredibly well. We are using it both for data science purposes, but also to serve descriptive and diagnostic information to larger audiences, thanks to the compatibility it has with our standard visualization tools from other partners. And that, I believe, is a great story. It's a great story when we can make our tools work better together so everyone can deliver against the business and analytics objectives.
That is a great story indeed. You touched on using other tools and technologies there, Vittorio. As you know, we are a big believer of customer choice and open platform. Can you share how that's influenced your decision to work with Google Cloud?
Yes, Google Cloud is a strategic partner in our multi-cloud environment. And one of the things that I've appreciated is how your teams work together as an extension of our teams to help us bring transformation initiatives to life without pushing us into a closed ecosystem, a closed software environment. Now, our future is with a multi-cloud environment, and we are really excited by what working with Google Cloud will deliver, will enable us to do and to achieve, to redefine the experiences for all consumers of Procter & Gamble brands.
I'm intrigued by those future experiences. Vittorio, is there anything else you would like to share with us today?
Well, I believe you'll see more and more examples of connected products where our consumers opt in to share information and receive in exchange personalized and services and advice. And I'm sure you're familiar with some of them, such as Lumi by Pampers, the sleep routine system that helps parents to track day-to-day developments and monitor their babies 24/7, or the Oral-B IO series toothbrush that has a unique and very effective brush head design, but also shows you how to effectively improve your teeth cleaning routine. All this is made possible by data, including the information we safely store on Google Cloud. And things will evolve. It'll be interesting to see how.
Indeed, it will. Thank you for joining us for Next On Air, Vittorio. It goes without saying, we very much appreciate your time and your partnership. Thank you.
Thank you, Debanjan. It was a pleasure. Have a safe and productive summer.
Just to wrap up, throughout the week, we are going to cover different aspects of data analytics services in Google Cloud and how we are building a platform that is open, intelligent, and flexible. Please tune in and participate in the 40+ breakout sessions from Googlers, our customers, and partners. Thank you.
Welcome everyone to the Smart Analytics Roadmap session. I'm Sudhir Hasbe. I'm the Director of Product for Smart Analytics at Google Cloud. Data across organizations is growing, and then organizations need a very strong analytics platform to leverage this data, create insights, and make real-time decisions on top of this data. At Google Cloud, we are a data company. We basically collect massive amounts of data. We leverage our machine learning and AI capabilities to generate insights from them and power our products. We have more than 9 products. We have 9 products that have more than 1 billion users that use it every day. At Google Cloud, we have also seen convergence of a lot of these technology trends. We have seen organizations are breaking down data silos between data lakes and data warehouses. As organizations are moving to cloud, they want to be able to interoperate between all of these data assets that have been created. Second, we're seeing organizations focus a lot more on real-time decision making. And a lot of processes historically have been built for batch processing. And this transition to real-time processing is requiring organizations to think about how do you go ahead and build consolidated solutions that can run on both real-time as well as batch data. And then finally, analytics and AI, merging these concepts. Like data scientists are spending 80% in some studies on data preparation, and analysts are trying to go ahead and do predictive analytics on top of data that they have. And convergence of these different users within organizations, use cases is also becoming a norm now. So at Google Cloud, our vision is to go ahead and provide you with an enterprise class data platform that is proven to be dependable. We at Google actually have services that are built for scale, built for availability. So we want to bring that same kind of rigor to our data platform. The other thing is we believe in open and flexible capabilities. We are also leveraging some of the intelligence capabilities with AI, ML, embedding it within our products. So we want to provide you with this end-to-end smart analytics platform that allows you to go ahead and get more value out of your data. So what does the platform entail? You can go ahead and collect massive amounts of events in real time or in batch with the platform. Organizations like Spotify are collecting events. Every time you play a song, the event gets collected across the globe using PubSub. They process the data through Dataflow, which is our streaming service that allows you to go ahead and do stream processing as well as batch processing. You could also use Dataproc, which is managed Hadoop and Spark environment with similar kind of data sets. And then you can use BigQuery for large-scale analysis. In addition to that, we have launched migration service that allows you to easily migrate from your traditional data warehouses to BigQuery. We launched Data Fusion. It's a data integration service. Visually, you can create data pipelines end-to-end and then go ahead and deploy it on GCP. We went GA end of last year, and we've seen tremendous interest in this from customers across the globe. Data Prep is a data wrangling service. It's a partnership with Trifacta. It allows you to go ahead and do zero code data wrangling or data preparation. We are also going to have a couple of new SKUs that are being launched for Data Prep as we go into this year. The other thing is also from a storage perspective, you can leverage BigQuery or Bigtable. A lot of organizations use Bigtable as their backbone for high throughput data sets, like when you need it for your e-commerce website and all. And an organization use BigQuery for large scale analytical data sets. It's a analytical store. And then you can use BigQuery for analysis with SQL. It has various different capabilities in SQL. And then like things like BI Engine, which is our in-memory technology, embedded machine learning. So you can create machine learning models with like just a couple of lines of SQL. And then you can also use Spark with Dataproc. A lot of organizations like using Spark ML for machine learning models and all. You can do that with Dataproc. And then finally, to activate, to take actions on top of your data, you can use Looker. Looker is a great addition to our platform. We'll talk more about that later in the presentation. Connected Sheets. You can now leverage connected sheets like Google Sheets to leverage the power of BigQuery on the back end. You can take a petabyte scale data set and just start analyzing it with connected sheets. And then on top of that, we launched Data Catalog earlier in the year. It allows you to go ahead and get metadata, understanding of your environment. You can search for any data set that you have, put some policies on top of that data. And then Composer, which is our workflow orchestration capability, which is managed airflow, allows you to bring all of these services together. So overall, if you look at the platform, you can collect, you can process the data, you can store it in various different platform solutions that we have for different use cases. You can analyze it at scale, and then you can activate on top of that data with different kind of activations. One of the other things we were talking about earlier is this interoperability. So at Google Cloud, one of our key value propositions is to go ahead and have this completely interoperable environment where you can have your data in a data warehouse or in data lake or in databases, and you can use the same BigQuery engine to go ahead and run queries across all of them, even Google Sheets. Then on the other side, if you store your data in BigQuery, which is a highly analytical store, you can then use any of the other engines, including like you can use the BigQuery engine, but you can also use Spark engine with Dataproc. You can use Beam with Dataflow. You can use Cloud AI. So all of these different engines like AutoML and all, they seamlessly work on top of BigQuery. So this interoperability is one of the key value propositions that we are focused on. We've added a lot of capabilities in last year or so, and then we continue to improve it as we go. We have seen tremendous growth across the globe. Every industry, every region, organizations like from Home Depot to AirAsia, HSBC, UPS, like you will see different kind of organizations, some of them like cloud native startups to like Twitters and all, and to like, traditional enterprise organizations using the platform. So today, as I talk through the roadmap, I want to take you through 4 different kinds of use cases that organizations use or scenarios. One is with modernizing your data analytics with BigQuery, data lakes with Dataproc and Composer, more responsive businesses with Dataflow and PubSub, and then finally enterprise BI with Looker. Let's talk about BigQuery. BigQuery is highly scalable cloud data warehousing solution. Start query. You don't have to worry about machines and operations and manageability or anything like that. It allows you to do real-time streaming. We have customers that are ingesting tens of millions of events every day. Tens of millions of events every second into BigQuery. We have embedded machine learning, and then we also enable insights for everyone within an organization. With investments like connected sheets, now data and insights is accessible to everyone. One of the other innovations that we have worked on is around our pricing. So BigQuery is 10 years old. In June this year, we became 10 years. We pioneered the pricing model of pay per query, but over a period of time, organizations have asked for different options. So we launched BigQuery Flat Rate, which is subscription pricing, every month fixed price, so that you can go ahead and leverage BigQuery with a consistent price point. We also had a lot of customers ask us for this burst per second, per minute billing, so that they can bring workloads that are bursty. Monday morning ETL jobs have to run, or you have a Black Friday event that happens in US. So all of these different kinds of use cases needed this burst capability. The beauty of 3 pricing models with BigQuery is you can actually interchange them. You can basically use all 3 of them in a mix and match fashion within your organization, and go ahead and leverage each one of them for different kind of use cases. So you can easily mix and match these. Let's talk about BigQuery roadmap. I want to highlight few of the key things, but there is another session at the bottom of the screen. You will see these recommendations I have for different sessions that give you deep dive into these specific areas. But let's talk about BI engine and materialized views, always fast, always fresh, BigQuery ML, data Q&A, and Omni today. Always fast, always fresh. This is our theme around collecting large-scale events in real time. We have rebuilt our whole storage engine to be streaming first. Along with that, we have materialized views where what users can do is they can take this data that's streaming, coming in, or any batch data that comes in. You can partition and cluster it so that the queries become faster. But with materialized views, you can actually pre-aggregate and keep the data sets ready for the use case that needs the low latency. One of the best things about materialized views is, as the underneath data changes, we automatically update your materialized view. You do not have to worry about running scheduled jobs and all. So we will automatically materialize it. Second thing we do is, if a query is returned after, or if you have an old query that doesn't use materialized view, but you've created this materialized view, internally our query engine will reroute the queries to go through materialized view. So that's a really good capability, so you don't have to worry about changing all your queries and all. And finally, BigQuery BI engine. So BI engine allows you to have this in-memory caching layer on top of BigQuery that gives you sub-second latency response times on your BI use cases. Today, it only works with Data Studio, but later in the year, we will make it available through TurboSQL, which is our internal name for our SQL capability. So any query coming to BigQuery will be able to leverage BI engine. So this will be available through all the BI tools, our JDBC drivers, as well as the queries that you fire. It will give you really fast response times on top of that. And we will also support some of the star schemas for BI engine use cases. And the other thing is, nothing changes on your side. Write the same query, we will automatically fall down to whichever layer has the most cached results for you. So if it's BI engine in-memory caching, we'll use that. If not, we will fall to materialized view. If not, to partition cluster. Let's switch gears, talk about BigQuery ML. BigQuery ML is our embedded machine learning capability. It allows you to write 2 lines of code to create machine learning models, and then get predictions with similar kind of 2 lines of code. So we launched this like a year and a half back, and then since then we have been adding all these different types of models. We have seen tremendous interest in k-means clustering, with matrix recommendations, or recommendations through matrix factorization. We have customers who have taken their historical user data, gone ahead and create clusters based on what type of users are there, and then do product recommendations to them using matrix factorization. In recent times, we've also added new capabilities where now you can connect to cloud AI services and their capabilities, like AutoML tables. Now, BigQuery ML with 2 lines of SQL, you can leverage AutoML. You can use XGBoost from there. You can use DNN models with it. So we are basically making it all the different cloud AI capabilities more accessible through SQL for our BigQuery and our data analyst community. We also have the time series forecasting. But the most important thing that we have added is this interoperability with TensorFlow. Now you can take the model that you created in BigQuery, export it as TensorFlow, and then load it into your serving platform and make it more accessible in the real-time world too. The other theme we have had is this democratizing insights. with connected sheets, you can take a petabyte scale table and then have a great visualization, great ad hoc analysis with connected sheets or G Suite sheets. With data Q&A, now you can use natural language to get your questions answered. So it's basically, you just ask a question, get an answer. This is going to free up a lot of time for BI teams, right? You don't have to now create a custom dashboard or a report for every question that comes up. You can just ask it. The main thing that we're focused on is making this available through various different experiences. We do realize organizations want different experiences with natural language. In many cases, it's all available through an API. So organizations can build their own custom experiences. We will make it available through Google Sheets. We will have some chat bots, Dialogflow integration. So all of these different integrations are planned to be coming. It's all built on our internal technology called Analyzer. There's a great paper on it if you're interested. But this is the same technology that also powers Google Assistant and various different services that we have internally. It allows us to go ahead and get like question parsing, intent identification, and entity matching all done automatically using the same technology. And then the SQL and how we map it to BigQuery is where we are innovating right now. So great new capability. If you're interested, you should reach out to us so that we can give you early access. The other big area, every organization is in multi-cloud environment now. If not, they will be in some time to come. A few years back, there used to always question which cloud, why cloud, and all of that. Now, I talk to customers across the globe. Most of the questions that they ask is, what are the key capabilities in which cloud and how do I leverage them for their use cases? So BigQuery Omni is our ability to take some of our core capabilities with BigQuery and extend them into other cloud environments. So you will get the same experience. You still go to the BigQuery UI, you still write the similar queries, you're just now accessing data on different clouds. So that's one main thing. And then finally, we're leveraging Anthos internally so that the management of the machines and all of that is not your problem. We just do that behind the scenes. The way to think about this is like we are announcing the availability on Azure in the early alpha phases where you can reach out to us and we can you can start testing and validations and stuff like that. We will make it available to organizations in form of beta and all later in the year and all. But the way to think about it is it's just another region. So you will have the same control plane, same query experience in BigQuery, but today you can connect to US and EU multi-region or one of the regional deployments of BigQuery datasets. And now the data in S3 just becomes another data set for you to go ahead and query. We will take our compute engine and run it in AWS, so you don't pay any egress charges back and forth within that. The only time egress will be involved is when you move that end result set that you have aggregates or something that you created. If you want to move it back into GCP, then egress will be there. But otherwise, you don't have to worry about any of that. All that is managed service. We take care of all of that stuff. AWS is available now, and Azure will be coming soon in coming quarters. So let's switch gears now and look at the second topic. We covered BigQuery from an analytics perspective. Let's go to data lake side of things. If you think about Google Cloud, some of the largest data lakes are running on top of GCP, and like customers like Twitter and Pandora, all of them run large-scale clusters on it and on us. And the reason is it's super fast, it's secure, it's managed, and it's cost-effective for organizations. And we do support managed experience around various different Apache projects like Spark and Hadoop and Scala and Presto and Druid and just pick one. Like we enable you to run Ranger, all of that. And also we have managed Airflow, which is available as Composer service that is there. Today I wanted to talk about few key roadmap items in this area. One is enterprise notebooks. Second is Dataproc Metastore, and then analytics on Kubernetes. Again, more details in other session. We launched our Cloud AI notebooks in recent past, right? It's available. Organizations are using it across the board. You can have your personal notebook. You can create a team notebook with Kubernetes backed environment. But what we have launched now, it's in beta that's available, is our Smart Analytics framework. And what that is we are bringing all the big data capabilities, big data services behind the same Cloud AI Notebooks environment and enabling you to run this on top of a Dataproc cluster. So basically, large-scale Spark jobs can now run on top of it. You just go and create a notebook from Dataproc environment, and then it's available. And then you also have the Beam notebook, and it also connects with like BigQuery, Dataflow, Dataproc. All of these engines become accessible to you from the same framework. Really powerful, really looking forward to enabling these data scientists across the globe to leverage this new environment that's available. The next topic I want to talk about is managed Dataproc Metastore or Hive Metastore. A lot of organizations have told us managing a Hive Metastore is painful. We should just have a managed version of it. That's exactly what we're doing. It's going to be completely integrated with our security capability, monitoring and monitoring capability in Google Cloud. It will support all the major the security capabilities that organizations need. Over time, we will enable all of that stuff. So that is there. You will be able to go ahead and scale out over time and all of that. So it's available in beta this year, and so I would highly recommend using this. If you're running any kind of a Hadoop environment on top of Hadoop or Spark environment in Google Cloud, you should use the managed Metastore now. Finally, I'm super excited about this transition from Yarn to Kubernetes in the big data world, and we pioneered some of it with our launch of Spark on Kubernetes, and we believe that this is the best next step for open source community to adopt Kubernetes. And so right now we have Spark on Kubernetes available. We are looking at other options like Flink and Presto, but this is a great way of running Spark environment where Kubernetes becomes the backbone for management and all. One of the other things this enables is for you to now run Spark jobs on top of BigQuery. Earlier I talked about how BigQuery enables you to have the analytical storage accessible from a Dataproc and Beam. With this now, you can have Spark on Kubernetes connected to BigQuery, and you can run large-scale Spark ML jobs or various different kinds of aggregates that you may want to run outside of BigQuery SQL. So great way of doing that. With that, let me actually switch gears and talk about the next topic that we have, which is around building more responsive businesses with real-time environment, right? So we covered BigQuery, analytical cloud data warehousing. We covered data lakes. Now let's talk about data flow and PubSub. If you look at real-time is becoming really critical, there's a standard pattern. To ingest large-scale events, you want to transform them, and you want to analyze and serve them later. And so the pattern normally in GCP, the way it works is you use PubSub for large-scale connection. You can always use Kafka. Confluent has a good managed service on that. You can transform and transformations. Normally, Dataflow is the best engine, I think, across all clouds for running large-scale stream processing. And then you can also use Spark if you wanted to. And then for analyzing and storing later, you can use Cloud ML. You can use BigQuery. You can use Bigtable. There are a lot of different options there. In the roadmap side, I wanted to highlight a few of the key things here. One was PubSub Lite, Dataflow SQL, making it easy to get started with streaming pipelines, observability and manageability, and of course, streaming predictions. Again, more details in another session in 101. If you think about a collection of events, PubSub is an amazing global service. As I said, Spotify uses it. Large-scale organizations are using it. But we have seen adoption of a lot of do-it-yourself messaging platforms on GCP. And a lot of organizations have said, hey, we want a lower cost option. We want something to get started in smaller teams, departmental use cases. And then PubSub Lite is exactly for that. It's a zonal service. It's super low cost so that organizations can get started. They don't have to manage their infrastructure. Fully managed, really low price and low cost offering. I would actually challenge you to compare your do-it-yourself costs against PubSub Lite, and I think PubSub Lite will become much more compelling for you in even those scenarios. It's a zonal service. So keep that, you should have that in your failover scenarios and stuff like that. Think through what use cases you're enabling. And then it will integrate with data flow and other services like cloud functions and all natively out of the box. The other thing I want to highlight today is data flow SQL. We want to make building streaming pipelines super easy. Data flow SQL allows you to write SQL statements to create complex pipelines. You use the same BigQuery experience for writing SQL. It's the same BigQuery UI, and some of the innovation that we've done in BigQuery UI with multi-tabs and all, I'm super excited to just run a SQL statement and create a pipeline, and we'll take care of all of the creation, management, all of that after that. The thing that it's available today is with PubSub as well as BigQuery. We're going to add Kafka. We are going to add allows you to take any pipeline, go dig deeper into individual steps, what happened and what the bottleneck was and how do you resolve the bottleneck. So getting better and better. The two trends in AI, data flow, various different integrations, cloud AI services, integration with Flow Extended. Now you can build streaming pipelines, go ahead and transfer them, do the prediction in real time, and then go ahead and serve it from a serving layer. We are taking, we're not just stopping at just base integration. We're going to have templatized solutions like anomaly detection, where you can take it and customize it for your industry, your use case, and then go ahead and use it. We've seen anomaly detection being used for fraud detection in financial services or e-commerce sites. We've seen that in network anomaly detection in telecom and all of that. So these standardized patterns and templates are going to help organizations to adopt it faster. Finally, we are also going to enable GPUs and PPUs through data flow pipelines. This has been one of the most asked for capabilities, so you will have that capability too. So we covered BigQuery, the data warehousing, we covered data lakes, we covered streaming analytics. Let's switch gears to enterprise BI and data applications. So Looker now is part of Google Cloud family. It's a great data platform that's available. It basically, Looker is based on this amazing semantic modeling layer. It allows you to define your common understanding of your metrics within the organization. And this is one of the biggest pain points for most of our customers. They basically have different, self-service BI enabled everybody to define their own dashboards, but also everybody to have their own definition of common of their metrics. So with Looker, you basically define your common metrics. This allows organizations to rally behind the common understanding of these key metrics. It also has this BI capability with great visualizations, great tooling for your dashboards and reports and all. So that's always there. Another thing it allows you to do is everything in Looker is an API. So you can build your own custom applications and custom use cases and workflows on top of Looker. Some of the organizations using Looker are like, you can't even see anything in Looker there. It's just an API, headless BI platform that you can go ahead and do whatever UIs you want on top of it. And then we've seen a lot of organizations use embedded Looker, where Looker gets embedded into other applications. It works with more than 55 different kind of SQL dialects, means different databases and data warehouses in the world, including BigQuery and some of the other cloud providers. Today, there's a long list of capabilities we are adding with Looker. There's a great session that will go in deep dive into that. But today, I wanted to highlight the 3 key capabilities that we are enabling. Looker on GCP, integration with the BI engine, and then instant exploration. So first of all, making Looker available in the cloud console in GCP is one of our big priorities this year. What that will enable you to do is you can, with one click, get access to Looker, get started, and leverage the product. But one of the most important things is we are also focusing on all the key security horizontals that you all care about. Like you want CMEC and you want like a VPCSC. All of those different kind of horizontals, they will come over time, but that's part of being a Google service where we're focused on that. The second thing is better integration with BigQuery is, of course, one of our priorities. BigQuery plus Looker is an amazing combination. Like there's unlimited scale on one side and then great visual capabilities, but common APIs that you can use, semantic modeling layer. It's really good story together. And with BI Engine, our in-memory caching layer, you can now start bringing these two together and get sub-second latencies on most of your dashboarding and reporting use cases or different visualizations you want to go with. Finally, in Looker, you do have to start with a model, define it in LookML, and we wanted to make it very easy for organizations and analysts in organizations to go from BigQuery and start using the power of Looker. And basically what you will be able to do with the instant exploration capability is you can write a query in BigQuery UI. With one click, you can get into visualization with Looker. You will be able to go ahead and add calculated fields. You can share those visualizations with your peers within the organization. And then finally, when you're ready to go to this higher level capability with enterprise capability with a governed BI and have this modeling layer that you want to customize, then you can go ahead and upgrade to that. But this starting off and getting started with Looker, with BigQuery is going to become super simple. With few clicks, you will be able to go do that. We covered a lot of stuff today across cloud data warehousing, data lakes, streaming analytics, as well as enterprise BI and data applications. We have tons of more stuff coming. There are a lot of details that we have across the portfolio. In last few years, we've been leaders in every report that's come out from analysts. Forrester, this is a good one where for 2020 data management and analytics wave, we were the leader. Same thing with Gartner reports that have come out. And we're going to continue focusing on enhancing our products, getting feedback from you, making sure that we are working on the right priorities. There are also a lot of other sessions that the team is doing that you can get more deep dive across different aspects of the products and different capabilities that we have. We have 30 plus additional sessions with customer use cases, how customers and organizations are using the platform. So I will highly recommend viewing all of those. And finally, thank you for your time today. Really appreciate listening to our roadmap for smart analytics. Thank you.
Getting back live slowly. Let me make a small adaptation of the screen setup. I will be joined by a marvelous team of experts, Marek, Michał, and Adrian, coming up live now for your pleasure. Let me move like this and have a small round of introduction. Let's put a banner on below us what we will cover now, because we will live discuss these two videos which were covered. So together with me, Marek.
Hello.
Hi, Marek. Marek is our architect for Google, as I showed with you before, and Michał and Adrian, our top consultants in this area.
Hello.
Hi, Michał. Hi, Adrian. So, guys, we all watched together the video. I will show a little bit of. Let me do this full screen. Okay, now I forgot. I will show some points. I made some notes I wanted to make it full screen. Let it be full screen like this. I hope everybody can see. We watched these two sessions, what's new and what's next in Smart Analytics, and Smart Analytics deep dive on the roadmap. Some of the interesting points, sorry, I clicked too much, that's why it's flickering. Maybe, you know, that's the beauty of lives, everyone on the stream. Not all will work as you planned, as you dreamed, right, guys? So be patient. Once more, maybe it will stop flickering. It will not. Whatever. Let's start. So we had news like data catalog, composer, looker acquisition. For the BigQuery, there is Omni, data Q&A, new machine learning capabilities, connected sheets, and not only sheets in case of looker, as far as I know, materialized views which could be used, Smart Analytics Notebook, which could be quickly linked with the whole infrastructure, managed data metastore, PubSub applied, streaming pipeline for AI, so you can do AI while processing streaming, and this cloud data fusion product. Let me ask quite an open question, guys. What do you think is the most interesting out of this? Maybe I ask Marek first. Marek, which point is your favorite on this list?
Okay, just generally, I'd like to emphasize that it seems that that Google is going its own path of developing all components of the analytics in its cloud. We can observe this for the last few years that all the components are getting more and more major, and there are also appearing new ones, like for example workflow recently. And in my opinion, the central point of the analytics is the BigQuery engine, with all its newer and older features. And it also is somehow visible that the role of the data processing and data analytics will be moved more and more to the BigQuery as a processing engine and a kind of a substitution or a replacement of a traditional ETL tool. So it seems that Google try the strategy of ELT and processing data and in form of the compute and storage separation. And yes, and what is very interesting here is the situation of the BigQuery Omni. I don't know how it will go further, because there are also competitors like Synapse and Amazon Redshift. And right now we can see that Google tries to place its product, its main product for analytics, in competitor clouds. It is very interesting situation for me. I would say that it could be a game changer for the competitors, but first we need to investigate what will be the price politics beyond this, and how it will perform. If there could be similar performance as in a native Google Cloud and similar pricing, I think that it could be a really game changer here.
Yeah, so that functionality that you can grab data sets from the foreign cloud and make a usage out of the BigQuery engine. I'm quite interested in that move. That's like Google is trying to underline this ethos concept of making containers running everywhere just from deployed from single location, from single cockpit. That's fine, nice. Gentlemen, Michał, what's your favorite point from these two sessions?
Yeah, so from these two sessions, I think the one point we can take out is that Google tries to open more their products for even less technical users, introducing new options like BigQuery Q&A, when you can query BigQuery not even knowing SQL, not even knowing query languages, but just getting questions in natural language. Also getting new connectors, like connecting Google Sheets with BigQuery. So analysts who are experienced in working with spreadsheets can now work with BigQuery data from their spreadsheets without even getting external tools, without getting external queries, without getting some data extracted from database. So they have direct connection into the data from the tools that I used to work with.
So did I understood right this message that you have petabyte table and you just run it from Google Sheets?
Yes, from Google Sheets you can make a connector, so you can make like some tables, add attributes to them, and the data will be gathered from the BigQuery directly to your Google Sheet. So you have you are operating with a Google Sheet as it is the front end to the BigQuery data that is underlying behind them. So you are not constructing the SQL query to query the data. You are more constructing the Google Sheet with aggregations, and the data is pulled in the backend for you.
Yeah, that would be great. I also know from looking at other sessions that even Looker will also extend that, but that's for the Looker session, because there will be capability to connect to Google Docs, Google Sheets, and so on with the BI view of Looker. So that will be quite interesting mixture for it's called now Google Workspace, in fact, even not anymore G Suite as we used to call it. Yeah. Let's also ask and what's your favorite, Adrian? You can repeat the same points if you wish. Yes, feel free.
I would like to shed a little light on Cloud Data Fusion service. It is ETL service for batch processing, missing till now on GCP. We had data transfer service, but it required prepared and already formatted data. It is point and click, code-free kind of service, so it seems to be good also for non-strict technical users. The theory of letting users with no experience to implement and run ETL pipeline is appealing. However, the reality is that you will end up trying to understand Hadoop debug logs and opaque error message just because pipelines of Cloud Fusion are run on a Cloud Dataproc. So every time you run a pipeline, you first need to wait for Dataproc cluster to spin up, and it takes some time.
We already use it in several projects. I know it from some of the colleagues of Lingaro. So that's like nice packaging for the lower stack of Dataproc, right? So this is more visual, have plenty of connectors and so on, right?
Yes, the point price is, I think, interesting here, because a basic edition instance costs $1,100 per month, and I believe it is a little too expensive for small projects. But I'm really glad that Google provides ETL service now, and I'm looking forward how it's going to be developed.
Yeah. I learned also that this product is currently for nice big enterprise deployments, more visual, and the pricing comes with it. But they also try to limit that to really second billing case. So this could be also for smaller projects, I think, in the nearest future. Gentlemen, thank you for your comments so far. I think we are gonna move now to another video, which I have on the list. What's new in BigQuery, Google Cloud's modern data warehouse? There will be much more interesting deep dive discussion after that. We will see each other at round about 10:50. So thank you. I'm getting back to share the video now. Just give me a second. Little bit of change of the landscape of my playlist. Let's move to share that screen with the videos, and let's start. Let's rock with the video.
Dependability. At Google, we believe in building these large-scale services. Welcome everyone to What's New in BigQuery session. I'm Sudhir Hasbe. I'm the Director of Product for Smart Analytics Platform at Google Cloud.
And I'm Tino Tereshko. I'm a Product Manager on Google BigQuery.
So at Google Cloud, in the Smart Analytics team, our vision is to give you or provide you with an enterprise class data platform with proven dependability. At Google, we believe in building these large-scale services that can meet all your security and trust needs. So we basically have been focused on that. In addition to that, we are also about being open and flexible, providing you with choice. And finally, and most important, we want to embed intelligence across the whole platform. So that's our primary vision in the Smart Analytics team. Let's talk about BigQuery first. Google BigQuery, it's now 10 years old. In June, we celebrated the 10th anniversary of BigQuery. BigQuery has customers from few terabytes to hundreds of petabytes. It's a completely serverless technology. What do I mean by that? It means you don't have to worry about any infrastructure pieces. Just bring your data and start analyzing, start writing queries on it. There is no monitoring, there is no administration, there is no machines, there is no nodes, there are no servers that you need to worry about. So most of that is managed by Google. We take care of all of that for you. The second thing, we are highly differentiated. We provide you capability to ingest tens of millions of events in real time into BigQuery. And a lot of organizations like King, which is a gaming company, they have in-game events that happen and they want to stream that in real time so they can analyze what users are doing on their platform. So it's possible. And when you ingest large-scale events, it does not impact your query performance on top of that data, because we completely distribute or decouple our compute and storage layers. In addition to that, we have embedded machine learning capability where you can write SQL commands to create machine learning models and get advanced predictions. And finally, we don't want insights to be limited to few in the organization. We want insights for everyone. We have made a lot of investment in this space where BigQuery is being used by organizations like AirAsia, where they were able to reduce their operational costs in an airline by 5 to 10% by making those insights available to everybody in front lines so that they can make better decisions. So those are the key capabilities that we provide. One thing that BigQuery is great at is scale. We are really powering some of the largest of the workloads in analytics space. Our largest customer has more than 350 petabytes of data in the data warehouse. One of the largest queries that was run was roughly 100 trillion rows that were queried in a single query. And we have seen up to 10,000 concurrent users being used by one of our customers. So concurrency at a very high scale is also supported in BigQuery. Let's talk about HSBC. It's a systemic bank. It's highly regulated. HSBC uses BigQuery to run a lot of large-scale analytics for a lot of regulatory reporting and all. One of the key things that we were able to do by working with HSBC is provide a lot of security capabilities in BigQuery, like CMEC, that's Customer Managed Encryption Keys, Virtual Private Connect. So all of these VPCSC, all these capabilities we built with HSBC. They are proven. They're used by some of the largest banks in the world. In HSBC's case, they bring data from 40 plus countries, all transaction data. They put it into their data lake / data warehouse with BigQuery. They analyze all of this data, and at the end of the day, they have to report to regulators about the viability of the business based on all this data. And all of this is running in few minutes, which used to take I think 30 hours on-prem systems and stuff like that. And you have to do this every day. So with 30 hours, you cannot go ahead and report every day. So on BigQuery, they can do it in a few minutes, and it's allowing them to scale their business.
So BigQuery is much more than a data warehouse because we have so much advanced capabilities. But one strength of BigQuery is the fact that it is a part of a tightly integrated, broad, smart analytics platform that includes services like Dataproc, Data Fusion, and even Looker. And actually, the vast majority of BigQuery customers are using a number of these services together with BigQuery. And Sky UK is one of them. Of course, Sky is a broadcaster, and they provide these enhanced set-top boxes that communicate data directly to PubSub, Dataflow, and BigQuery for real-time analysis. What that enables Sky to do is to really understand the customer deeply. They're able to visualize what customers are doing, what they're watching, their preferences. They're able to tailor, customize content and advertisements, so on and so forth. And they even can do research on customers by doing A/B testing.
And if you look at the growth of BigQuery, we have seen tremendous growth in last year or so. We have customers across every industry vertical, across every region in the world. We have large customers like Home Depot to UPS in United States. We have HSBC, we have Sky, we have King, we have various different customers, Metro, Ocado in EMEA. We also have customers in JPAC region like Fast Retailing Group, ANZ Bank, and Gojek and AirAsia and all. So we have seen adoption across the globe by different customers with different kinds of use cases and scenarios. So for today's roadmap session, what we did was we've taken some of the key highlights in the roadmap, and we're going to share them with you. And we're going to do this across the 3 value pillars that we have, being open and flexible, intelligent, and with proven dependability.
Let's start with proven dependability. HSBC and Sky, of course, multinational corporations that put their trust into BigQuery to drive their business forward. So we really need to take care of our customers in this area. And so what we think about it is we enhance dependability in 4 areas: availability and uptime, administration and control, performance and just query execution, and finally, trust, security, and governance. Today, we're announcing the fact that we are enhancing our SLA by an additional 9. So now there's 4 nines availability that we guarantee. Right? We're doing this free of charge to all of our customers. There's no special rates that you have to pay. The reason we're able to do this is because we have serverless architecture. It's very advanced, radically unique architecture that does guarantee against downtime in specific circumstances. So this 4 nines of availability is really only about 4 minutes of downtime per month, or less than an hour per day. And you note that it is actually industry leading when it comes to cloud data warehouses. All other cloud data warehouses only offer 3 nines of availability. And of course, we care about performance and our customers care about performance. So we started running this query in the last few years to demonstrate the power of BigQuery. This is a query that is a simple point lookup, but it is a query on an entire petabyte worth of data. So in 2016, when we first ran this query, it executed in about 6 minutes and it scanned the whole petabyte. In 2018, a couple of years later, we executed this query in just 2 minutes, and it actually scanned about 400 megabytes. Today, if you run this query in BigQuery, you will notice that it takes about 4 seconds to run. And the best part of all is that you didn't need to do anything special. You didn't need to pay anything extra to start getting this better performance. We just upgraded your service for you seamlessly without any downtime, and you just got better performance. In fact, just in 2020 alone, from the beginning of the year, we've made major improvements to all the typical industry standard benchmarks. This is a TPC-DS benchmark, and we're looking at the geo mean of performance. So both for 1T, 10T, and 30T scales, we improve performance anywhere from 20 to 30%. And again, you just get this performance as part of using BigQuery. You don't have to do anything, and it just happens. So we have a number of customers in all kinds of areas. And of course, sports leagues and sports teams are taking advantage of BigQuery. Major League Baseball being the newest one. There's a breakdown, DA204, that talks about the journey that MLB took to kind of re-platform onto BigQuery. Well, the first thing they noticed when they started using BigQuery is the fact that they're able to give this information, to give analytics to all the key stakeholders within Major League Baseball and the teams that are part of the league. And they're able to do this in real time, right? They don't have these bottlenecks anymore. At the same time, they're getting performance that's significantly better than the previous platform. And finally, it's very, very easy for them to manage this, right? Because BigQuery is serverless, there's really not a lot of things for them to worry about, and they really like that. So we talked about how BigQuery is serverless, it doesn't require administration. That said, the more customers we have that are multinational, that are complicated, they have lots of business units, the more they're asking for better control, better predictability, better visibility, right? So we've made significant investments here. Just in 2020 alone, we've launched a number of improvements to BigQuery. The first one being reservations. Reservations is an enterprise-grade workload management platform that allows you to achieve predictable pricing and to make sure that all your workloads are executing under the proper SLAs. And it's super efficient because it's using idle capacity. The next enhancement is flex slots. Flex slots allow you to purchase capacity just for a few seconds at a time, and you can cancel them anytime. You essentially get instant capacity to meet your workload demands. And for the classic database administrators out there, we've made a number of enhancements as well. One is information schema. These are just tables that contain metadata relevant to your service. We've made enhancements to data types, and we've made improvements to SQL dialect as well. I'm really delighted about this feature. It's coming in the next few months. BigQuery slot auto scaling. So this kind of combines the best of both worlds, right? You're getting the price predictability of slots-based pricing, and you get like the low management overhead that's associated with our on-demand model. BigQuery slots auto scaling allows you to configure your scaling limits and your spend limits, and BigQuery takes care of the rest. We'll simply scale up and down your workloads depending on what you throw at BigQuery. So some of the things that are really relevant about this is the fact that this supports the auto pause and auto start mode. So we can go from 0 to full scale and back to 0 if you'd like that. Because we are not powered by VMs, you get a lot of additional advancements. So for example, we don't have this pre-warm period when you're not getting optimal performance. The second you get your capacity, performance is at 100%. Also, if you have queries in flight, queries that are being executed, you can add capacity, and those queries would immediately start taking advantage of that, right? So you can accelerate queries in flight using the BigQuery slots auto scale. Because we don't have VMs, we're not powered by local disk, right? So we don't have those local disk bottlenecks. If you start running out of local disk, you start getting performance cliffs that are unpredictable. They're hard to monitor for and hard to document. We don't have such problems, right? We always have hot data for you. And finally, we kind of already talked about this in the SLA slides, but we can provide a high level of reliability because we're immune to individual node downtime. In fact, a huge portion of a data center can come down and you're not even going to notice that. The next feature we're launching in administration in the next 2 months is admin panel UI. Now we have Stackdriver for monitoring, which is incredibly powerful, but our customers want us to also have BigQuery native monitoring capability. So admin panel will provide you with the ability to monitor your queries, your slots, your resources, your spend, your workloads, and your users right in BigQuery from BigQuery. This will have a real-time component to it, so you can see what's happening right this second, and you can go back in time several weeks and months. So how are you going to use admin panel? Well, you're going to be able to figure out how your organization is using BigQuery in general. Who are your top users? What are the types of queries they're running? And you're also going to be able to perform real-time root cause analysis whenever things go wrong. Maybe there's a for loop that went awry. So you want to catch that and you figure out what's going on and move on. Customers always ask us, you have all these pricing capabilities, but how do I choose which model to use? Which one is the right one for me? And you know, how much capacity should I purchase? So we're launching BigQuery Slot Recommender. With BigQuery Slot Recommender, we're going to run this intelligence, and we're going to send you insights automatically that will actually recommend whether you should be on the on-demand model or whether you should be on the slots model. And of course, we're going to do this without sacrificing your performance. So if we're going to tell you that there's a recommendation out there, it's going to recommend you to save money without actually sacrificing performance. So we talked about availability, we talked about administration, we talked about performance, but probably the most important aspect of BigQuery is its security, right? Our customers trust us with their data and their workloads, and we can't fail them. So we have a kind of a three-pronged strategy here. The first one is BigQuery is a part of Google, and Google employs thousands of the best security engineers in the world. They're working on security on custom hardware, networking, penetration, so on and so forth. And BigQuery gets to benefit from all of this innovation. Right? That's the beauty of BigQuery. And that's the first pillar. So you just get a high level of security automatically with BigQuery. The second pillar is the fact that we're giving you a number of controls and configurations and services that enable you to customize how much security you want in your environment. Things like Sudhir mentioned, customer managed encryption keys, virtual private networking. But the key to this component is data catalog. Data catalog is a metadata management and discovery service that we launched recently. So imagine your data coming into Google Cloud. Data catalog can automatically index that data. Then the data passes through data loss prevention API and removes and tokenizes PII information and private and secure information. And then you can apply tags and policies to this data and grant access to the right levels of data to the right users inside of your organization. So it's a super flexible, super powerful platform for data management that allows you to really control how your data is exposed internally and externally. And the third pillar that's critical to our success here is the fact that we're working with all the relevant agencies to achieve these audits and certifications, right? So if you're storing medical data inside of BigQuery, you know you can trust us because we have HIPAA certification. If you're storing financial data inside of BigQuery, you know you can trust us because we have PCI certification. If you're doing business in Germany or Singapore, we have proper credentials as well. And with FedRAMP, we can do business with government.
With that, now we talked about proven dependability. Let's switch gears, talk about the intelligence. One of our key capabilities in Google Cloud is, of course, our capabilities around machine learning and AI. And we're going to talk more about how we are enhancing our embedded machine learning capabilities that we are providing with BigQuery. We'll also talk about some real-time analytics improvements that we have done. But before that, let's talk about democratizing insights. One of our key value pillars in Google Cloud is we want insights for everyone. We want to make sure every individual person in an organization can get access to the insights that they want. So in this realm, the first thing that we are doing is our refresh to BigQuery UI. A lot of our customers have been asking for capabilities in BigQuery UI, like multi-tab editing. We are adding that, so it's now available for everyone to use. It's a really great experience where you can write multiple different queries, compare them, but more importantly, you not only write SQL for BigQuery, you can also write Dataflow SQL and create streaming pipelines with PubSub and Dataflow in combination with BigQuery. So it does allow you that integrated experience. It's a faster IDE. One of the other features I like is this autocomplete for me, so it can recommend or suggest what are the table or fields that I should be using and stuff like that. So a lot of innovation and investment going in that space. And the second thing, I'm super excited about this feature, which is connected sheets. Connected sheets is literally, think about Google Sheet in front of BigQuery. You can have petabyte scale data sets in BigQuery. You can use Sheets to go ahead and create pivot tables, charts, functions, and custom calculations on top of the sheet. And then all of that actually runs on top of BigQuery. So it's best of both worlds. The great experience with great analytical engine. I personally use this every day. I have a 29+ billion row table. I analyze data from that every day about our product usage, what's working, what's not working, and all. So really, this makes data at scale accessible to all analysts who can use spreadsheets within your organization. So really powerful tooling. But with that, we don't want to stop at analysts and just a few folks in the organization. We want to extend insights to everyone else in the organization. With that, we are announcing availability of data Q&A. Our data Q&A is natural language interface for BigQuery. You literally go ahead and ask a question, get an answer. It's as simple as that. There is no setup required on top of BigQuery for leveraging it. You just enable an API, pick the table that you want to go ahead and ask questions on, and we just make it possible for you. So you can just start leveraging it. We also believe that no one interface is the right interface for technology like this, right? I think organizations want to build custom workflows and custom experiences on top of such a technology. So we do have the whole API available for data Q&A, where organizations can literally build their own experiences. But from Google side, we will be integrating it in Google Sheets with connected sheets plus data Q&A. Now you have a very powerful experience. We will be providing chatbot experience. We will be working with a Dialogflow and various other experiences that we can provide directly, including BigQuery UI will have a version of this. All of this is actually built on internal Google technology called Analyzer. There's a great paper that you can read more about it on. But fundamentally, this is the same technology that powers Google Assistant and various other services and products that we internally use. Analyzer gives us ability to go ahead and do question parsing, intent identification, entity matching. All of that comes because of Google's investment in this space of natural language, conversational understanding and all. And we're just leveraging parts of that. We are on BigQuery side, making sure that works really well with your custom data sets, and we can make it easy to go ahead and get started without doing that much of preparation and setup on your data sets. Let me switch gears, talk about embedded machine learning. One of the key values that we have in BigQuery team is we want to bring computation to data, not the other way around. We don't like moving data, copying data. That's not the best way of running large-scale analytics. And so in the same realm, 80% of time data scientists today are spending in data preparation, according to some studies. We want to avoid that. With BigQuery, what you can do is you can just use 2 lines of SQL to create machine learning models. You literally say create model name of type X regression, matrix factorization, whatever you want, and then give the input data set, and we will do everything for you on that. We do internal hyperparameter tuning. We take care of the whole system on the back end. When we launched a couple of years back, we only had regression and logistical and linear regression models. From there, we have come far ahead. We now support k-means clustering, matrix factorization. I've seen a lot of organizations use this in combination. They do customer segmentation using k-means clustering. They do matrix factorization to find products that we should recommend to those segments. And they basically done email campaigns and ad campaigns on it. So very common pattern. You can use this for. In addition, we've also launched time series forecasting. This is great for inventory optimizations and stuff like that. So we've seen a lot of interest in this model. But in addition to that, we have enabled BigQuery ML to be the SQL interface for a lot of our capabilities in Cloud AI. So DNN classifiers, XGBoost, and AutoML tables all are using Cloud AI platform services behind the scenes, and you still get the same consistent experience that you have. But most importantly, a lot of our customers said to us, hey, all these models, creating them easily and running batch workloads is great, but I would love to use these models in real-time predictions. How do we enable that? And so we have enabled you to go ahead and export these models directly into TensorFlow model. And so you can export it as TensorFlow model and then host it in any of the serving platform that supports TensorFlow, which will be ML Engine, Kubeflow. There are various platforms that are available that you can run this. With that, we covered the democratizing insights, especially with data Q&A and connected sheets, embedded machine learning. The third area of innovation that we have spent significant amount of time is in real-time analytics. As I earlier mentioned, we have customers that are putting in like tens of millions of events per second within BigQuery. And just this year, we rewrote our whole storage engine from like a batch first mode to a streaming mode. So it's a streaming first storage system now, and we can scale to any of your needs. Tens of millions of events per second is without any problem. The more important is none of your queries will have any impact on performance because of that ingestion rate. So we can do tens of millions of events and give you the same query performance in the real time when that's coming. The second thing is materialized views. When you have a lot of these data changes happening batch or in stream, you want to materialize your data set and views so that you can easily power the dashboards and reports that you may have. All of this is automated in BigQuery. Once you create a materialized view, as the underlying data changes, we persist it in the materialized view for you. What that means is you don't have to worry about scheduling these. You not have to worry about when was the last update made to the base table, but nothing like that. We will always keep it consistent. And most important is query rerouting. What that means is if you fired a query to BigQuery and you created a materialized view later and you had this historical query, we will automatically take that query. Our query parsing engine will realize that you have a new materialized view which can make the query run faster, and we will automatically leverage that. So that's there. It's available in beta for you to use now. BI Engine is another third investment in always fast, always fresh theme for us. BI Engine, we launched the BI Engine last year working with Data Studio so that we had an integrated experience. We wanted to test the technology, make sure it can scale to global needs and all of that. So I think that is there. It provides you a sub-second latency query capability. It automatically tunes your queries as they come in and all. But more importantly, in this year, we are going to extend that capability of BI Engine, which is our in-memory caching engine, to all the queries in BigQuery. So when the query comes in, it will be able to leverage BigQuery, even from a standard BigQuery interface. In addition to that, all your JDBC, ODBC drivers will support it, and also all of our BI partners like Tableau, Looker, Sisense, Domo, Power BI, all of them will be able to leverage the BI Engine capability that we have. You just pick what your size of cache is and everything will automatically work. And then, and also one of the other things we will support is star schemas so that all your BI workloads are taken care of. Extending that, if you really think from a stack perspective, you as customers today now have a choice. You can decide whether you want low latency or you're okay with relatively higher latency, and you can decide how much you want to use on the very hot data with caching with BI Engine, or you just want to create materialized view, which we will keep fresh all the time, or you want to just use partition tables or just go to the storage layer directly. So all of this is a choice that you have. But you write a query, we will automatically first try BI engine. Not there, go to materialize view. Not there, go to partitioning and clustering. If not, go to the core storage, however the data is stored. So that's the key thing that we've been working on. You will always get the best performance at the best price, so you can pick and choose what you care about. With that, we covered intelligence and proven dependability. Let's switch gears and talk about open and flexible. This is another big theme for us. We'll cover like BigQuery everywhere, flexible pricing, as well as data platform interoperability in this. Let's talk about BigQuery. BigQuery everywhere. We are introducing BigQuery Omni. What is BigQuery Omni? As I earlier said, we have this theory or vision in BigQuery where we like to bring compute to data. And a lot of our customers have data not in GCP. A lot of them have data in AWS S3, and maybe other customers have in Azure. So with BigQuery Omni available for AWS, we will allow you to write queries and execute and do analysis on top of the data that's stored in S3. What does this mean? We will literally run our compute engine or computation engine of BigQuery in AWS closer to your data. And what that means is you don't have to worry about paying for this egress charges or anything. So you may have tens to hundreds of petabytes of data in S3. You can start writing queries with the same interface in BigQuery, with the same SQL dialect that we support, as well as and run it on AWS. So you'll be able to do computation in that and then get access to the results. There are 2 or 3 different kinds of use cases that are becoming really prevalent in this. A lot of our customers do have split mode. A lot of our customers use BigQuery and GCP, as well as they have data in S3 and AWS. This is going to allow you to have a single interface to analyze data across clouds. And as I said, we will be bringing out the BigQuery Omni for Azure in coming quarters. So that will extend it to that platform too. So that's one. The second use case that is becoming pretty prevalent is I've been talking to large customers who have tens to hundreds of petabytes in S3. They don't use GCP today, but they're intrigued with our capabilities like the BigQuery ML, embedded machine learning capability, and they want to use it. And so in this case, what we can do is we can enable those organizations to do data preparation, summarizing the data, identifying the key data sets that are there, and then just move the data that you want to run machine learning on to GCP in BigQuery, and then run those machine learning models, do advanced analytics with it. So those are the different kinds of use cases we are seeing in the early adoption that we have seen. We are learning as we go, and we would love for you to request access, get access to this technology, and would love to co-innovate with you in this space. With that, let's talk about pricing.
So we talked about how BigQuery has some of the largest use cases in the world. But what's interesting is BigQuery probably also has some of the smallest use cases in the world. And it's really because we built our system to be scale invariant. And we built the right pricing options to support that kind of the gradient of scenarios. So no matter where you are in terms of scale, capability, and requirements, we're going to have the right pricing options for you. So we do have a perpetual free tier where you get 10 gigabytes of storage for free and a whole terabyte of query processing for free, no strings attached. And we have pay-as-you-go pricing, which is serverless pricing, incredibly efficient. You don't have to think about anything. But as you kind of graduate and become bigger and bigger, you start caring about additional capacity, you start caring about price predictability. So we have flex slots there that are recently launched. And then all the way out to the largest use cases. If you really care about efficiency, you care about price predictability, and you're working on these types of annual budgets, we have flat rate pricing for you. So wherever you are, BigQuery is going to have the right pricing options for you. And of course, you're not just using BigQuery. Typically, our customers are running Spark workloads, data pandas, data frames, other types of execution engines. And at the same time, they keep their data in other places other than BigQuery storage, right? So whether it's MySQL, Postgres, Cloud SQL, it could be potentially Bigtable, it could be Google Drive, and it could be open data lakes like Parquet and Orc. So we provide interoperability with all of these layers. So BigQuery Storage API and its ecosystem of open source connectors allow you to run Spark, Pandas, MapReduce, and other open source workloads directly on top of BigQuery storage at high levels of throughput and parallelism. So it's as if you're running these workloads directly on open storage, directly on HDFS without sacrificing performance. It's a very unique and differentiated capability of BigQuery. Now, if you want to leverage BigQuery SQL, but your data lives outside of BigQuery, we provide that capability, right? So Cloud SQL Federation allows you to, in real time, access data in your relational databases from BigQuery execution engine using your familiar BigQuery SQL. And of course, we support Parquet and Org Federation, which means that you can run BigQuery right on top of your data lakes. And finally, your data may be living in these other service providers like Stripe, Marketo. Maybe you have Google internal data sets that live within AdWords, within YouTube, and so on and so forth. How do you get that data into your data warehouse so you can enrich it and you can join it against your other relevant business data? Well, we provide hundreds of connectors that are very, very easy to configure, very easy to set up, and we take care of the rest. Right? Once your connection is set up, we simply move that data into BigQuery on your behalf, and now you can do advanced analytics on it.
Perfect. And this is just a subset or summary of all the different capabilities that we are announcing. We know there's not enough time in 30 minutes, so 35 minutes for us to cover everything. There is a lot of other sessions. There are 30 plus sessions that are happening, so that you should be able to get deep dives into all of these different topics, as well as hear more about different aspects of the roadmap. I do want to highlight one of the ESG studies. BigQuery is providing the lowest total cost of ownership for our customers across the globe. I will highly recommend looking at the study and then trying BigQuery out. And finally, we are the leaders in all the different magic quadrants from Gartner as well as Forrester Waves over the last couple of years. This is one example. But one of the things I want to close today by telling you is when COVID-19 hit, I know the whole globe, everybody is fighting the new pandemic. A lot of organizations came to us. They wanted to get access to data, and we were able to go ahead and make 20 plus data sets available, globally accessible, shareable in BigQuery. We were able to go ahead and make all the computation on top of that free until I think later part of the year. The key thing is BigQuery does provide us this platform that we can share data, share insights with the globe, not just within organizations. And then that's really a great feeling from the team's perspective. We want to thank you today for joining us and hearing what's new in BigQuery. Thank you.
Let me go back to our live discussion. Small reconfiguration of the screen. Just a moment. We are joined by Marek, Michał, and Adrian for some of the discussions for the session about BigQuery. Just a second, guys. I want to show a small sketch note around that, which I've prepared during the video watching. So to capture quite nice announcements in generic announcements. 99.99 SLA, which beats competition, which doesn't have the last 9 in their SLA. Much faster performance. You have to do nothing. They go forward with that. Interesting changes in pricing. We will probably discuss that as an important point. Auto scaling of slots, and once more a list of interesting things. I'm missing one now. I realize myself. But it's Omni, it's the data Q&A, so natural language interaction with data which is there. Much more machine learning modeling inside BigQuery. You don't have to go outside. Streaming goes into newer capabilities. You can embed within the streaming pipeline Also AI, materialized views as something which brings more speed, BI engine, capability to power up your BI infrastructure of Looker or Tableau or any other tool in the future. And the point which I missed, quite interesting, ready to go connectivity, data transfer possibilities. These are the points, and back to the team of our experts. We were chatting in the meantime during the video watching, and now you know what kind of things we will discuss with you. If Michał, you said quite interesting things about pricing. Could you share a little bit with us on this?
From my perspective, one of the biggest advantages of the cloud computing solutions is the flexibility and scalability. So these are the factors you cannot so easily achieve with on-premise solutions. And now on BigQuery, it's easier to scale not only in the performance, but also in the pricing, with introduction of flex slots, which allows you to buy additional slots on demand and for very short periods of time, so you can boost your performance when you really need it. And also, if you don't want to have constant monitoring of your performance, there is a new possibility that will be announced, that is now announced and will be able to use in the next month. That is the slots auto-scaling. So you can set certain boundaries in which your solution will scale on demand. So you're only paying for this additional burst in performance only when you need it. So you're not throwing money on having the huge reservation slots only for the short amounts of time when you really need it. So some heavy daily jobs or monthly jobs, they are only scaling when you need it, and this is much more flexible in terms of the pricing of the overall solution.
Marek also stated in our internal chat that he got quite interested in the administration capabilities, new administration capabilities for BigQuery. Marek, what would you share here, something on that?
Yes. When we try to load and analyze data, there is, in most cases, there is a barrier to entry. Which I mean that the mostly used MPP databases are even if they are placed in the cloud environment, so still they require additional effort to set up, to maintain, to distribute data. You need to do some additional tasks as if you use typical on-premise database. So BigQuery entry is very easy. You just create tables, create your data set, and that's it. Yeah, you forget about all the administration tasks which are typically required. This shortens the way how the data could be pushed to the database and how the data can be analyzed. It means also that you initially don't care about the data location, about data distribution. All this stuff is in BigQuery engine, and it's built into a BigQuery engine, and it takes care of all the settings for you. So quicker and also faster.
I was also amazed by this, messaging that because it's serverless, because it's you managed completely day by day, they take care to increase speed, and you might even not notice that the query from year ago runs 2 times faster. Yeah, that's amazing. That's great. That's a great surprise. Yeah, because they don't do anything to pricing, but on the other side, you get more for that for a buck, right? For $1 or for €1. That's interesting. Adrian, we were chatting a little bit with you that you see interesting shift in the way how BigQuery is positioned in the Google Cloud stack.
I would like to add something about BigQuery use case from a customer perspective. BigQuery originally was a columnar database which was suited for receiving already processed, transformed, and cleaned data. It was designed as a source for a reporting tier with quick aggregations operations. Now BigQuery became also a processing engine, and we can effectively impressive here. And what is important, Google still fights against limits for BigQuery. For example, I will remind that for a few months ago, there was a limit regarding DML operations. It was allowed up to 100 DML statements to the table during any 24-hour period. Now there is no such a limitations. There is a concurrent rate limit for interactive queries instead. It's 100 concurrent queries, but this is something we can handle and live with. So BigQuery became effective solution, not only for aggregations, calculations, but also in transforming data, which I find really impressive in such a short time.
That's interesting. Thank you guys for sharing these observations from these announcements. I think looking at the clock and being aware of the setup and agenda, we already have Bartik and Magda waiting in the lobby of our stream to watch together Looker blog, 2 videos about Looker, and then we go into discussion. So thank you, gentlemen, for the moment. We see each other in the blog for solutions after Looker. So everybody stay tuned. I make a little bit of change of a setup of the scene. So thank you, Marek, thank you, Michał, and thank you, Adrian. I pull up on my screen the videos related to Looker. We will start with the video for, this will be a video named Looker's Roadmap. Let's watch it together now.
Hi, I'm Jamie Davidson. I run the product team at Looker. And today I'm going to give you a quick overview of what Looker is today and where we're going. Looker is an enterprise BI tool and data platform. We empower our customers to make the smarter use of data. On the top, you see the diversity of use cases the Looker platform can be used to power, from modern BI and beyond, and I'll talk about that in a moment. Looker's platform has a couple of key differences relative to the existing market. Our customers come with their data aggregated from a wide variety of sources into a cloud data warehouse. Looker has an in-database architecture that will leverage the functionality, scalability, and performance of technologies like BigQuery and enable customers to derive real-time data value from. We've got a semantic modeling layer on top of that in-database architecture where an analyst can come and codify their business metrics and enable an organization to have a single source of truth. That modeling layer is integrated with Git and version control and allows for governance. Looker is a cloud-native BI tool, and that means that everything you can do inside the application and more is accessible via API. That architecture has a couple of key benefits. First, data governance is built in from the ground up too. Because of the modeling layer, because of the integration with Git, our security, access, and authentication, you can have confidence that the metrics that your users or your business is using are what you think that they mean, and that the right people have access. That same semantic modeling layer also serves to empower business users. You don't have to know the complicated definitions for things like gross margin or lifetime value to be able to still make directional decisions based on that data. Looker's a cloud native application. Every URL is shareable. It means that you have easy, repeatable analysis. Because we have an in-database architecture, we are representing what's live in the database today. And that in-database architecture allows for operational use of your data, because customers are now replicating their full transactional information into a cloud data warehouse. You can not just look at the high-level KPIs and where they're trending, you can actually see the individual transactions that are driving. Over 50% of our customers now are actually using the Looker platform beyond API context. To give you a couple examples,
as I see some reports that the video is streamed not so fluently, let me cross-check if all is good. Maybe I will redo the sharing. Let's see if this improves. Just give me a second. Small delay. I need to look how this goes. Finally, something is not as perfect as I thought it will be, but maybe now it will be better. Let me play back the video from the moment now.
We see customers using us to have embedded dashboards in internal portals so that their knowledge workers can use data to make better decisions. We see customers embedding dashboards into SaaS tools like Salesforce so that the salespeople can go and have the relevant information while they're making their decisions. We see customers integrating us into existing products and even creating completely new products to give value to their customers and at times monetize data. And then finally, we see customers going so far as to use Looker effectively headlessly, so not using any of our UI or UX, integrating with our APIs to provide governed data into custom applications. These applications don't look or feel like anything that classic BI would suggest. It's beyond reporting and self-serve analytics. It's really operational. So for example, maybe a supply chain management application where the historical inventory levels and pricing is useful, and Looker provides a governed view of that into that application. So Looker's different. We have a different architecture too, and it gives it some benefits. We are fast on any size of data. We're leveraging BigQuery and Snowflake and Redshift to be able to give you real-time access to their powerful functionality. The semantic model means that there's a single source of truth for your organization too, and it gives the business users trust in the data. That model is integrated with the development workflow too, that lets you have changes over time and a life cycle and management for those workflows. And finally, Looker is a cloud native application too, which means we've got APIs to integrate with lots of operational tools. We want to be where the users are working. That was a quick look at what Looker is today. I want to tell you about where we're going. We talked just recently about the breadth of experiences that we enable, or use cases that we enable. We think about the ability to serve those use cases in three real layers too. So the top layer is data experiences. This is where the business users are consuming data and taking action on it. Below that, we got our application platform too. This is what enables our customers to create those data experiences. And then finally, the base really here is Looker's foundation. This is our development lifecycle. This is our ideas, this is our query execution. This is the core of the app. So to start on data experiences, I'm going to talk quickly about our core, the core unit of a report for Looker is a dashboard. I'll talk about how we've completely rebuilt that dashboard stack, and how we're similarly now reimagining that the core Explore experience, that self-serve analysis, the expression of the model as well. We'll talk a little bit about how we integrate into existing business workflows, and then finally close on how we help with content discovery. So I mentioned that we've been rebuilding our dashboard. We've basically spent the last year and a half completely rebuilding it from the ground up with a bunch of different goals in mind. We want it to be a more modern stack. We want it to be more performant. We want it to be more customizable. We also want to enable fundamentally new interactions and experiences that haven't ever been possible inside BI. And that includes things like cross-filtering at petabyte scales. Because we have an in-database architecture and we can take advantage of databases like BigQuery, we now have an interaction mechanism too that lets you get full granularity of your data, ask as many questions as you want of the content. When we rethought, the consumption of content, we also had to think about the creation of that content too. We want to give our analysts a whole lot more control over the presentation of their data too. We want to make it easy for them to create reports that you can easily derive insight from and ultimately take action on. And that includes things like fundamental new modes of consumption. Here you can see a new report type. This is closer to a Google Doc than it is to a dashboard. It's still integrated with the Looker governance. It's still integrated with our security model too. You can see it's infused with data. It's got a live look and visualization of metrics too. But it's presented in context too. And imagine you're an executive consuming a weekly PDF report emailed to you too. The analyst needs to construct it in such a way where you can easily derive insight from it too, in a way that you'd expect. So this can allow that. We're also increasing the amount of customization as possible inside dashboards too, with new dashboard extensions where you can take over a tile of a dashboard too, with pre-built extensions that are present inside our marketplace, as well as custom extensions that you build to allow you to create custom experiences and workflows to tailor to your data. We're really excited about bringing Looker more broadly to as many people as possible. That includes doing work like localization. We now support 23 different languages too for our core reporting use cases. We are in the process of bringing all of that localization to the full application. Similarly, we're looking at accessibility as well too. We want to make it easy for Looker to navigate for all users too, so that everyone can derive value from it. We're looking now at exploration too, and Looker's Explore has always been an incredibly powerful feature. It's the manifestation of that semantic model. It lets you ask lots of questions of your data too. We want to make it even easier. We want to make it so you have smarter starting points, so pre-built queries to start the question and answering process. We want to make it so that you can do on-the-fly calculations and not have to go into the model to create new metrics or dimensions too that are just transformations on existing ones. We also want to take advantage of GCP's best-in-class AI and ML functionality too, and integrate some of that into the BI tool so that you'd have things like time series forecasting too integrated into the Explore experience. We want to bring data to wherever work is being done at a high level. We want to drive more value. That requires things like our alerting functionality. We've got analytical alerts that use data to power workflows. We want to make them even smarter. We want to use that same AI and ML expertise that GCP has to do things like outlier detection, where a analyst can come in and say, this metric is important to me. Let me know if it changes and maybe tell me why. And we can do that, and we'll be bringing that in. We want to make it easy to take action directly from within the BI experience. So this is building on our Action Hub, which is tightly integrated with our semantic model, and it allows for interaction and integration with third-party services. So in this case, you could have complex analysis inside the BI tool to find overperforming campaigns too, and then take direct action to change their budgets or change activity inside the Google Ads platform. We recently released an integration with Google Sheets. We're really excited, and customers have adopted it incredibly quickly because they want to take governed, trusted data into a context sometimes where they want to have some lightweight ad hoc analysis. analysis to customize the experience. We're excited about this integration. We want to bring it forward. We want to do a bi-directional integration where Google Sheets can basically pull Looker data in and Looker can send data into Google Sheets. We're also excited about integrating with the broader G Suite products. We've got lots of customers that create, slideshows that are weekly operational reports where they go through a process of downloading a bunch of images and reconstituting that slideshow or deck every week. We want to make it so that you have live access to governed data in the context where you're working to enable that data storytelling within slides or similarly within Google Docs. We've got a deep integration with Slack where you can send data from Looker into Slack and request data of Looker from Slack. We want to make that interface of requesting data even easier in that communications context too, extending to a natural language interface to that semantic model. We're really excited about a new native mobile app experience we've got for iOS and Android in beta today, and will be GAing over the course of the second half of this year, where you can consume your data on the go. We also want to expose that natural language interface in this context. It's not enough to have your content inside your instance, though. If you can't find it, it's not useful too. And we're really excited now that we're part of Google, the search company too, to really invest heavily in that content discovery. We're rebuilding our search infrastructure for a couple of goals, better performance, better relevance, but also with an eye to help with some of the fundamental problems that BI always has. If you don't have a piece of content, say you're searching for annual recurring revenue, you don't have a piece of content that's relevant, we can automatically generate that content too and give you a live look at your total ARR inside that search context too. The data experiences side, we are focused on reporting and self-serve analysis, integrating with your workflow and driving more value from your data. I'm going to switch gears now and talk about our application platform. This is where customers and partners build those data experiences. And we're very focused here on a couple of things. We want to help accelerate value for our customers. We want to increase both the customizability and power that's possible inside in embedded context, and also extend the platform. To accelerate value, we've released a marketplace that's in beta currently, where you can easily find, install, and manage pre-built pieces of content. So these can be applications, these can be LookML blocks, these can be data sets, these can be custom visualizations, and they will dramatically accelerate your ability to actually explore. One of those contexts and one of those data sets too is Google Marketing. We've had an application and a series of LookML blocks too that are targeted on the marketing use case. We're really excited to leverage the expertise in Google to push this really a whole lot further. We want to help our customers be able to gather all of their marketing data together, to analyze and find insights from it to, and ultimately take action on that data too within the BI experience. For embedding, we think that there's a spectrum actually of need for customization, and it sort of goes from, on one side, there's inside the BI tool, and there's customization that's possible inside a dashboard experience or inside an embedded dashboard experience where you have themes so that it can feel like the application it's embedded in. We want to increase the amount of customization that's possible in that context. Similarly, we've got our APIs on the other end of the spectrum too. And we want to both increase the customization as possible, but also give you more out of the box there too. So we want richer APIs, better SDKs for interfacing with those APIs too, and then even high-level JavaScript-based components too, so it's much easier to be able to create bespoke workflows too and customize. So as an example, here's a dashboard that's been themed so that it can basically fit it into an application to and feel native. We very literally took our new dashboard code base to and packaged up the new functionality and features to in a JavaScript component SDK, so that customers don't have to recreate filters or visualizations and integrate them with our APIs. They can instead take our visualizations and extend them and customize them in any way that might fit their specific work. We're investing heavily in our APIs and SDKs too, from documentation to more robust interactions as well. And we're also focused on extending what's possible inside the platform. We're really excited to talk about the extension framework. We've got a bunch of partners and customers that are excited about the potential here. The extension framework is the ability to host custom JavaScript in a sandbox environment within your Looker instance too, and have direct access to Looker's APIs so that you can leverage security and governance, and it's a part of the Looker platform. So there are lots of different potential applications. I'll give you a couple of examples to sort of to show what's possible. We've released our first extension in our marketplace too, in our data dictionary. This is closely integrated with our data model APIs too, which can show analysts and developers the data that's present and the definitions behind them in a simple, easy place. We've got a lot of partners and customers that are excited about creating custom ways to explore their data. Going beyond the pivot table metaphor of the Explore page, there are contexts where a more tailored experience actually makes sense. So in this example, the cohort tool, it's a very parameterized workflow where you select a measure, you select an aggregation place, you select the interval that you want to measure cohorts on, as opposed to needing the full canvas of a broad pivot table. Another example is actually a hosted notebook experience where you can leverage the power of Python integrated with the Looker API too, and go beyond what a classic Explore experience would be. Really excited about the application platform. We're focused on increasing the customization inside the embedded experience, increasing the performance there too, and accelerating value for our customers. I'm going to switch gears and talk about the foundation or core of Looker. Here we think about things like our software development lifecycle and IDE for the data developers. We think about performance. We think about transformations that can power that performance too, and how can we leverage the data model. Looker's always been tightly integrated with a development workflow, and we want to continue to push that forward. We want to have a full quality assurance process too in a single instance that allows for development, staging, and verification of development and production environments. And we want that to be inclusive of your LookML models, of your content, and even your transformations in database too. It's in service of driving some performance, and Looker's in-database architecture gives us the ability to actually drive performance in a layered approach. We can take advantage of best-in-class functionality of data warehouses too, and then also use BI context to help inform queries and drive more performant queries. We've got a bunch of customers really excited about aggregate awareness. We released it a few months ago, where you can create roll-up tables within Looker, and Looker's platform will have the intelligence to be able to dynamically optimize queries based on the questions or the query that's coming in. So if you're going for a granular piece of information, we can go to the full granular table. If you're looking for a summary, we can go to the high level. And to power that aggregate awareness too, we've been investing heavily in our transformations, so making them much more robust and more durable. We're focused on adding new functionality like the ability to actually incrementally load into your aggregate tables and integrating those transformations into Looker. We're taking a layered approach to performance and acceleration. We want to take advantage of the best-in-class functionality like BigQuery's BI engine inside the database. It's an in-database cache specifically targeting BI use cases. Similarly, we also have a new in-memory cache as well inside the Looker application layer that eliminates the need to do round trips to the database too when they're not necessary. We think about analytics, or we think about administration a little bit differently. We think about it from an analytics first perspective. We want to give you as much information about the usage of your Looker platform to help you drive data-driven decisions. And so you can use the actual query performance to help drive performance optimization. You can use the actual user engagement to help better captivate your audience. Looker's data model is the key reason why our BI tool is differentiated. It's that integration with the data model and understanding of the transformational logic that's present inside. We have a bunch of customers now using that transformational logic in other workflows or use cases outside of Looker. So we've got a bunch of customers now using stable roll-up tables too inside the database to power machine learning workflows, where they've got governed definitions of features for their machine learning training processes too that are governed by Looker but used in other contexts. Similarly, we also want to help further leverage the Looker model too, like we're doing inside the Google Sheets integration. We want to basically let analysts use the right analytical tools too on top of governed data. We think we create more value when you give governed trusted access to that data too, regardless of the context where it's being consumed. Looker and GCP firmly believes that customers have the right to choose. They have the right to choose the right infrastructure for the right problem. We firmly support that too. We currently support hosting Looker inside GCP, inside AWS, and we're actively working on supporting Azure. We are also very focused on security. It's a large effort inside our engineering and product teams. We've already got our SOC 2 Type 2. We've already got our ISO 27K and our PCI SKUs as well. We're actively working on additional security certifications too.
Hello, and welcome to Looker and BigQuery, Enterprise Digital Transformation at Sunrun. I'm Joel McKelvey with the Looker team, and joining me is Harish Ramachandraya from Sunrun. We're going to be talking about modernizing your data infrastructure and modernizing your analytics together to drive better business outcomes and to accelerate digital transformation in your organization. Now, this is particularly important now because we know that data-driven or insight-driven businesses are far more likely to succeed during a time of disruption like the one we're seeing now. They're going to be more profitable, have higher customer satisfaction and customer retention, and they're going to be able to drive better and more efficient operations, etc. So it's really key that we be successful with data. So then why are more companies not successful with data? And I think it comes down to, with all the businesses I've spoken with, this concern of balancing the maintenance, keeping the lights on, using the systems that exist already, with the need to innovate and update and build new systems or better systems going forward. And it comes down to a rapidly increasing supply of the 3 V's of volume, variety, and velocity of data, but also an incredible demand for data and demand for insights in the business. And keeping up with the 2 of those, particularly when you're maintaining legacy systems, can be a real challenge. Good news is that there's hope. With modern technology, data lakes and data warehouses have effectively become a single entity. That is to say, the massively parallel processing cloud-based database like BigQuery can be both a data lake and a data warehouse. So you no longer need a staging database, an analytic database, and maybe a data mart. All that data can be consolidated in a single location, which gives you a really nice source of truth for the business, simplifying data pipelines, making an analytics much more real time. And then when you take a modern analytics system like Looker and you connect it to one of these modern data warehouses, suddenly you've got data governance at scale. Data becomes very, very accessible. You free up your data team to do more and to focus more on that innovation. And you can operationalize data in new and very exciting ways to drive those outcomes you need. What we call these new ways of using data is data experiences. Certainly, all the organizations I work with are looking at modernizing business intelligence, getting better dashboards and reporting, making that simpler, making that easier. But there are new ways to use data when you're not spending all of your time on the infrastructure and analytics maintenance. And these new ways include putting analytics directly in the CRM or a chat application that your teams might be using, inserting insights directly into people's workflows right where and when they need them most to make better decisions, not just large-scale decisions in the organization, but even micro-scale decisions, say on a factory production line or something along those lines. So making data so operationalized that people consume it may not even know that what they're seeing is analytics outcome. And you can even build custom applications or use data in really new, interesting, and innovative ways to monetize data or drive those outcomes you're looking for. So one organization that's been very successful driving positive business outcomes with data is Sunrun, led by Harish Ramachandraya, who's with me today. And he's going to talk a little bit about his transition from an older infrastructure to where he is today, some of the pitfalls and benefits he's seen doing that. And I think you'll be really excited to hear what he has to say. So with that, I'm going to hand over to Harish. Harish, take it away.
Thank you, Joe. Thanks. So with that said, just a quick background about Sunrun. Sunrun has been been in the solar industry, #1 residential solar company. It's pioneered in the solar industry for quite some time now, and since then it has offered a number of products out there. And the latest being battery as a service, as well as the storage options. And just to keep it simple, what we do is essentially have the customers or the consumer buy electricity from at a discounted price than what the utilities would otherwise offer. But what we offer is a clean energy, environmental friendly, eco-friendly options. And so that's our mission. And if you look at our mission, is to ensure that we run the planet by the sun, right? So with that said, you could envision any of your company in similar profile to the company where you've been associated. You may be in the crossroads of a BI transformation, and Sunrun was no different a couple of years back. So you could imagine in most of the companies out there either have a monolithic transactional system, either an SAP or an Oracle environment, and then a number of other platforms in terms of marketing or sales platforms. And counter to that, you have BI applications where you essentially have locked into a license or an infrastructure or a support cost and skill sets and so on and so forth. And we were no different than that. Along with that, I think some of the business questions, what we were trying to address in terms of the transformation was, how do I justify the ROI, right? Or how do I do the transformation yet without doing the disruption in the existing side of the business? And within the engineering team, we were in the dilemma trying to figure out that, is it as simple as lift and shift of your data sets or the schemas from one environment to the other environment, or porting these pipelines from one to the other ecosystem, and are you really going to solve the problem, right? And certainly not, right? I mean, you want to take advantage of the newer platforms with better architecture and so on and so forth. So how did we solve that, right? So we embarked on a journey, right? 2 to 3 years back in trying to figure out how do we go about in transforming some of these problems. And some of the critical ones I've noted here, but I'm sure most of you can relate to this as well as it resonates among you, is time to market, right? From a business standpoint, it was very, very critical for us to work in close proximity with the business to be able to turn around some of their analytical needs and in a very short duration. And given the situation, right, the expectations was to build, deploy, and be able to execute some of these products in a very short duration. And given that we were operating in a capital and labor intensive market, it was very critical for us to be able to turn around some of these things. Also, the most popular one about single source of truth, given the number of integration points we have, each of the business units would have their own set of single source of truth or their own versions of it, and then the timings of it, which would never align and they would never come to an agreement. And so we wanted to take this opportunity to ensure that some of those business rules are encapsulated both at the physical layer as well as the logical layer for the senior execs to come into the forum and be able to align, based on the KPI or the same set of metrics what they have agreed upon. And so it was very prudent for us to ensure that that single source of truth is in good shape. And further to that is the infrastructure, right? And for those of us who've coming from the legacy platform or the on-premise side of it, having managed services was, the best thing to have, or we loved it, considering that, you're looking at the pipelines, you're looking at the infrastructure from a data warehousing standpoint to ingest data sets at petabyte scale, as well as from a reporting standpoint where you overnight have certain expectations to scale up the number of users and so on and so forth. And we certainly we didn't want to be in the business of capacity planning, right? And so that was very important for us to be able to overnight auto scale some of these expectations. The other thing was in terms of the cost aspects of it. And for us, it certainly mattered to figure out what are the kind of transaction some of these projects are undertaking, and what are the costs involved in it. Are we locked in? Is it flexible enough? Can we predict some of these cost aspects of it so that tomorrow, if the business needs to do additional investment, they have full transparency about what is costing us, and that level of visibility certainly would be helping us. And finally, the most important one is certainly the security and the compliance side of it, which is we've handled quite a bit of it. There's still a lot to go there in terms of the DLP, in terms of PII, and in the next subsequent quarters, we certainly plan to address that. So with that said, I would not go into the legacy aspects of it, but more on the current infrastructure, the architecture, what we have in place at Sunrun, right? So if you look at this, you're looking from left to right, and essentially you have a combination of various platforms on cloud, on-premise, as well as formats of these data sets in terms of CSV to API to JSON, all kinds of format. At the same time, you're looking at the data coming from some of these financial systems like Oracle. We have 2 ERP environments, and Workday production data sets coming from solar panels, and so on and so forth. And some of these data sets certainly have highly time sensitive from an investor relationship or the Wall Street information, as well as Workday, for example, has number of footprints in terms of productivity, and as well as traditional reporting and so on and so forth. So as these data makes its way into the target environment, which is the cloud storage, where we retain the raw form of it, we use number of components or variations of this in terms of data proc, data flow, and then Informatica predominantly plays in terms of doing the pipeline. And so the raw form which arrives at the cloud storage is almost like an audit trail coming out of the source system, right? You could trace back any of these transaction information. But subsequent to that is where we kind of take a 2-step approach in terms of staging the data, and then subsequently a derived table. Between the 2 steps, what we essentially do is to ensure that the change data capture gets handled in a very seamless manner, right? And in stage 1, and then subsequently, if there are any heavy transformation of the business rules, we incorporate it in the subsequent step, which is probably close to 20% of those elements get transformed. But by and large, we take advantage of the staging itself from a reporting standpoint. And so between the 2, we ensure that we are good to go from a reporting standpoint, right, from a physical layer, and start building the logical layer. And along the way, we also ensure that we make the best practice from a BigQuery standpoint, whether it's in terms of updation, making sure that it is cost effective, as well as establishing certain joins, because just in the nature of BigQuery, in terms of this being a distributed system, we want to make sure it makes really sense where it needs join. If not, we try to take advantage of the platform. And then we have certain homegrown open source orchestration engine, and then we have scheduler from an Airflow and other monitoring tools in order to maintain and manage these pipelines. And subsequently, it makes its way from a consumer standpoint, where we have Looker, which is our prominent reporting tool, not just from a visualization and report aspects, but also we take advantage of it in more like a data as a service. And that is something which we are in full thrust as we speak. Besides Looker, where I think close to 70% of the execs rely on some of these reporting aspects coming out of the Looker, there are other consumers. Like there are some cases where Google Studio makes use of it for quick turnarounds and POCs and so on and so forth. The AI and ML people, again, tap into the same data sets. And for them, it is a curated data sets. It is transformed. There's nothing much they need to do versus focus on modeling and take full advantage of what BigQuery can provide them from an AI and ML standpoint. And then the other consumers are your Anaplan or some of the planning systems, as well as we also provide the integration hub. So that's how the current structure. But if you really look at, there are a number of pipes or the arrow marks, which essentially they're equally prone for certain failures. And so we ensure that these are well managed, monitored, and taken care. And to give you a quick preview of the pipelines, the data warehouse, I'll just quickly go over that. So as I pointed out in terms of the double click, right? I mean, any failure in these pipelines can cost a wrong decision downstream. So we want to make sure that it is well managed. And so the footprint is close to around 700 or pipelines as we speak, and it is growing incrementally almost every month. The other aspects in this is the type of transactions we handle. It's not just the volume side of it, it's more to do with the complexity across the various data sources, as well as correlations of these data sets in order to write a good data story for some of the business units. You're talking of integrations between financial systems, Salesforce systems, as well as HR and so on and so forth to do some complex analysis from a cycle time, from conversion analysis, as well as the reporting coming out of the tax and financial systems. Besides that, we started at the cadence of 24 hours in terms of scheduling these data sets. That's got reduced almost to an hour every day. And so we run these jobs at a very high frequency on most of the environments, including ERP. Then just to double click on the BigQuery, again, this is more to talk about how we manage the slot allocations from a resource standpoint. Essentially, we have three segments here. The ETL, or in our case, we manage the ELT process, Looker from a reporting standpoint, and then the backend users who tap into the BigQuery. These are the three segments, but we also have the ability to prioritize. And in our case, we have Looker as the most prominent end user community to take advantage of it, and then the other slots come into picture. So that's the brief approach, and so far we haven't had any challenges in terms of resource allocation. And if you have to scale up, it's a matter of a few minutes. You could certainly scale it even further. So that's the aspects from a data warehousing standpoint. And then finally the reporting. Looker again has come a long way for us, and so as I said, it is not just reporting in terms of visualization aspects. We've taken it in terms of the hub and spoke models within the Looker community, where we not only enable the business users to do self-service reports, not just canned or building those reports, but also if you really look at the power users, we extend our capacity of development effort along with the business community in terms of enabling the data models, as well as exploring it and establishing certain metrics which the central engineering team may or may not necessarily address, but instead we have an opportunity to extend those spoke models into the business community. So overall, that has accelerated not only the development cycle, but also to bring in some of the SME knowledge which the business units can bring in and turn around certain POCs, integrate some of their data sets which we probably don't have visibility, and have a wider footprint and have a protocol to ensure, besides some of the automation in terms of testing these data sets, CI/CD process, and so on and so forth. So that's on the reporting side. And just to take it further, I just wanted to highlight one of the case studies. I know there are a lot of information about social media analytics in terms of sales conversions or marketing channels analysis out there. And so we thought of sharing some of the case studies from an Oracle financial standpoint, where we were having a pre-built ETL or a pipeline, as well as physical data models, star schemas, as well as reports coming out of the box, and something which we engineered it within the Google platform to ensure that some of these data sets, there are hundreds of these pipelines which are fairly complex in nature. As I said, it's not just the volume, it is the complexity in integrating various data sets. And in this example, the financials in terms of general ledger, accounts receivables, payables, we take advantage of it in order to arrive at the profit and loss statements. And it has been engineered homegrown at Sunrun. The other aspects which you can even take it further is you could easily integrate this into a demand planning system along with it, as well as a financial planning system, there are other aspects. If you're running a marketing campaign during a certain period, you could snapshot those information real time and be able to see if these are having an impact, right? Your campaigns, are they having impact from a dollar aspects in terms of conversions, and look at it within a particular window. We haven't certainly done it, but since we've taken care of the financial system, it's easily imaginable to integrate some of these data sets. And it is we have converted the entire financial systems as well as some of the other supply chain and so on and so forth on the Oracle financials. And you can easily relate this to an SAP environment where you're handling controlling and profitability, or yellow cockpits and LIS and so on and so forth. So with that said, I just wanted to quickly go over the certain monitoring aspects. On each of those environments, we have the ability to manage and monitor the GCP environment, the Looker, as well as load orchestration. And then these are the reports which we use out of the Looker to ensure that there is consistency in the data loads. If there are any failures or any exceptions, alerts, we have automation done in place to handle on an overnight basis, and not necessarily lose sleep over it. And there's more to go, but this is something which we handle on a day-to-day basis. And then one quick question on areas in terms of establishing that confidence within the business community was pretty critical for us. And so we put a lot of things in place or process in place to ensure that the business are looking at the very authoritative data. And the slide essentially speaks about how the reconciliation happens between the source system and the target environment. In this case, the production, if you notice, is in a fairly good shape. We run these processes along with the data loads to ensure that the number of transactions or any impacts on the metadata structures or any elements being introduced is reconciling between source and the targets. And as you can see, the QA is certainly out of sync, and essentially because there are no live projects in the current state, as well as on the dev environments where the work is in progress. So these are some of the things which helps establish those confidence within the business units to take it further. And just to give you a gist about the journey where we started, we started something like a phase 0 where we undertook our POC, and it was certainly not a lift and shift. Engaged with a number of partners, and then embarked on a full-scale development effort. And we took approximately a year and a half to cover 80 to 90% of the footprint from our legacy platform into the cloud. And we basically undertook certain user community which would gain more mileage and took advantage of the platform and certainly build those confidence. And then it was kind of wildfire at Sunrun to enable some of the business units, and that came extremely handy, and there was a lot of acknowledgement in Sunrun. And certainly today, most of the core reporting aspects comes out of GCP and Looker. And we wrapped up our project 100% into the cloud now. It's been a couple of quarters since we've gone live, and currently we are heading more towards the ML and AI initiatives, taking advantage of what the BigQuery platform can provide us in addition to the analytics. And just a final thought, or the takeaway, this is the final point. What we got out of our overall initiative was, how could we add business value back into, and this particular slide, if you really notice our legacy infrastructure or the legacy environment of your infrastructure, as well as data modeling aspects and the reporting enablement. And we've reduced in some of the areas close to 70%, 80% in terms of life cycle. And certainly those are the business benefits which we can give it back, and it has certainly increased our footprint. And it's been an extremely successful run at Sunrun. And both with great partnership with Looker and BigQuery, we were able to achieve this in a very short duration. I just wanted to thank my team, BI team at Sunrun, and certainly my boss, Naren, for providing the support. He heads the engineering team, but for him, we wouldn't have been here. And so thank you all, and I hope you have some takeaway from these initiatives, both from Looker and the BigQuery standpoint. And I'll be certainly here to field any questions and answers. Thank you.
So let's shift gears a little bit. I will remove that screen sharing for a moment. Welcome back. We are after watching together two videos about Looker Roadmap 2020 and beyond, and a story from Sunrun, how they did digital transformation using Looker also. Let's go now into that discussion. Together, joining me on stage, Magda.
Hello, hi.
Kurlanc. Hi, Magda. How are you? Say something.
Hello, everyone.
Perfect. And Bartek.
Hello.
Our...
Hi. Good morning, good afternoon.
Hi, guys. How do you like it? How did you like it so far?
Yeah, I mean, from my perspective, you know, a lot of new features, a lot of new experiences that we can have with Looker platform. So happy to see them in action.
I will show for a moment a small note which I've done during watching of the videos. Just a moment to recap. Sorry for not zooming it once more for full screen, but we looked at two videos: Looker's Roadmap 2020 and beyond, and the Sunrun situation. And I've noticed there plenty of new stuff and plenty of promises. Maybe we deep dive how far these promises in time will be made. Maybe I can ask you later on. Cross-filtering, a little bit of new authoring tools, more rich visualizations, more into area of collaboration, either with the stack of Google Workspace, Slack, and so on. Looker Mobile, looking forward to it. Smart search through the environment, theming, analytics on analytics, and the story from Sunrun, where they've shown how the big portfolio of products from Google Cloud make them easy to go into multiple styles of analytics. Finally, colleagues, I know that you used some of the functions which are announced today. Can you share a little bit that perspective? What do you like the most?
So
some comments on this improvements.
Every release gives us more powerful features, and I would say I was super excited when we had the ability to test some beta features that were enabled few weeks ago, like cross-filtering ability. But we also realized that there is a new approach regarding the overall design. Now new filters are more user-friendly. We have ability to of filter types that is very beneficial for the users. We can use ranges, slices, we can use drop-down lists, and that all looks really great.
Magda, I've noticed this thing which many customers look forward: cross-filtering. What will change here?
So finally, that feature also comes to Looker. I was waiting along for this feature. So simply, thanks to that feature, we can get the information much more quicker. Why? Because we can filter out one visualization by using another one. So if we are focus on one thing, we can simply go deeper. We can click into visualization, and all the context of the dashboard. So other visualization on the dashboard will be changed, and that's make process of getting information shorter. This is what we want.
And so do you have some insights when it will be available around for us to use and for customers to use?
So the rollout of this function already started. However, according to the news from official Looker site, we know that this feature will be available until for all customers. It will be available until the end of October. So soon, or maybe
it's
now.
quite soon. So I know this video was, taken by Looker team, I think, for the American session also. So it was kind of a couple of months ago. So maybe that's already there. Guys, I also wanted to put that tough question on your shoulders. I have my answer, but you're the experts. You're the top experts here for the Looker. Why do you like Looker? Because that's probably many of the viewers will say, okay, there is this, there is that, there is Power BI, there is Click, there is Tableau. Why should I get in any way interest to take a look at Looker?
Bartek, do you want to start?
Yeah, I would love to. Yeah, there are plenty of tools, right, in BI market, but Looker seems unique in few aspects, I would say. Let's say for me, one of the most important is the approach to the semantic layer, right? So the data modeling piece is like taken to another level from my perspective. It's quite at first it seems like you need to have a knowledge about about coding. There are not so many, let's say, drag and drop features, but in let's say in few moments you can start leveraging that, right? So all the things you created can be reused in many places. So Looker strongly recommends and or follow this paradigm do not repeat yourself, right? So I really enjoyed that. And the other thing is versioning. For the enterprise scale implementations is, let's say, another unique thing to me. So I like it very much.
In this LookML area, right? The semantic modeling gets its Git repository, gets versioned, so it's really you all together with me can develop together the data model, which is then distributed to everyone.
Correct, and it's worth to mention that it's like a native feature of Looker, right? So you don't need to worry about like integrating any like other tool with Git provider. It's like native function. It's really helpful. It's really like meaningful. You have your space or workspace where you have all those remarks. What was the newest, let's say, code? How to let's say work with some new piece of let's say implementation or code that your colleague did. You have really useful framework to work, to collaborate within your team.
In addition, there are many already built blogs that you can easily implement to your final solution. There is something called Marketplace, which is a place where developer can find new visualization, but also already built dashboards. So the newest release of Looker allows you to download the dashboards that were already prepared with were crafted in partnership with Google experts. So this is it was
do
something.
You have some example, like what could be solved this way quickly?
So let's say that you are following KPIs by using Google Analytics. There is already built dashboard that allows you to check how many visitors are on your social media, which type of content is the most frequently followed by your users.
I will challenge you, or maybe add on that, because this purely is available on Google Analytics itself. But I noticed this. I know what which kind of marketplace offer you're looking at. I think the benefit is that you can also have ads, search, and so on, multiple elements of Google Marketing Suite all together in one dashboard. That's a difference, yeah, because analytics have already there are already their charts and statistics, but in Looker you can bring it all, and I understand mesh it together with your internal data, not only stay on the level of Google Marketing Studio product, right?
Yes, that's right. In addition, there are you can make some impact by using this dashboard, because there are a connection to your campaign that you created. So Lookers allow you to combine your dashboards with third-party tools.
Sure. The action, for example, that you find something in Looker, you jump directly into Salesforce, Marketo, put some list of customers. Yeah,
this is absolutely new in business intelligence world. No other tool has something like that.
They are trying. They are trying. There are some solutions, but I think Looker is the most advanced here. I admit, to be really honest with the viewers.
Yeah, I really agree with you what you said, guys. But it's worth to mention that the let's say the variety of actions that we can choose, and like pull to your system, like with some few clicks, I would say. It's like a massive thing. It looks like a few steps, and you have completely new baseline which you can use for your analytics. You can do analytics even on analytics, right? So Looker provides you a easy way to check what is what is the performance of your, or how your dashboard are being used for your users, which are the most heavily used, right? Which are the most interest of. So many, let's say, out-of-the-box features allows you to improve your solution on the way.
Guys, I will make a stop here. I love to talk to you for hours. That's obvious, and that's not the first day it happens like this. But for the sake of agenda and our viewers, now we will move to another topic. Thank you, Magda. Thank you, Bartek.
Thanks.
Thanks for inviting us.
Now we will switch gears once more, do a little bit of reshuffle how my screen looks like. We have here the videos. We will now dive into data lakes story with Google. Let me play the video, and we will get back after that video into discussion with you. Small correction because I've shared that without video, without audio. You need audio to get it, right?
Data analytics role. So today we're going to be talking about how you build data lakes, but let us first understand what a data lake is. Data lake is a centralized and a secure data platform for ingesting, storing, processing, and analyzing all your data, structured, semi-structured, and unstructured data at scale. When we work with our customers, we find out that the traditional approach for building data lakes, where you bring data from various different sources and land them into one single central store, has not worked and has not provided good results. And they have also told us that they would like to have more use case driven data lakes, right? So the traditional approach basically ended up creating, instead of lakes, it ended up creating swamps. And too much of operational cost was incurred during maintaining those lakes. But when you look at like what those data lakes are and what is the value proposition of having a data lake, there are many. One of them, to begin with, is cost savings. You save a lot of operational and capital costs in essentially doing all of these transformations outside of your traditional data warehouse. It also increases the quality of the data, right? As the data actually gets processed in the lake, the quality of the data as it progresses through the lake increases dramatically. Now, if you build a good data lake, it has to have a fast discovery mechanism, which will allow you to identify all kinds of data that exists within the lake, right? And then when you think about what actually this data lake is going to provide to you, it's going to reduce the time for analytics. It's going to basically make it easier for doing analytics that you haven't been able to do it before. And with having better analytics solutions, you're able to get to market faster. Now, there are various different components that are involved in building a lake. Whether it is you're doing a data discovery, you're organizing your data, you're doing transformations, you're doing optimizations. There are various different components that have to be included together to build the best data lake. Now let's see what are some of the challenges that are there in building the ideal data lake solution. Data lakes are complex and time consuming, right? And the process of building them and managing them is extremely difficult. And the reasons for these things to be difficult is because you are doing a lot of various different operations within the lake. First of them that you begin with is importing and ingesting data. It's a very laborious process. You have to first identify all of the various different data sources that exist within your organization, which could be of various different formats and various different data sources that you would have to bring all of that data together using some form of an ingestion tool. Now, once you land the data in the lake, you have to organize it. And if you can't organize it very well, it just turns out into a swamp. So you have to spend huge amounts of time organizing the data in the lake. So it is basically you categorize the data in various segments, you basically store them, separate them, segregate them, and also assign different security policies for it. The next thing that is critically important in the lake is data transformations. The data transformation provides a standardized way of transforming the data from a raw form to a standardized form, and then actually preparing them for analytics. Now, we'll combine all of these things together. The most important part that will bring all of the abilities of a data lake is the discovery. If there exists no good discovery mechanism in a lake, the data itself is lost. And it turns into a dark data, and more such dark data actually leads to creating a swamp rather than a lake that you would like to have. And the data quality aspect of a data lake is critically important for a few reasons. One, if you look at traditionally why data lakes were built, data lakes were originally built to offload a lot of the work that was happening within the data warehouse so that they could use the CPU cycles of the data warehouse to run the queries. So when you bring all of that data in and combine that with all of the structured, unstructured, and semi-structured data put together, you have to have a very cohesive strategy for ensuring the quality of the data as it progresses through the data lake towards the data warehouse or a data mart. So there has to be tools that have to be integrated in order to have guaranteed data quality for the data moving through the data lake. The last but not the least, you want a lake, but you don't want a lake that is not accessible from various different tools, whether they are open source tools, whether they are proprietary tools, it doesn't matter. The lake has to be accessible to all kinds of tools that exist within the ecosystem. So interoperability plays a very vital role in ensuring that your data lakes are not isolated, but they're integrated into all of the ecosystem. So lakes can be simple. There are three primary pillars on which the lakes can be built. One, ability to quickly build the lakes, which is essentially involving populating data from various different sources into the lake. Once you bring the data into the lake, you need to be able to catalog that data. you need to be able to discover them. You need to make it easy to find all of the data that exists in the lake, right? So you would have to have some kind of an ability to crawl all of that metadata that exists within the lake and store that into a central repository. Once the data is cataloged, it then has to be indexed so that it's easily discoverable through a search mechanism. Now, and there are many aspects of it. The metadata can include a lot of different types of metadata that you can aggregate. One is the file format. The other could be various different metadata associated with it, the size of it, the time, the date it was updated. So all different metadata associated with the data can be aggregated with this cataloging. The next is standardizing, cleansing the data. So as the data lands in the lake, the data has to be cleansed. It has to be turned into, it has to be standardized, and it has to be canonicalized to conform to a standard format that is appropriate for the organization. Things like SSN, things like phone numbers, things like zip codes, all these have to be processed in a standard fashion, and they have to be made easy to do that, right? So all these transformations takes a lot amount of time. So these things have to be simplified as part of the process. So you would want to have some kind of a code-free tool that will allow you to do that. Now that you have brought the data into the lake, the first thing you want to do is secure that data. You want to be able to define access control. And you also want to not only just do it on the data, but also the applications that are going to be accessing that data. It's critically important. Data access control is one aspect of it, but the applications that are going to be accessing the data also have to be controlled in terms of who basically has the permissions to run the jobs that are inherently going to be accessing that data. Now, in a lake, there are so many different jobs that are run, right? Jobs that are ingesting the data, jobs that are standardizing it, jobs that are transforming it and preparing it for analytics, preparing it for warehouses. Now, all this in an enterprise are based on a scheduled time window during which these jobs have to be executed. So in order to get a better insight into those metrics, you would have to have ability to understand all of the different metrics that are there. You would have to have access to them, as well as being able to look at the end-to-end SLA of the jobs that are running within the lake. Some kind of a dashboard, like a data operations dashboard, is required to enable these. Now, because lake is a central place where critical data exists, and as you all know, of all the data that is in the lake, 20% of the data is actually very critical, and it's being used by a lot of different parts of the organization. So in order to ensure good security mechanism and compliance mechanism, there needs to exist audit logs that administrator can use to see and improve the access control as well as the security for the data lake. Now, once you have ingested the data, and you have provided the standardization tools to essentially transform the data, and you have secured it, the next thing, which is critically important for a lake, is to making the lake accessible. Right? The lake today is being, if it is not accessible to the world or the tools outside, people will not find the lake usable. So first of all, the lake should be able to expose all of the data that it has in various different tools, whether you're using Spark, whether you're using Hive, whether you're using Presto, or you're using BigQuery, it doesn't matter. The data that sits in the lake has to be immediately be accessible to proprietary as well as open source tools. In addition to that, the data has to be smartly partitioned, because what ends up happening is, as there are various different tools and various different needs from an optimization perspective, the data has to be partitioned in such a way that it is, it integrates seamlessly with all of these different tools. And there is, like from an analytics improvements, there needs to be handling of partitioning of the data, which actually is very critical. Then at the end of it, you would have to have standard ways of moving data from various different areas within, you can call them zones, various different zones within the lake that you define. There needs to be a standardized way of moving that data, because in some cases you might want to move the data from the final, the defined zone directly into your data warehouse. So you having that ability, which is inbuilt and allowing you to connect with the world outside, is extremely critical for making the lake successful. With these three simple pillars, you can build an end-to-end lake. Now, there are many use cases that can use this lake. And let's briefly look at the kinds of use cases that we have seen with our customers and how they are actually using all of the GCP products and bringing them together in their use cases. Let's start with a simple use case. First of all, data warehouse staging. And this was the primary purpose for which data lakes were built. They wanted to offload all of the additional ELT, the transformation that happens in the warehouse. They wanted to offload it in the lake so that it provides a lot of cost savings. And then they have more horsepower in the warehouse to run analytical queries. Now, when you bring that into the lake, what needs to be happening is the lake has to define these zones or staging areas, right? So there are different staging areas that have to be defined. So our customers end up defining various different staging areas where the data moves from. They bring all of the raw data from external systems, whether it is structured, semi-structured, or unstructured data, into a raw stage. Then they will transform it, right? Cleanse it, standardize it, canonicalize it, and move it into a refined stage. Now, once the data is in a refined stage, they will run further analysis. They will apply business rules. They will, again, further cleanse the data based on the business rules that they have from their organization. And then they move it into a curated stage, then ending up into the data warehouse. So this is a very simple use case, most common use case that we see on GCP right now. Let's look at the next one, which is data lakes are used from a perspective of data science experimentation. So it follows a similar model, but here the data, the curated data now has to be accessible to exploratory tools. Things like, you want to have access, you want to provide access to notebooks, you want to provide access to any of the other machine learning tools that exist, you want to have access from the Spark. Like all the data that is actually in curated zone has to be made accessible to all of these different tools that exist within open source. And there are more that keeps on getting added year over year, right? So this is the second use case that we commonly see on how people are using data lakes on GCP. The last one is an interesting use case, and this has been this is recently becoming more popular, where customers are using the data and transforming it, moving it into data warehouse, but also they're looking at ways where they can take the data from a data warehouse and put it back into the lake, and then have a federated way of querying the data between the data warehouse and the data lake. Have a federated query capability that allows you to bring the data, stale data or old data, and the new data combined together when you are essentially doing ad hoc analysis that you're looking to, right? So all these three use cases are primarily what we see with our customers on GCP. Now, when you look at what goes into building these three use cases, right? These are the components of GCP that makes them happen. Right now, we have various different services, and these services have to be brought together. And this is something that we will be looking in the future, but these are some of the things that you would have to bring together in order to build your lake. So right now, it's do-it-yourself lake. And this is going to be, we are looking at how we'll be integrating these various different components to make it easier for you. But in order to build a lake, there are two main things you need from a lake perspective. First is you need the central storage. You need to have the ability to store the data, whether it's structured, semi-structured, or unstructured data. You need to have a way to store them. And part of GCP, there are two services that are available. One is Google Cloud Storage, and the other is BigQuery Storage. So these provide, and we'll look at what those differences are and when you should be using one over the other. I mean, it's an easy choice, but would like to give you more information on that a little bit later. So storage plays a vital role. The second one is security. You need to be able to have the best security possible for securing all of the data that actually exists, whether on the BigQuery side or on a cloud storage side. So cloud storage provides you at the bucket level or the prefix level access control that you can define and set on these policies that you can set. And BigQuery has now added, I think we have added like column level as well as row level security as part of BigQuery. So customers can pick and choose how they want and where they want the data lake to be and what the data lake storage is. But these are the two common choices that customers make when they are building the lake. Now, when you look at how you bring the data into the lake, there are various different services. If you are bringing data in real time, customers tend to use PubSub. And when you're looking to move massive amounts of data from your on-prem filers to GCP directly, they end up using what we call transfer appliance. Transfer appliances are, you can order them, they will come to your data centers, you can copy it into it and ship it back, and then it will be copied into the buckets that you have created for this data. Then you have Data Fusion as another tool that allows you to bring data, but there are other capabilities that exist within BigQuery, which are tied to BigQuery from that perspective. To BQ transfer service that allows you to bring data from all of the various different SaaS sources into BigQuery. Now the data as is being ingested in, it needs to be cataloged. So by default right now, all of the data that exists within BigQuery automatically gets registered with data catalog. But GCS, there is no mechanism right now by which the GCS data, the data that gets stored on GCS, gets cataloged automatically. So you would have to end up building some kind of a metadata extractor that's looking at all of the different buckets and different files that exist within GCS buckets and registering them with the catalog. So that's something that you would have to build by yourself right now. So you would have to use your favorite tool or programming language of choice to build and add a kind of like a crawling capability to add metadata to the data catalog. The other thing that is required in order to make the data accessible is all of the data that exists within GCS buckets or in a BigQuery. So recently launched data prop metastore, right? So this is a high compatible metastore. It's based on high metastore. So this will allow you to register the data, structured data specifically, so that you can query it using Spark, Presto, or Hive, right? So this is another system that basically allows you to bring more of metadata and organize it in a way that is queryable. Now, once the data is cataloged and once the metadata, technical metadata has been registered, there are various tools that are available on GCP to actually process. You have Cloud Data Prop, which is hosted Hadoop or managed Hadoop, I would say. And then you have Cloud Data Flow, which provides you a serverless data processing paradigm for both batch and real time. And then you have BigQuery, which has the query engine as part of it that allows you to run analytics, right, in real time on the data that's being ingested. And there are a lot of machine learning algorithms and techniques that are included, like, for example, AutoML. They can be pretty much integrated, are very much integrated into BigQuery. And there are also approaches for connecting it with the data that sits on GCS. So now bringing in all these together, like when you look at it, there are various different aspects, right now still exists, that you would have to spend a little bit more time connecting them together. First, you would have to catalog all your data. While the data in BigQuery automatically gets rendered in data catalog, there is some amount of effort required in cataloging all of the data that exists within the cloud storage system. Now, when you think about Metastore, which is a new addition to the cloud GCP family, it provides the much awaited technical metadata registration for structured data that allows the data to be now exposed with the most popular open source tools, which can, again, be run on data prop. So now let's look a little bit further into all of these various different technologies or services that we have on GCP. Let's start with storage first. So how do people use data, GCS, right? People consider GCS as the data lake. Some customers do that, and some customers consider BigQuery as the data lake. And that's okay. Both do have advantages and disadvantages, but they both can be used as the base storage layer for a data lake. Most customers end up bringing the data into GCP using various ingestion tools and processing systems. It's not just limited to whatever GCP provides. You could have traditional on-prem vendors providing capabilities that allow you to bring the data. You can use any other SaaS services to bring the data into GCP. Now, as you bring the data into GCP, the pattern that we observe is as the data goes through various different forms of processing, one of the primary destinations for this data that lands on GCS is BigQuery. And that's where most of the analytics end up happening. Because as you guys all know, BigQuery is the data warehouse offered by GCP. Now, when you look at from a BigQuery as a data warehouse, data that gets moved into BigQuery is optimized for analytics from the beginning, from the start. As soon as you import the data into BigQuery, it's optimized for analytics. Now, the way BigQuery stores, the internal format is very much optimized in a sense for doing a large-scale analytics on data. Then we have customers who stores petabytes of data and analyze all of that data in seconds. Now, one of the differences between BigQuery and GCS is BigQuery, the data has to be structured or semi-structured, so you can store JSON and you can store those kind of data types within BigQuery. But on GCS, you can store any. You can have images, you can have audio files, you can have pretty much anything you want being stored on a GCS. Now let's look at let's go a little bit further and look at what are the differences between these, right? I want to be careful about talking when we talk about cost. I think the cost from a cost up, it all depends on what you're doing with BigQuery, but compared to GCS, BigQuery now has optimized with fixed slots and all those things. It basically gives you a lot more optimization from that perspective, right? But the major difference that exists between GCS and BigQuery is the schema for BigQuery has to be defined a priori. The schema has to be known, but in GCS case, it doesn't need to be. They can actually store just the files and they can define the schema at any time. The common data sources for all of the data that exists in GCS is like any file formats, any data type. It doesn't matter. Structured, unstructured, semi-structured data all can be stored. Now, mostly BigQuery is used from a relational and transactional databases, but as you can imagine, there are also semi-structured data that can exist within the database. For example, like in Oracle, they can be XML, they can be JSON. So all of that, like not specifically XML, but JSON can be represented within BigQuery seamlessly. And the primary users, when you look at it from the perspective of these two different services, cloud storage, data engineers, anyone who can read and write a file can basically access it. And in BigQuery, anyone who can write a query, which are mostly data analysts, business analysts, and even data engineers, right? So pretty much everyone on the planet knows how to write a query, so they can use BigQuery. In that sense, the data is a little bit structured, and they would have to understand how to write a query, which is very common these days right now. So anyone can do that. The only difference being is the data is very much structured in BigQuery, and the data is not at all structured in GCS. Now, when I mean structured, it's representation of the technical metadata, which is like the columns and the types and those kind of things, not the files and organization of those files. So these GCS and BigQuery storage becomes the foundation for any data lake that you're building. So depending on your use cases, you would have to make a choice. Do you want to start with GCS, or do you want to directly land the data into BigQuery, and that becomes your data lake storage? Now, when you think about it, in cases there might be, in a few cases, customers still want to land the data in GCS and progress it through in GCS, and then load only the data that is required and curated for analytics into BigQuery for business analysts. Now that we have looked at storage options, let's look at the catalog and the metadata options. The catalog and the metadata options, which is the metadata stored. Now, as you guys all know, data catalog provides a central catalog across GCP for storing all of the metadata and indexing the metadata and making it much more accessible through a search interface, right? So the interesting part of all of this is it also adds on to ability to create some of the data governance capabilities integrated as part of it. So you can use data governance templates to categorize various different data assets within the catalog. So right now, this is very deeply integrated from a BigQuery perspective, but there is, in the future, there might be integration automatically being provided from a GCS perspective. But in the meantime, you would have to have a system that can analyze, pick all of the metadata that exists on GCS and populate that into the data catalog. So auto tagging PII data. So this is basically using DLP, data loss prevention. It's yet another service of GCP that allows you to analyze the data and identify any of the sensitive data that exists within that. If there is any PII data, it'll auto tag that PII data and surface that to the administrators to act on it once identified. The data catalog also provides the ability where you have the ability to control who has access to what metadata. Some of the parts, as the data is important, the metadata associated with that also is very important. So having ability to provide or have access control over metadata is a critical capability that data catalog provides. Now, this is for all of the metadata that exists. And as you all know, there are three kinds of metadata that exist: technical, business, and operational metadata. So we're talking about a business metadata, and this is also incorporating some of the technical metadata. But this is not from the viewpoint of processing. This is just for making the data accessible to you and making it easier to access. Now, the next one is more focusing on how do you take technical metadata and register that with the metastore that then allows you to make it, then makes it accessible. Then that data becomes accessible to open source tools that exist within the ecosystem. So Dataproc Metastore is a newly launched service. It's a fully managed, highly available, open source native Apache Hive Metastore service, which simplifies technical metadata management. Right? All of the technical metadata that exists and that gets registered within the Dataproc Metastore is now accessible to Spark, Hive, Presto, notebooks. All these tools that are popular in open source have ready access to the data that exists in the lake. Now, it's an alpha feature. You should please go take it for a spin, give it a try, and let us know if there are things that you would like to see improved on it. But it's a great addition to telling the true story of a data lake on GCP. Now, what does the Dataproc Metastore provide? It provides a simplified management. It allows you to create and configure a Dataproc Metastore. It even comes up with Kerberos cluster, so you can configure a KDC and do all those kind of stuff. It provides the versioning capability, and it's all integrated into the standard console of GCP. So you get a fully managed experience for managing one or more metastores in your lake. Now that we have talked about the storage and the metadata, we can look at the other components that exist within the lake for critical components that exist within the lake. Now, data exploration analysis is an important aspect of it. Now, because we talked about registering the metadata and with Dataproc Metastore, you should be able to, as soon as you bring the data and you want to do some kind of an exploratory analysis, you should be able to use tools like Hive to query the data. Now, the data, because it's registered with Hive, you'll be able to readily query the data that using a Hive or Spark right from the console. Now, because of the launch of Dataproc notebooks, the notebooks are also integrated with all of this data, making exploratory analysis much more easier and fun. Right? So you don't have to have a separate system. You don't have to manage it all by yourself. It's all managed within Dataproc and makes it extremely easy to get access to all of the data that gets registered with the Dataproc Metastore. Now, there is a little bit of a manual process where you would have to register for the data that already exists on GCS and not registered with the Hive Metastore. You would have to do that manually, like I have alluded to that before. But that's something that in the future we might basically make it automatic. But for right now, you would have to write something that will just pull all of that stuff and put it in there, metadata and put it in there. Now, for one of the use cases that I talked about, right? So you want to have ability to spread the data between, like, for example, between BigQuery and GCS. Now, the interesting thing is, how do you federate queries between that? So BigQuery has recently launched the ability to query the data using federated tables. So you can define that as an external table for a data that's sitting on GCS, and part of the data could be in BigQuery. You can join, you can do all normal operations that you can do with the table can be done with federated queries. So here it's a simple process of registering. Now, wouldn't it be cool if all of the data that sits on GCS and any other system automatically gets registered into Hive and gets represented as an external table in BigQuery, so that any tool that exists in the ecosystem can use the metadata that is being registered to query the data and make it immediately accessible. So the data lake doesn't have to end up being a siloed storage, but making it much more accessible through these ecosystem tools that are basically providing that additional service from a registration of metadata perspective. So, transformations we have talked about. When you build a lake, yes, you want to have the ability to transform your data, you want the ability to do complex transformations on it, but we have never seen, at least I have never seen a simple job that's running within the lake. It's a complex network of hundreds of jobs that are actually running in a lake in many enterprises. And in order to control all of that and manage all of that, you need two things. One, first of all, you need the ability to run the job, to do the transformation. So you can use Dataprop or you can use Dataflow to do that right now. So Dataflow is a serverless offering for batch and real-time stream processing. And Dataprop is basically supporting both Hadoop and Spark workloads. Now, what do we need to do for this is to be able to take these two things together and orchestrate them using Cloud Composer. So while I can essentially create jobs, I want to be able to stitch them together in a DAG, and that can be done with Composer. In addition to this, you can, of course, look at Data Fusion as a way of doing transformations, but Data Fusion underneath uses Dataprop and provides a visual tool. It's a data integration tool. It provides an ability to do the similar stuff on top of it, where you don't need to have any programming. You can just do it in a code-free manner, right? So now that when we have looked at all of these things, the storage, the metadata, the transformation, now the last thing that is required is the ability to bring all of the data integration aspects and ability to look at the lineage end to end. Because when you look at how the data flows within data lake, right? So while Dataflow and Dataprop provides the advanced transformation capabilities, data integration like Data Fusion provides much more a managed ETL solution with no code ETL pipelines, right? So you need to also have ingestion templates for bringing the data in. So you should be able to, if you look at it as an example of BQTS, BQ transfer service, it provides you a very simple form that allows you to look at, select a source, select a destination, be able to just copy the data over into the target, right? So you need to have the ability to do simple ingestion, and the data lake should not limit only for the usage of, you should be able to use any form of tool, right? Like, so we have customers who use Informatica, people use Talent, people use Matillion to bring the data in. And then they basically ETL it. Here you can use, as an option, you can use Data Fusion to do that, while you can also use Data Fusion for doing additional transformations if you would like, and deploy them into the lake, right? Like all the data that gets generated gets deployed back into the lake, or it can be pushed into the data warehouse. Now, one of the important things from a large enterprise perspective is ability to keep track of the data as it flows through the system. So you need to have a good understanding of how the data is flowing in your lake. So you need to have good lineage capability, right? While this lineage capability right now exists only in Data Fusion, in the future we will be looking at making that available as part of the data catalog. And once it's there, you will be able to look at lineage across the board, end-to-end, from that perspective, from a GCP perspective, for any data, right, that exists. Now, the only limitation of the current lineage is that if you use data fusion, only then that lineage would be presented. The lineage is available at 2 levels. One is at the data set level, which tells you what job process worked on what data set and what are the resulting data sets that were generated. The second is be able to look at the field level. The field level will give you much more granular information of how an individual field was generated and what were the various different data sets that were connected to it to generate the resulting field from those operations, right? So you need this. These will provide, from a compliance, auditability, it provides an end-to-end solution to have the best possible data lake, right? So now that we have looked at various different aspects of data lake, right? So we have looked at what are the different storage mechanisms we have in the lake, what are the different metadata systems we have, what are the various different transformation systems we have, and how do you do, what do you do from a data integration lineage perspective? So bringing it all together right now is a task. It's something that you would have to do yourself. But in the future, we are providing all these deeper integrations with various services to make the life for building data lakes much more easier. So it should be very easy for you to just take all of these integrated set of services and build lakes in. Our goal is to make it as fast as you can, right? Like right now it probably takes weeks or months. So we should be able to reduce that down to, with all these tool integrations that end up happening, it should come down to a few days. Now, to summarize, as we found during the talk, building data lakes is extremely hard. Now, GCP provides all of the necessary services to build the best data lakes you can possibly have. As you can also see, all of the innovation that is happening within GCP to build best integrated products. As an example, BigQuery now integrates with data that exists on GCS, allowing you to federate data across BigQuery and GCS. In addition to completing the story for data lake, we are closing a lot of different gaps. Data Proc Metastore is another such service that just got launched that provides you ability to integrate metadata and make it accessible more with open source tools. And these are some of the capabilities that exist in GCP that you can leverage to build the best lake possible. Give it a try. Thank you so much.
Okie-doke, we watched the video on data lakes. I'm coming back to your screen now. Hello. Hello. In the meantime, we had a question for the previous session. Let me address that in the meantime. One moment. Mr. Tomasz Truszkowski, who I know, by the way. Hi, Tomek. Nice that you joined our stream. Asked the following question. Correct me if I'm wrong. We are talking about click-like selection experience. The question was related to Looker cross-filtering capability. Let's say these are two different approaches to data sets. I know Click from the past, so can refer to that point. Maybe to some extent it gets interest to some of the viewers. So in Looker, Looker is asking database directly. So it shoots SQL statements to the back. So if we have dashboards combined out of multiple charts called looks in Looker, all these charts will ask database layer to answer the question. So none of it is stored in memory directly. It's cached, of course, by the engine of Looker, so that you don't shoot too often the same questions to the backend, and it's smartly managed. But the point is, you can see the visuals based on much complex data scale, not much complex, but much wider data scale in the concept of Looker. At Click, you can for sure click through and get through multiple analytics, select from the chart and get the result. but this is limited to that what's kept in memory of Qlik. And the solution similar to Looker is rather, let's say, second way of using Qlik, not a native mechanism, which have its limits. Thank you, Tomek, for raising the question. So you're in the game for the contest then. And now I want to bring back live to your viewing pleasure Marek, Michał, and Adrian, because we had this session on data lakes. It was like a session covering all of the aspects. I did one screenshot because I see that some pixels are not the best in the final stream. So maybe we'll bring it online for our little bit of our discussion on top of it, because gentlemen presented full, let's say, tool chain or full stack how you can ingest, how you can catalog, how can you process and keep secure all the stuff kept in the core of the setup in either BigQuery or cloud storage. Guys, what do you think about that session? Any free comments?
Okay, I can start with once upon a time, many years ago, when the data warehousing were very young, there was a definition that data warehouse is a platform, on a single platform which you can use to query your data, but first you need to push everything to this platform. So this was a challenge because the platforms were very, very different and so on. So it seems that currently
I've changed something, Marek.
Yeah,
I've changed something, Marek, in audio. Go forward. Yeah.
Okay, it seems that data lake nowadays it's something like that it is a single platform where we can upload everything what we have in the enterprise, both structured and unstructured data, and then try to analyze them. Yeah. So it is slightly different than the data warehouse, which means that we have structured data, cleansed, transformed, and so on. Yeah, in most cases we have also data marts and ready for analysis. But data lake is a kind of a first step for building data warehouse. In most cases, clients which ask us to build data lake, actually they require a real data warehouse, but they call this as a data lake requirement. Okay, and the consensus here. What is the very great thing in Google platform is that you can use, again, BigQuery for querying data lake. And this is the same BI engine which you use for querying your data warehouse. So one single engine and single habits which you used before, you can adapt to the data lake. And it is, I think, a very good approach because, yeah, no barrier at the entry.
Yeah, that's a very good point. I think nowadays these terms are blending. So that data lake was like a marketing topic to grab attention that it's more capable, but now you do hybrids. You have have the area of managed, well-cleaned data and still some data in data lake, but nevertheless, to use it in the business, you need to go through the process of cleaning, adjusting, modeling, and so on. You can do ad hoc analytics on top of some files stored on storage, even not moved to BigQuery. But this is
Yes and no, because to do
Yes
the
and no.
analytics, you need to, this is, I think, the one of the huge mistake, that you try to analyze data which are not clean, which are not integrated. So you, by default, you get wrong results, not the single version of truth. So this is the huge disadvantage of data lake, that you are not sure what to query. This is the great data source for machine learning, for exploring, for finding unknown, but not for enterprise reporting.
Yeah, but always, there is a mix. Yeah, some people need that exploration capability.
Yes,
some
that's
people
true.
need fixed report where they'll be very certain that the margin is with 4 digits of rounding, very correct one. And for various use cases, I think the best is to mix all of that. But the benefit of Google Cloud is, as you say, that this is like through the same window of Google BigQuery UI. Thank you, Marek, for that. For the sake of time, we will now move to another session and get back after them, because now we dive into streaming, powerful capabilities on Google Cloud, quite easy, managed with Google Stack. So we're getting back to you later on. I will put in the comments what it will be the timing for that. Thank you, guys. Now I'm switching back to correct video. Just a moment. We are starting with easy access to stream analytics with Google Cloud.
Hello, everyone. I'm Adrian Rzeźnicki. Welcome to Streaming Analytics on Google Cloud. When you look at IDC, they predict by 2025, more than a quarter of the data in the global data sphere will be real-time in nature. Now, you may wonder, why is this important? It is important because window of opportunity in the real-time analysis diminishes and goes away really fast. You want to be able to actually respond to your customer needs, their asks, maybe do prediction, or maybe detect some problem and really respond to really fast. While each and every one of this data becomes valuable for retrospective analysis, time to respond in a real time is very limited. So you want to have a platform that you can achieve both of these, real time as well as a place where you can do retrospective analysis. And for that, you have Streaming Analytics on Google Cloud. And this is the platform. Many of you out there are already providing various solutions in your industries. You have PubSub on one end, the Google native service that entire Alphabet company takes advantage of. We made it available through GCP for you to take advantage of as well, and you're doing a great job in there. That is your ingestion and distribution of data reliably globally. And you have data flow for all your data processing, whether it's streaming or batch. Now you can do that. And as you know, in data flow, it's the same set of code for both streaming and batch. And then you have the AI platform, BigQuery, Bigtable, Cloud SQL. All of them are there for your machine learning needs, for your AI needs, and data warehousing needs to do more analysis for your businesses. Here are some examples, great success stories. Home Depot, when they started their journey on the digital transformation, when they wanted to establish this e-commerce platform for themselves, they picked PubSub, Dataflow, and BigQuery to do this thing. And this allowed them to really increase new revenue opportunities and reduce their churn. When you look at Palo Alto Networks, they're building their next generation firewall using Dataflow as an embedded data processing system. AirAsia used the streaming analytics platform to provide refined pricing for their customers. This allowed them to increase their revenue and improve customer satisfaction and customer experience. Ulta Beauty has established their e-commerce platform where they can actually provide real-time offers to their users and suggestions based on their shopping practices and search practices and so forth, again, using this real-time analytics platform for their shoppers. Now, in this platform, in your own organizations, you have some heroes out there. Your data analysts, your engineers, your data scientists, and your operators are out there making this work for your systems, for your customers. And throughout my conversation today with you, I will be highlighting what we're doing to make their lives easier, more effective, and also bring some cost-saving opportunities for all of you out there. Here's a snapshot of what you're going to hear for the rest of my talk. You will hear Dataflow SQL. We're actually really happy. All the feedback that we've gotten from you on the early releases, you're loving this thing. It made it much easier for your analysts and engineers. You're really enjoying the AI platform integration with Dataflow. And Jupyter Notebooks was one of those things that data scientists really, really asked for it. And here you go. You have an integrated, a seamless experience from many of our services on Google Cloud, including Dataflow. And operators have asked for some dashboards, some real-time analysis capabilities, and a lot more in here. We're going to go into it. Ready? Let's go. Let's start with the ingestion first. I mentioned PubSub is one of those services that we across Alphabet leverage, and we made it available. It's a globally scalable, fantastic technology, really, really good. We did hear loud and clear from all of you that you wanted message ordering and that other topics. And thank you for your patience. Now they're going to be available for you. We also heard some cost-saving opportunities where you asked for a service like PubSub Lite. I'm going to go into it a little bit more. And it gives you cost-optimized event ingestion and data messaging platform for your zonal needs, where global nature may not be necessary for you. So we created in here. Our objective was to make it so compelling, even for your do-it-yourself Kafka solutions that you may have, is going to be higher cost than what we can provide to you. And of course, through our Confluent Cloud partnership, we have a fully managed Kafka service for all your on-prem to cloud migration needs. And CDC was one of those capabilities that you've been asking for, and I'm going to give you a couple examples of what is coming up for you. Here's a PubSub Lite. So this is possibly the lowest cost to serve possible messaging and event messaging system that you can find in here. It's ideal for predictable workloads. It's zonal, so that you can actually figure out where to do it. It's really easy to configure and already seamlessly integrated with Dataflow, rest of Google Cloud Data Analytics Platform, and GCP services. So give it a try if you haven't used it. We believe it will be much easier for you to really take advantage of PubSub Lite than do-it-yourself Kafka-like environment that you may have. If you have a lot of Kafka workloads and you are migrating to Google Cloud, you are using, or you should be using, Confluent Cloud. We've seamlessly integrated with our partners. They're integrated just like PubSub with Dataflow and our other GCP services for you to achieve your Kafka workloads and as you are migrating towards GCP. And CDC, this was your ask. And here's a two option for you that we're actually providing you. And for your MySQL and Postgres use cases, we're building a solution with Debezium. It's available as an open source self-managed templates. As a fully managed templates solution from ourselves, we're bringing you through our data stream. You will have a CDC capability for Oracle databases through data stream, through Dataflow, to BigQuery. You'll be able to provide this CDC capability. This has been one of those asks, and we're happy to show you what's coming up for you. For our data engineers and some, pipeline development, that's key. I highlighted the Dataflow SQL. It's for you to really take advantage of SQL. It's the same dialect that we have with our BigQuery and Spanner. You'll be able to do kind of joins between the PubSub streams and BigQuery tables and GCS files and so forth. You'll do some schema supports using the visual editor. It's right there for you. The early responses was very, very positive. If you haven't started using it, I encourage you to really take a look at it. You'll be able to build your real-time dashboards based on BigQuery, do your transforms. It's right there, very easy. Go at it if you haven't started using it. Data scientists have been asking for this Jupyter Notebook integration with Dataflow so that you can actually do your own interactive development, prototyping in the environment that you're so used to it. Now Dataflow is integrated into Jupyter Notebooks. Go ahead and do it. You have the interactive runners there, all the supported unit for your AI platform on Google Cloud. It's the same experience. So this was something you've been asking for. I'm really happy to announce that it is in your hands. Now, this is a good one. Flex templates. As you know, we provide 25 different templates through our Dataflow UI and CLI for you to take advantage of as a template. One of the asks that many of you had was, hey, I built these Dataflow pipelines into my system, but I want to turn this into a template so rest of my organization can use it as well within my own team, within my own organization. Now you can do that. This was something that you asked for. It's a much better system and you're used to it. You create it. It's all yours, along with the 25 that we provided. Quick recommendations. It's a really interesting capability. So it actually provides you guidances for your data analysts, data engineers, data scientists, and it achieves some cost saving along the way, where you can actually get some recommendations. Hey, do it this way and do it that way. Maybe clean your data, store databases or extra entities, find different ways to really store it, backup and restore spanner, what have you. It provides you through these recommendations ways to really improve it. What is it that you can do? And this is all in the fingertips of yours. Performance at scale. This is always a paramount for us. This is always top of mind. We always figure out a way to make it faster, easier, and scale even bigger and broader. Here's one, FlexRS. If you haven't heard, this is a fantastic cost-saving opportunity for you. You could save up to 40% of your cost in some of your batch workers. If you have a job that you run daily or weekly, you don't have to worry about changing a single line of code. All you have to do is turn it on, add one pipeline option, that's it. But remember, this needs to be one of those jobs that you run daily or weekly, because it might take a few hours to find the most cost optimum environment for it to run. So that's why it says in here, it may delay up to 6 hours. Here's what we have done for the Beam community. The Dataflow Runner V2 is available. It has a lot more capabilities in there, from more IOs, including Kafka IO and so forth, to parity across SDKs, some including the state and timer support in Python. It's available right now for you to test with your Python streaming pipelines. Go at it and try it. You will find some cost-saving opportunities there. All of you data engineers out there, and thank you for really taking advantage of the Beam. And our operators, for you, you've been asking this dashboard. Now, all your important pipeline metrics in a single time-correlated dashboard is ready. It's available for you. You'll be able to go deep dive into it, understand how we're making some of these auto-scaling decisions. That was somewhat of a mystery for all of you, and you've been asking for it, so we're providing some of these visibilities and achieve some cost reductions as well. So you can optimize your own pipelines, latencies, and throughputs that you're going at it. And these are all in your fingertips. And keep asking, keep pushing us in this area. Manage pipelines. This is another one that you've been asking. Now you'll be able to understand resource allocations over multiple job executions that you may have. This actually enables you to really give you better freshness on the SLAs and SLOs and so forth. Drill down on your pipelines, maybe figure out some problems that you may be seeing it there and fix it and optimize it. It's much easier for you to do it. We're going to continue to invest in here. Ease of use is paramount for us. We really, really want to make it easier for you. Now, real-time AI. As an AI student, I'm always excited about what we're doing in here. So we've been working with our partners across the ecosystem and trying to figure out what is it that we can do and how is it that we can actually create some patterns and create some kind of easy to start templates and sample codes and so forth by integrating Dataflow and Cloud AI platform. for pattern recognition, anomaly detection, some predictions and forecasting and so forth for every industry you can think of, from media to retail to healthcare to fintech, you name it. There's some great capabilities out there. You can use structured and unstructured data for your pattern recognition. You can use it with your videos, you can use it with images and text and so forth. Now, here's an example from TELUS, a great team. In Canada, they're one of the largest and fastest growing telecom companies, and they have many, many events coming in, and they wanted to actually use data flow to detect some anomalies in their network. So we're looking at 250,000 events per second that they process, and they figure out, are there any anomalies that we need to be really looking at it and detect it in a timely manner and respond to it. This is one of those use cases where you really need to detect fast and respond fast. And TELUS team has done a fantastic job taking advantage of this platform, these capabilities that we provided with data flow. And there's a lot more to do there. You can do it in every industry. If you visit our website, you will see a lot more in there, and the codes are ready for you to take advantage of from GitHub. Let's wrap it up together. We are the leader in streaming analytics. When you look at Forrester's streaming wave, there are a lot of things that makes us the leader in this area. There are 5 criteria that we've been rated the highest this year. Many of you are already taking advantage of these capabilities, and we invite all of you to come, take a look at it, visit, ping us, chat with us. There's a way we can help you with all your needs in here. Here's a list of you up there doing wonderful things in everywhere in the world, from retail to transportation, from healthcare to gaming to media to fintech. All of you have built great solutions on these technologies that I just spoke about. Thank you for everything that you're doing. Thank you for all your use cases and challenging us and working with us. We're looking forward to really hearing more of your feedback. We're here to really work with you. Here's a wrap up for you. We talked about what we've done for data analysts, data engineers, data scientists, and operators. There's a lot more out there if you go and visit our streaming analytics website in Google Cloud. You will find many blogs, many links to the code repositories and so forth to really make it easy. If you still have a problem, ping us, ping me, find me, and wherever you can, just we'll get you going right away. Thank you for your time. We really appreciate it and hope you had a wonderful time.
Hello, and welcome to the session on best practices to maximize BigQuery performance. My name is Jagan Athreya, and I'm a product manager for BigQuery at Google. I'm pleased to be joined in this session by Gary Steelman, who's a software engineer at Twitter. Hello, Gary.
Hey, Jagan. Nice to be here today.
Really glad to have you. We've put together a technical session for data analysts, data engineers, and data scientists. In short, if you like SQL, you've come to the right place. I'm going to start with a quick overview of the BigQuery architecture that drives the performance you see in BigQuery. Then we'll walk through a typical query execution within BigQuery. Next, we'll cover some of the best practices on how to write fast and efficient queries. And we'll also cover data processing techniques on the best ways to get data into BigQuery. Then I will turn it over to Gary, who will show you how Twitter uses BigQuery and will share some of his performance tips. Shall we dive in? Customers around the world rely on BigQuery performance to run their business. Spotify, which is a global leader in music streaming, analyzes hundreds of petabytes of data to give you the most personalized song recommendations. Their analytical queries went from 16 minutes to 33 seconds after moving to BigQuery. HSBC is a global financial institution serving 40 million customers worldwide. They were able to speed up their country liquidity calculations from hours to minutes and run their financial crime analysis 10 times faster with BigQuery. UPS, the largest package delivery company in the world, collects 1 billion data points into BigQuery every day and have used it to optimize their truck routes, saving $400 million and 10 million gallons of fuel each year. So let's explore how BigQuery can help drive performance for these businesses and businesses such as yours. So what makes BigQuery special? It starts with the true separation of storage and compute, which allows you to store petabytes of data in storage, but pay pennies per day for your queries. Data is stored in Colossus, which is BigQuery's columnar storage, which is encrypted, replicated, and distributed, making it highly durable against failures. When you send your queries to BigQuery, they run in stages over a massive farm of compute units called slots, which are units of computational capacity. BigQuery automatically calculates how many stages are needed for every query and dynamically calculates the slots needed for each stage. Data moves from the storage to the query server at lightning speed over the petabit scale network called Jupyter Network. Even complex queries, which need to store data between the query stages, have a persistent store called Shuffle, which is entirely in memory. All of these put together is what makes BigQuery deliver blazing fast performance to you. Now we'll take a look at a sample query to see how it works within the BigQuery architecture. This is an example of a scan filter aggregate query on a table containing 1 billion page view logs from Wikipedia, where the title contains Google. The queries are first routed to a query master, which contacts the metadata server to figure out exactly where the physical data resides and how it's partitioned to come up with the initial execution plan. The first stage of this query sends the query to a lot of parallel workers, each of which reads the title column and filter out the data that don't match. It then does a partial aggregation as directed by the group by and writes the results into Shuffle using a hash of the title. The next stage reads from the shuffled output from the previous stage and does the final aggregation. The final stage, or stage 3, is extremely simple. It just reads the resulting titles and sorts them in an alphabetical descending order. This final sort operation is done on a single worker before serving up the results to the client. Now that we know how BigQuery runs queries, let's look at some of the best practices and how to run these queries fast and efficient within BigQuery. A typical query consists of a select, from, where, group by, and order by clauses. Since BigQuery is a columnar store, we're going to start off with how to optimize selects. Select star may actually drive up your costs if you have a really wide table with lots of columns. So the first tip I have for you is to use only the necessary columns in your select clause instead of select star. Next, when using functions, consider using approximate functions such as approx count distinct or approximate quantiles instead of the corresponding exact functions such as count distinct or quantiles. These approximate functions produce results which are 99% accurate if you're looking for trend data and not looking for exact values such as financial data. Now we'll come to the where clauses, where you can drive a lot of query optimization and efficiency. The key to improving efficiency is to filter early and use predicates which can be pushed down into the tables to filter out data, especially when joining multiple tables. Use the column directly to match values is a lot more efficient than applying a function on a column matched to a value, since this predicate can be pushed down. Next, we'll come to joins in the where clause. Any complex query involving joining one or more tables and finding matching relationships through the join columns. There are different types of joins, such as inner join, cross join, left and right join, which are well known. Speaking of how they're executed, joins are executed in BigQuery in several ways. A broadcast join is where a large table on the left is joined with a small table on the right of the join. In BigQuery, a broadcast join takes the small table and sends the entire table to every worker working on the large table column values if the table on the right is sufficiently small. To achieve this efficiency, you may need to filter and aggregate the data from the small table before joining with the large tables. The other type of join executed within BigQuery is a hash join, where you're joining large tables. Now, this is computationally more intensive. The goal of the hash join optimization is to ensure balanced data distribution across the joined tables. So keep an eye out for data skew. To give you an example of data skew, the number of cricket players per capita is skewed to the 12-member countries of the International Cricket Council versus the countries in the rest of the world. When this happens, you may need to query the skewed data separately from the other data and combine the results using union to maximize the efficiency of the query. A special case of join is self-join when a data is joined within itself. This type of query can get very expensive. Some of the techniques you can use to get the data efficiently is to first take one pass at it. So for example, if you have a table containing male and female baby names, you can use an if function to create pseudo columns and compute both sets of aggregates in one pass. Another option, if you have multiple records with dependent data, for example, a start and end time and date for bike rides, you can use the lead and lag functions to specify a window within which you want to find the matching entry. To understand how these queries work, it is important to look at the actual execution plan. The execution plan for the query is available under the execution details for every query in the BigQuery user interface. It shows you the stages that the query took and provides the details of the operations and timings at each stage. Look for the waits, which indicates the stage that is waiting for a dependent stage to complete, which can often be a source of delay. Also look for variances between the average and maximum worker timings. This indicates that the distribution of work across the workers may not be uniform. Now that you've identified query inefficiencies, what can you do to improve them? BigQuery provides several data organization techniques such as partitioning and clustering to speed up your query and lower the cost. Partitioning in BigQuery allows you to divide large tables into smaller logical tables called partitions. Data for one partition is stored in a physically separate location from the other partitions, each with its own metadata. When a query is issued representing a specific partition value, BigQuery only scans those logical tables matching the partition value instead of the entire table. Partitions are usually designed for low cardinality fields, which is fields with a low number of distinct values, generally of the order of a few thousand. Clustering is a different form of storage optimization within BigQuery that stores the data in a semi-sorted format based on the cluster key, which may consist of one or more columns. You can use a combination of partitioning and clustering to optimize your query by identifying the low cardinality and high cardinality columns as candidates for partitioning and clustering. We recently announced support for partitioning of non-partitioned tables, so you can speed up key lookups for even high cardinality data which are not partitioned, such as user IDs. In addition to looking up queries, you can also improve the cost and efficiency of DML operations through partition pruning by using the underscore partition time pseudo column for ingested time partition tables, or by using the table or timestamp column for partition tables in your DML statement. The final recommendation for query speedup is the use of materialized views and BI engine. Materialized views are pre-computed views that cache results of a query for increased performance and efficiency. BigQuery leverages the pre-computed results from materialized views to deliver the results. If the data changes, BigQuery only reads the delta changes from the base table to compute the latest results, which is much more efficient. BigQuery is also smart enough to detect when a query can benefit from a materialized view and automatically redirects the query to the cache results of a materialized view instead of querying the base table from storage. BI Engine takes the speed improvements up another level by providing an in-memory store for BigQuery. To enable this, just reserve the BI Engine memory capacity in the same location as your dataset, and that's it. Your queries will now run fast and always fresh. To store and manage data, you need to bring data into BigQuery. BigQuery supports batch and streaming methods of data ingest. Data can be loaded into BigQuery from a variety of storage formats ranging from Avro to JSON. You can even use DML to perform ELT to transform data using the query API. We've removed the limits on the number of DMLs a table can process per day, which is much more beneficial to you now and is much more useful. If you need to perform continuous ingest, you'll need to use the streaming API to get more real-time information. If you need really accurate data that is still in the streaming buffer of partition tables, you can use an additional clause of underscore partition time as null to find the data that is in the buffer. Finally, we come to automation within BigQuery. While we have various ETL tools such as Cloud Composer and Data Fusion to perform various types of ETL, sometimes it may be more efficient to use BigQuery to run complex ETL operations. BigQuery supports scripting by which you can run a series of commands in a specified sequence with control logic, such as while and if. And if you want to save these, you can save these as a reusable program called a stored procedure. It can also be used for migrating existing stored procedures from legacy databases when you bring them into BigQuery. This allows you to perform your in-data warehouse operations quickly without having the overhead of having to move the data outside. With this, let me now turn it over to Gary to tell us how BigQuery best practices are used at Twitter.
Thank you, Jagan. My name is Gary, and I'm a software engineer at Twitter. Today, I'm going to talk about how we use BigQuery at Twitter and some of the specific use cases we have, and some of the performance results that we've seen from using BigQuery's optimization features. So first, I want to go ahead and just dive right in and talk about how we use BigQuery at Twitter. It's important to understand the scale at which we use BigQuery at Twitter. We have hundreds of different users running queries and jobs every month. They're running tens of thousands of jobs every day, most of which are queries. We store data and run queries in hundreds of different GCP projects with thousands of different data sets storing hundreds of petabytes of data. As you might imagine, processing that amount of data uses a lot of compute power, and we're using over 1 million slot hours a day. It's important to note that at this scale at Twitter, that's why we care about performance so much. Every little bit of performance optimization we can make helps quite a lot. So now, let me talk about some of the different actual use cases we have for BigQuery at Twitter. We can think of these broadly in two different categories: analytics projects and adoption projects. The analytics projects you see here, I'll get into a little bit more detail later. But the adoption projects are ones that we can think of as already existing and migrating from a previous platform over to BigQuery. So for example, people are migrating from Google Sheets and Google Apps scripts, or on-premise Vertica and Solr clusters, or even using Google Analytics and moving their use cases to BigQuery. Teams who are adopting BigQuery are looking for big gains in performance and also maintainability. They're also looking for that rich integration with GCP tooling. So now, let me talk a little bit about those analytics projects in more detail, and some of the performance gains that we've seen for those analytics use cases. It's important to frame this discussion by understanding how we look at these optimizations at Twitter. We look at them at 3 different levels, kind of: the query level, the table level, and the project level. And a lot of those different features that you saw Jagan talk about earlier, you can see here categorized into the different categories. We make heavy use of all of these optimizations because at our scale at Twitter, every little bit counts. We also use the project level optimizations quite a bit, such as slot reservations and workload isolation. We try to separate workloads into separate projects so we don't end up with noisy neighbor problems. So now that we have an overview of how we think about these features at Twitter, let's talk about how we actually use them in some of these different types of projects. The first one I'll talk about today is this marketing project. The goal of this project is to generate an internal dashboard based on some filters, where the result of this report will actually be used to drive marketing insights and strategies internally. Generating this report requires running multiple BigQuery queries for each of the different sections of the report. So here, some of the first optimizations we made were to partition the input tables by time and to give the project more query slots to use. These 2 steps, partitioning the input tables by time and giving the project more query slots, are generally our very first 2 steps every time. The reason is because these are very low effort and very high impact steps. We will do this across most projects. Here, we also clustered the input tables by user IDs because that's what the report is keyed on. And we also scheduled a projection of necessary columns out of the source tables and into a destination table. In that destination table, we also joined in a couple additional columns just so all of the data for this particular report is available in one table ready to go. Having all your data in one table like that is actually a huge speed up just in and of itself. As part of this, we also helped this team clean up their queries by making small tweaks here and there, such as removing unnecessary order by clauses. All of these things together resulted in a 33% faster average query time and a 45% faster end-to-end report generation time for this use case. The next use case that I'll talk about today is the A/B experimentation project. This team already has an analytics use case running on-premise in Vertica. So in this case, we're migrating from an on-premise Vertica cluster into BigQuery. The goal of this use case is to fetch the results of A/B experiments on the Twitter product and render those in a UI. Users of the UI will actually use the insights they gain from the UI to drive product decisions. The interesting thing here is that the table that powers this UI has the high hundreds of terabytes of data in one place. We also have a very low latency requirement because this is powering an internal dashboard. So here, we partitioned these input tables by time again and gave it more query slots to execute. Again, we do this for almost every project. We also clustered these tables by more than one ID. Like Juggen mentioned, you can cluster by more than one field, and we want to do this in order of highest cardinality first to eliminate the most amount of data in a query as possible. We also selected only the necessary columns out of these source tables, whereas the Vertica query before was selecting all of the columns. And finally, one of the more interesting performance optimizations we made was using an array aggregation clause in BigQuery, where in Vertica we had been using a row number over clause. We use this to identify the most recent row in a set of rows to populate part of this UI. All of these things together ended up speeding up the queries by 55%. And the final project that I'll talk about today is a tweet analytics project. For this project, we want to generate a report of recent actions on entities. The interesting thing about this one is that we're migrating from an on-premise Solr cluster into BigQuery, and also the BigQuery table is populated via BigQuery streaming. The table is also massive. It's multiple petabytes of data in a single table. Here too, we partitioned the input tables by time, and we gave the project many, many more query slots to work with. We also scheduled the projection of the necessary columns to generate this report out of the source tables into a destination table again. Here too, we also saw a nice speed up with that. The most interesting thing that we saw here though, is we had to tune our storage set sizes. BigQuery tables are backed by storage sets, which contain files which contain records. Storage sets have a maximum size limit. So when a storage set fills up with records, it actually gets committed and creates a metadata entry with it associated with the table. When a query wants to run on a table, it has to process all the metadata for the different storage sets to decide which storage sets actually need to be accessed. If there's a lot of storage sets, there's a lot of metadata entries, and processing a lot of metadata entries can actually slow down your query. So in our use case, we worked with Google Engineering to increase the size of our storage sets. More storage sets, or larger size storage sets, means fewer storage sets overall because each one can hold more records. Because there are fewer storage sets, there is less metadata entries for a query to have to process, which actually ends up speeding up your query a good amount when you have a high volume of streaming inserts into a table. All of these optimizations together resulted in 33% faster queries for this use case. And that's the last use case I'm going to talk about today. I want to give a huge shout out to everyone at Twitter, cross-functionally, at Google PSO, and at Google Engineering for all the help that they've given up to today. Google has helped us build additional tools for Twitter internal data format. They've helped us build dashboards and administration tools. They've helped us increase DML efficiency by changing things in the back end. And they've increased limits in GCP all over the place for us. Some of the most notable ones are for VPCSC, or for the amount of data that a particular query can process in a single go. Without all of these things together, we wouldn't be near where we are today. And we're really looking forward to continuing our adoption and growth with BigQuery at Twitter. So thank you to everyone who's been involved. I'll pass it back over to Jagan now so he can wrap up the rest of this presentation.
I hope you found this session useful and some of the performance tips and techniques that we shared with you today. I want to thank my co-presenter, Gary, who shared his best practices of using BigQuery at Twitter. And I want to thank you for watching this session.
Now, so we are back from watching videos related to streaming and related to, now I forgot, how to optimize BigQuery performance with lessons learned by Twitter. Lucky company to push the boundaries of BigQuery and also to change, like he said in last sentences, to withdraw some of the limits, probably thanks to their effort. We have more. As always, on our live discussions, I want to bring into that discussion my lovely trio. Marek Kaczor, Michał Herman, and Adrian. Hi, guys. How did you like it so far? So, I will a little bit pinpoint, because as always we had a chat internally during watching the videos, and we got some points of interest. So in the streaming, let's talk first on streaming, and quite a generic question, maybe even to Marek. How do you think, is the Google Cloud platform stack good for streaming? Is it like something which distinguishes them on the market?
Yes, I can say yes, based on my own observation and experience. It is pretty easy to set up streaming. It is pretty easy to analyze data in BigQuery which are streamed. So from the perspective of data engineer or data architect, the task is easy and works.
Yeah. So I experienced one of the demo pipelines myself recently, that my sensors are sending something to PubSub, and from PubSub I decided to see how the template from Dataflow looks like, the template thing mentioned in the first presentation. And there are ready to go templates which will bring PubSub messages to table in BigQuery. Nothing sophisticated to do, but if you want to deep dive or fine tune, you have to dive into Beam, you have to dive into Python, and make more adjustments, which are not possible through clickable UI. We also have this interesting point of real-time AI, and I think Michał had some nice comments. Michał, can you chime in on that? Unmute yourself somehow, somewhere. Classical, new era.
Hello.
New webinar era, trouble, no voice. Interesting thing to say, but no voice. Now it's okay.
Okay, great.
Now we can hear you. Can you chime in a little bit on the real-time AI?
Yeah, so right now the BigQuery is expanding their portfolio of capabilities into more streaming, more real-time functions, and one of them are the facilitating the AI and machine learning, that in the more standard models had to first gather the data, then train some models. Then after some time, after these steps, you only can take some insights and some data of it. And now with streaming, this can be done almost in the real time. That means if you are doing some anomaly detection, you can be notified about these anomalies like seconds after they occur. You don't have to wait a long time and train a long training and modeling time to be able to catch that, which for some applications like financial applications are critical to do it on the fly.
To catch a fraud immediately, like it's happening, and for example, block the card, right?
Yeah,
that was one of the use cases mentioned on one of the presentations. That's great. And a little bit to the BigQuery optimization. I know session was highly technical, and this is like a guidebook for BigQuery intermediate, advanced people, so maybe not for business end users, which we have on the stream. But in this respect, we can help a little bit as Lingaro. So small marketing here. We do the BigQuery optimization, and I read that Adrian could address that a little bit.
Yes, so in real-time or close to real-time solutions, often there is a cost optimization challenge because streaming approaches are more expensive than regular ones. And nowadays we do have easy access to streaming solutions, but we need to have in mind to choose the right architecture concept and the right implementation to our specific case. And being aware of that, we need to define which data are urgent events in our process and really need to be processed in real time, and which data can be delivered with latency. And GCP gives streaming possibilities, but the key is to choose the right approach, because often the hybrid solution with both batch and real time is the best one. And we can help our customers to choose the best way.
Yeah, because it looks like there is a large stack and it still grows. I especially like, thank you, Adrian, for that comment. I especially like the news that Jupyter notebooks will be a little bit like IDE, preferred IDE for pipelines, for streaming, for that kind of feeling I'm getting, because everywhere they are shown. Which could be a nice function, because modern data scientists they tend to use that stack, and it's good that from single cloud instance they have a view on Jupyter Notebook and can play around with all the bits like Dataproc, Beam, Google BigQuery, and this all stays in the same setup or the same infrastructure. Okay, any other points which we should put here? Any other comments from the audience? If anybody views us live and have even tough question for us, I'm really willing to take a shot. There is a small delay, so we need to wait for that question to come up, but I hope it will come up at the end, either for this or next session. We are still there with this team to comment on the topics. Anything out from us more on these? Or we're closing the session, guys? No ideas? No ideas.
So maybe one comment from me, that lately the BigQuery is pushing new functionalities like materialized views, like partition pruning when you have partition tables. And even for some solutions that like 2 or 3 years ago, the BigQuery was too slow for these solutions. But right now, there can be done on BigQuery. So it will maybe worth to reevaluate these projects if they are worthy to moving to BigQuery now as the new performance solutions are introduced.
That's a very good point, because many myths are coming, not myths, but some prejudice to some of the points to any of the tools of the cloud comes from experience maybe from the past, like some of the stuff might be not anymore valid, especially when software changes so rapidly as it changes right now, and you don't have to even install that newly, right? You don't have to follow the release, you just have it. You just like the recent announcements of BigQuery, new functions like possibility to create a table based on files from the storage, or possibility to make dynamic SQL defined with I forgot the syntax now, but fresh things are coming in, and you could be surprised that it was not possible, but it is. So thankfully, the team is catching up on that stuff quite quickly. Okay, gentlemen, I think we close that discussion session. We go forward. Our next videos, let me look on the list, is awesome new features to help you manage BigQuery, because there's plenty more on administration side, and petabyte scale reporting pipeline on GCP. Let's see how this case was built. Thank you guys for now, and see you soon.
Thank you. See you.
Let me go back to sharing of the next video. Next video will be played soon. One moment.
Welcome to DA300, awesome new features to help you manage BigQuery. My name is Tino Tereshko, and I'm a product manager on Google BigQuery. So BigQuery historically has been a serverless data warehouse, which kind of means a lot of things to a lot of folks. But in practicality, what it means to you is that you get unlimited scale. BigQuery is very easy to use. It's automatically self-optimizing. There's no virtual machine related performance cliffs of kind of unexpected behaviors. It's got a high level of reliability and a lot of other features. And of course, we recently announced that we now have an industry best 4 nines of availability in our SLA. So all of these are benefits of serverless that you get as a BigQuery customer. Now, folks who are on the far end of the maturity spectrum, right? Large enterprises, multinational organizations, they actually do want more control, more predictability. So over the years, we've built out a number of features and functionalities that enable those organizations to take the control of BigQuery while kind of getting the best of BigQuery being serverless. In fact, we kind of built BigQuery to be for everyone, right? Whether you're a startup, whether you're a student, you're just kind of experimenting in your garage, we have functionality for that, right? Where you care about simplicity, ease of use, you want to experiment quickly. And then as you're growing and you have larger scales, you want more flexibility, you want more efficiency, more predictability, we give you that functionality. And again, all the way out to the largest enterprises where you have potentially exabyte scale use cases, you want control, you want predictability, you want monitoring, you want administration. So we are there to provide you functionality wherever you are on this gradient. And actually, if you move from the startup to grow up to large enterprises, you can take advantage of the various functionalities that we have here. Brilliant. So let me illustrate this whole concept through a fictional company. And so why not spruce up the administration topic with a little bit of cats? So this is actually my cat, Rascal. He's just like any other cat. He's got a lot of personality. And his interests really include naps. He really likes being pet. He stalks the neighborhood quite a bit, right? So that's his primary things in life that he cares about. So what if we used cutting edge technology to really figure out what Rascal does all day and what he thinks and what drives him to really provide a better user experience for Rascal? So with that in mind, we thought about critical feline requirements, so short for CFRs, really. And so the first topic, of course, is naps. So what do we need to know about Rascal's naps? Well, we need to know how often he naps, where he naps, locations, and actually total nap time, right? Which tends to be about 20 hours a week, 20 hours a day. The second one is Rascal loves being pet, but he does, there's a certain threshold to petting. So we need to know what is this optimal number of pettings that he can sustain.
Does he like to be pat on the belly? Does he like to be pat on the head? That's very critical to understand. And finally, for our sakes, we need to know how likely is Rascal to be upset if we give him just one more pet. That's really important to know. And finally, the third interest of Rascal is he's stalking the neighborhood. So we need to know the perimeter that he's patrolling. What is his territory? And a different cat right down the street has a different territory. We need to know how often he patrols it, and maybe we can even map the social network of Rascal and how he interacts with all the other cats. So these are all really, really critical things to know about felines. So with that extent, we're introducing 23 and Meow. This is a brand new innovative startup. It's Internet of Cats. What 23 and Meow does is it provides smart, connected collars for cats. Let me explain. So you put this collar on your cat, and the smart collar has lots of different sensors that collect telemetry data in real time. So there's a geospatial capability, so it gets location of Rascal. There's a temperature sensor. There's an accelerator meter that will tell you what the velocity of your cat traveling and the acceleration. There's also a microphone and a camera, so you can identify sounds and even take video and pictures. So all of that data gets captured and collected in real time, and then we perform predictive real-time analytics on that information. And so in this sense, we give you a better picture of what your cat does all day and what are your cat's preferences. It's beautiful. So let's take a look at the tech stack. All right, so 23 and Meow heavily relies on BigQuery. In fact, it's essentially the only thing that 23 and Meow is doing. They picked BigQuery because it's very easy to get started. Its time to market is critical because there are other similar startups that are trying to do the same thing. So 23 and Meow wanted to pick technology that's serverless, that's easy to get going with, and also easy to grow with. So let's walk through this technology stack. So first of all, we already talked about how a number of sensors are sending data into BigQuery in real time. That includes geospatial sensors. Right? So geospatial data comes into BigQuery. Point number two, this data is ingested in real time using BigQuery's unique real-time APIs to get that data into BigQuery for immediate access. Number three, BigQuery's new integration with AutoML and the cloud AI stack enables us to perform machine learning right inside of the data warehouse, right inside of BigQuery on this real-time data. So we've developed cat behavior models like danger of incremental pettings. How about the favorite body part to be pet on? And actually favorite nap time locations. These are all really advanced machine learning technologies that we've implemented here to develop this functionality. And number four, we have a number of public data sets that we include, that we enrich our data with. So for example, weather, right? That depends what your cat does, depending on what the weather outside is. And then we're using materialized views, and we're moving the data into BI engine. And that's number five. And of course, a new upcoming BI engine enhancements allow you to run BigQuery SQL on top of BI engine. And number six, Looker that recently joined our family is used for dashboarding of this data. So this is an entire stack that essentially lives on top of BigQuery. Now, if you take a look at those things, 1 through 6, all those things are essentially unique to BigQuery, or almost unique, which means that you don't need to build out a number of different technologies to take advantage of all these things. This is all integrated right into BigQuery for you. It's beautiful. So we started out small, right? We rolled out our startup. We have a few trusted cats that we're using. And so we're just using BigQuery's perpetual free tier. If you're not familiar, you get 10 gigabytes of storage for free every single month, and you get a terabyte of data processed every single month. And we do this in perpetuity, no strings attached. You can keep using that free tier for as long as you want. But now that we've kind of expanded our offering beyond the trusted cats, and now we have 1,000 cats that are using our collar. So we're growing with BigQuery, right? We're on that gradient. And so we're using the BigQuery's on-demand bytes processed model, right? This is a billing model that is purely consumption. You're only paying for what you consume. You pay per query, right? So there's no wastage, it's super efficient, and there's zero administrative overhead. You don't have to think about anything. There's nothing to set up. But if you want to kind of manage your cost and make sure there's no, runaway bills or anything like that, we're leveraging cost controls. Beautiful. So now we've thought about how do we expand our offering to make things more interesting. So we introduced an additional sensor to our cat collars that actually measures cat pheromones. It kind of actually smells what the cat smells like. And it tracks the cat pheromone excretions and then runs machine learning models to understand what your cat is feeling at that particular moment. So this is called the Emotions API, and it's available to all of our 23andMe customers today. So on the back of the Emotions API, 23andMe has become really successful. We now have a whole 1 million daily active cats. Phenomenal success. But now actually our infrastructure costs is starting to grow as well, right? We're running more analytics. We're using more CPU and RAM. We have more dashboards. So our leverage of BigQuery is growing. And so we need to start kind of worrying about maybe monitoring it, maybe administering it a little bit more. And so the question pops up very typically with BigQuery customers is, are slots right for me? Right? For the uninitiated, there's 2 billing models on for BigQuery. There's the batch process model that most customers start out with, and then there's the slots model. And the slots model is optional. It tends to be for the larger customers, and it has some really nice benefits. So the question is, are the BigQuery slots right for me? Well, in order to help our customers figuring out if that is the right option, we're launching something called BigQuery Slot Recommendations. It's currently in alpha. So this is advanced machine learning logic that we will run on your usage data, and of course using all the right privacy controls, and we will tell you proactively whether the slots model is the right model for you without sacrificing performance. So you could potentially save money without sacrificing performance, which is fantastic. And of course, the other pricing recommendation that we launched kind of helps you figure out whether you need to use monthly slots or annual slots. Go use that today. And there's a related session called CMP 100 that talks about that in a little bit of a greater depth. So what are BigQuery slots? It's a very frequent question that I hear. Well, it's simply a slot is a CPU, right? You can think about it like that. And a CPU processes your queries, runs analytics. So whenever you purchase a slot or a number of slots, you purchase analytic processing capability. You purchase throughput, which means that a number of slots that you have will either give you faster queries or will give you more queries to run at the same time, or both, right? You're kind of buying a cluster of BigQuery with BigQuery slots. And you can buy slots today in with a per second commitment, per month, or per year. The per second commitment is called flex slots. And there's no difference between those slots except for flex slots you can cancel just after 60 seconds. So you can use them whenever and cancel them whenever. But they're a little bit more expensive. Monthly slots, you commit to an entire month. So you can't change, you can't cancel them or downsize them for the duration of a month, but you get a little bit of a discount on that. And then annual is, of course, the cheapest option, but the least flexible, right? You commit to a full year for that capacity, but you get a discount. So how are queries using slots? Let's talk about that. So a query really inside of BigQuery is a dynamic DAG, directed acrylic graph. What that means is it's what does dynamic mean? Dynamic means that as the query progresses, our query execution plan changes. Right? We learn more about what you're trying to do, we learn more about the data patterns, and we decide on the fly the best path of execution. This is really, really powerful. It really accelerates queries for you. But what does the DAG part mean? The DAG part means that a BigQuery query is a series of stages. Now they can run in parallel, they can run serially. There's all kinds of patterns that we can are leveraged there. And each stage is essentially a tiny mini query in its own right. Each stage has a parallelization factor, anywhere from 1 to, I've seen billions, which basically BigQuery says, I can parallelize this particular stage of the query by so and so amount. And it's very typical to have this parallelization factor in thousands. And a slot is essentially that CPU that executes a single parallelization unit of a single stage. So in this particular picture, you see the first stage has 10,000, a parallelization factor of 10,000. That means that BigQuery could use up to 10,000 slots at any point in time to execute this particular stage of the query. But now, if 10,000 slots is a lot of slots. If you have a little bit fewer than 10,000 slots, we will simply burn through the slots that are not available with time, right? So let's say if you have 500 slots will execute that stage, and then 9,500 slots will essentially queue up. And then as the first 500 slots free up, they will burn through that pent-up demand with time. And so think of a query as a series of stages, and each stage consumes any number from 1 to billions of slots potentially, and each stage doesn't have to get all its slots. It will kind of wait for the slots to come in. Hopefully I explained that well for you. Now, when you have multiple queries running concurrently, what happens in BigQuery? We use this concept called fair scheduling. What that means is each query gets equal right to the available provision slots. Now, if a small query comes in, it doesn't have to use its equal right. It potentially could use only a single slot if it's a small query. Or on the opposite end of the spectrum, a query could request millions of slots, but they get equal right to the capacity that's available. Now, I've mentioned this before already. If a query doesn't get 100% of its requested slots, those slots just kind of queue up, right? So it will burn through that pent-up capacity as slots become available. And the final thing I want to mention is BigQuery continuously does this recalculation. This happens in real time. So whenever new queries come in, we will redistribute slots in line. Now, the effect here is queries speed up or slow down in real time rather than kind of cancel or anything like that. So let me give an example. So here on the right side, you'll see that the environment has 2,000 slots in total. And there's 4 queries running in there. And they're fairly large queries, so each one is asking for 500 slots. So for the maximum amount of slots. So our fair scheduler will actually give each query 500 slots. And let's say a 5th query comes in, that's a large query, and it needs a lot of slots as well. What we're going to do automatically in real time is we're going to take 100 slots away from each of the 4 queries. We'll just pause that work. We're not going to waste it. And we will give it to the 5th query. So now we have 5 queries running with 400 slots each. What that did to the original 4 queries, it just made them a little bit slower than before. So the system works really, really well. It actually biases against large runaway queries, right? And it biases 4 smaller queries that are higher, that have lower latency requirements. So it's a very, very useful pattern. So BigQuery slots pricing, let's talk about the benefits here. The first one, of course, it's predictable, right? You control how much you spend, right? You explicitly tell us, I want to purchase X amount of slots, and it's gonna cost me a certain amount of money. Now, I've mentioned before, we have 3 types of commitments. We have monthly, annual, and flex slots. Monthly and annual require you to commit to 30 days or a full year, and flex slots essentially have no commitment period, so you can purchase them and cancel them whenever you want. The other thing is we don't rely on t-shirt sizes. You can buy slots in a number of granularities, and that's really, really powerful. The second part I should say is a lot of features come with slots. We don't have a special type of slots that you have to purchase in order to get materialized views. We don't have a special type of slot you need to purchase in order to buy advanced security features like customer master encryption keys, like time travel, like DDoS protection that we provide. All of that is included in slots. We also do things like batch ingest. It actually doesn't consume your slot capacity. It doesn't contend with your queries, and it comes from somewhere else. So you really don't pay for batch ingest at all. And we also do a lot of background processes like automatic reclustering that we don't charge for at all. So it's something that we provide to you as a service to make sure that your queries are running exceptionally well, and we don't charge you for it. Now, and of course, the industry best 4 nines of SLA just comes with any slot, right? You don't have to pay extra for it. I should also mention that all of these properties you get with bytes process model as well. And finally, because we are serverless, because we're not bound to virtual machines, we get to provide some really interesting benefits to you, right? Our architecture is very unique in that sense. So the first one is we can provision capacity almost instantly, right? We don't have virtual machines to spin up a provision for you. We don't need to move data into your virtual machine to get performance, right? It's just serverless. It just lives there. So for us, scaling is just a number change. The other thing is, of course, the virtual machine doesn't have to be pre-warmed. Data doesn't need to be moved into the virtual machine, so you get optimal performance immediately. And the final bit that's a little bit hard to capture, but it's really, really important for real-life use cases. Whenever you increase capacity, it impacts your queries in flight immediately. So if you have a query that's running inside of your environment and you need to accelerate that query, adding more capacity will do that immediately. You don't have to undo the query, cancel the query, and start a new one, right? Queries in flight benefit from capacity changes. Fantastic. One last comment on the different commitment types. I want to make it really, really clear. So we have 3 commitment types: flex slots, monthly, and annual. And so think about what is the proper use case for how to combine these. You don't have to use only one of those types. It's just slots again, and the difference is the length of the commitment and price. So you can think about it workload by workload. You can have a steady state monthly or annual commitments there that are used 24/7. And you get a lower price for them. And then you can use flex slots to have kind of like this burst addition capacity to the steady state that is used for seconds, minutes, hours, or potentially days, right? So you can combine these two, and that becomes really, really powerful. I'm really delighted to announce that today we're offering 100-slot pricing. So before today, you had to commit to 500 slots, which admittedly is a little bit on, kind of a lot for a number of our customers, right? So with a monthly contract, 500 slots was $10,000 a month. So a lot of our customers really wanted to start using slots pricing, but they wanted a lower price point. So we're introducing 100 slots. What that means is on a monthly contract, it's $2,000 per month. On an annual contract, it's $1,700 per month. And on a flex contract, it's just $4 per hour, right? So you can purchase 100 slots, cancel them after 1 hour, and you only pay $4. So it's really expensive, and I'm hoping that a lot of our customers embrace this model. We're continuing to expand our administration functionality in many different ways. So admin panel UI is one of those investments that we're making. It's on the roadmap, and we're hoping to make it available in the next few months. Essentially what the administration panel UI does is it's a BigQuery native monitoring and administration platform. It allows you to chart how you're using BigQuery in real time. So it's going to allow you to monitor slots, resources, queries, jobs, users, and so on and so forth. You'll also be able to do this in real time and historically, going back 30 days or more, which means that you can zoom in and zoom out depending on the use case. For the real-time use case, you can identify whether somebody in your organization is using too much and perform root cause analysis in that way. Whereas if you zoom out historically, you'll be able to decide whether you need more capacity or less capacity based on their various usage patterns. The next set of features that we've recently launched is information schema views. Now, a number of these views are already available. Some of them are general availability. And what these views allow you to do is in real time and historically, again, you can see everything that's going on inside of BigQuery. So today we have available jobs and reservations views. We're going to be soon launching streaming views. So if you're streaming data into BigQuery, you can see what's happening there, error rates, bytes ingested, things like that. We're also going to provide storage views. So you can see how much data is stored in each of your column, each of your partition, each of your table, and how it's being used. And eventually, we're going to actually get into permissions as well. So some of the benefits of information schema that we provide, well, for one, it's just automatically managed by us. It's the data that we provide for you, and we don't charge you for the storage. So that's really nice. It's just there, and you can start using it. It's live, right? So this is consistent sub-second latency of information that's provided to you. It's also historical, so we get up to 6 months of historical information in these tables automatically free of charge. The other benefit is for larger organizations that have lots and lots of projects, we provide you an organization-wide view. So you don't have to kind of query every single project to figure out what's going on. You can query information schema tables for your entire organization. So there's lots of really interesting use cases on top of that you can leverage these tables with. Fast forward a few months, and 23 EMEA has been really, really successful, but we've decided to launch some new features. Because we have been capturing sound for a long time using our microphone on these collars, we started developing machine learning models that help us understand what the cat is actually saying. And then we've developed a two-way language API that allows us to understand cats, but also to communicate back. So it will actually translate human English language, only English is supported for now, into cat meows and purrs. So it allows us to communicate directly with the cat. This is a fantastic feature, and it immediately propelled us to become a global phenomenon, right? We have today 1 billion daily active cats, and we're a multinational organization. We operate in 145 countries. It's just an amazing success that we've experienced so far. But we've grown so fast, and so we are a large organization now, but we're still using BigQuery as the same core of our technology. So how do we obtain more control? What kinds of problems are we facing as a 1 billion daily active cat organization? So for one is we really care about price. We're about to go IPO, and so we need to kind of get our finances in order. So we need to control the cost. We need to control the cost of the organization as a whole, and we need to control the organization all the way down to individual users. We also have some really critical SLAs. We actually run our machine learning models often right in BigQuery. So those are very important workloads that we have, and we need to make sure that those get the right resources and they finish in the right amounts of time. So that's critical for us to have workload management capability. And the third one is cost attribution. Again, we should be able to trace every single action that's happening in our environment and down to the user that has caused that action so that we can attribute costs. So these are all very much enterprise-grade, billion daily active cat problems that we're facing. So to support these use cases, we launched BigQuery Reservations. This is a general availability platform for workload management and cost management inside of BigQuery. BigQuery Reservations today enables you to purchase slot commitments in seconds, again, monthly, annual, and flex types. Then you can take that capacity and you can departmentalize, you can isolate and partition it into individual departments or teams or sets of users, right? So if you have X amount of capacity, you want to give the individual use cases their isolated pools. So we allow you to do that. And finally, it allows you to share any unused capacity across your organization. So in the periods when there's not a lot going on, that capacity is not wasted. It's available for the rest of the organization to be used seamlessly and automatically. So let's think of a typical use case of how reservations are used in practice. So let's say we figured out that 1,000 slots is what we need in terms of capacity. And we said that 500 of those slots are going to be our steady state slots, and we can lock them in on a very inexpensive annual contract. And then 500 slots are going to be flex slots, simply because maybe we want to have more or less, we're not entirely sure, so we do want that flexibility. But in total, we have 1,000 slots. That's our capacity for data processing, right? A slot is a slot. Step number 2, we're going to take those 1,000 slots, and we have 3 different business units. We have the team that manages Pheromones API. We have a team that manages the Languages API. And we have a team that manages BI, all the dashboards. That's 3 separate teams within our organizations. And the Pheromones is, of course, where we make all of our money. So we're going to give them 500 slots. The Languages team is really important, but it's a newer feature, so we're going to give them 300 slots. And then BI is going to get 200 slots. So we've partitioned these workloads into these departments. And finally, the third step is we assigned all the relevant projects to these reservations. And off we go. That's all we have to do, set and forget. Here's a new feature that's going to help even further with this type of use case. BigQuery slots auto-scaling is coming soon. What BigQuery slots auto-scaling does is it automatically provisions and deprovisions capacity for you based on how you're using our platform. Right? So it's really, really advanced functionality. So again, because we're not running on virtual machines, because we are serverless, we're able to give you a lot of benefits that traditional virtual machine-based data warehouse cannot. For one is we have 0-second warm-up. The moment you get your capacity provisioned, your capacity is at 100% performance. There's no such thing as hydrating your local disk to make sure the performance is optimal. The second, as I already mentioned, whenever you increase capacity, your queries in flight take advantage of that immediately. The third is, again, because we're not running on local disk, because we're not relying on local storage, there are no unexpected behaviors like performance cliffs when the local storage goes away or gets saturated, right? We don't rely on local storage. We have true separation of storage and compute. And finally, we express this in our SLA, is we're immune to downtime for individual nodes all the way to large portions of a data center. And that's why we're able to provide 4 nines of the SLA. So let's talk about slots autoscaling a little bit more. So all we're doing here is we're adding one additional variable to the reservations configuration. It's called max autoscaling limit. And so let's walk through this example, right? So what we did is for the Fairmont's reservation, we set the autoscaling limit to be 300. And for the BI reservation, we set the autoscaling limit to be 1,000. Right? And so we did this per reservation. That's where this configuration lives. But we didn't enable this on the language reservation. And so what happens is whenever the Fairmont's reservation needs more than 500 slots, it will try to get that 500 slots from across the rest of the organization. It will try to see if the languages reservation has idle capacity or if the BI reservation has idle capacity. And then it's going to say, well, I still need more capacity than that because I have a lot of data processing to do. And only then will reservations autoscaling kick in. Only then we will increase your capacity by 300 slots, which is fantastic, right? So the only way autoscaling kicks in is if the entire organization is saturated and there's no idle slots to be had. And then if the capacity is no longer necessary, we'll automatically downscale your reservation. So Fairmont's will go from 500 slots to 800 slots and down, whereas BI will go from 200 to 1,200 slots and down. Now, something I should mention is that the current version of autoscaling that we're working on is binary, which means that we will only increase to the maximum amount or back to the minimum amount, right? So in this example, the Fairmont's reservation will only be at size 500 or size 800. There's no intermediate state. And of course, eventually we will have all these advanced autoscaling modes as well. So how does autoscaling work with steady state capacity? Well, really, you think about it, you can purchase monthly, annual flex commitments and keep them as steady state capacity that is always there, that's guaranteed for you. And then you can turn on autoscaling on top of it to provide burst, and it's managed for you, right? Autoscaling only kicks in when necessary. How do you pay for it? Well, what we do is we purchase flex slots for you. Right? So autoscaling underneath the hood uses flex slots, and so you pay the flex slots rates. Now here's a really advanced capability that autoscaling provides for you. Starting from 0. This is kind of called the auto pause or auto start use case. So in this example, we actually have 0 commitments. We've purchased 0 slots, and all of our reservations are sized to be 0, which means that there's not a single slot purchased or provisioned, and you pay us nothing in terms of analytic capability. But we set autoscaling for each reservation. Right? So Fairmont's, Language BI, they all have autoscaling limits set. In this mode, whenever a query comes into the environment, we will immediately scale the reservation to its maximum limit, and the query will execute immediately. And then on the opposite side, whenever your reservation is idle, we will diminish it back to 0, right? So this is essentially auto pause, auto start. Your BigQuery environment will only operate when you're running queries, and it will shut down when your queries are not running, which will enable you to save a good amount of money. So I've talked about a number of features that enable you to kind of traverse the gradient of growth, right? From a tiny little startup or just trying to go to market quickly to a mid-sized organization, all the way to a multinational organization with complex requirements and complex needs and reporting and so on and so forth. So let's kind of summarize everything that we've talked about. So on the pricing front, we have flex slots that went GA at the end of June. We recently launched 100 slots. So now you can purchase capacity for as little as $2,000 a month with a monthly contract, or $4 per hour with the flex contract. And the other thing we talked about quite a bit is the fact that we share idle capacity across your environment. It doesn't go to waste. The second point is workload management capability, right? So once you have this capacity, how do you actually break it up into your departments and workloads? Well, reservations is the powerful platform that enables that, and it's GA. But we recently announced slots auto scaling with that additional level of automation that enables you to scale up and down and only pay for what you consume. And finally, we talked about Animal Panel, which is the visual UI that we'll provide to help you monitor and perform root cause analysis on your environment. And finally, intelligence, higher level data and logic that we'll provide to you that will help you drive your decision making. So of course, information schema is a project that will have a series of views that will enable you to get data, and slot recommendations, just our first step in this advanced intelligence that will tell you exactly what's going on in the environment and will recommend to you further action. Now, actual administration knobs and performance is just one part of the story. Of course, as an administrator, oftentimes you care about performance. We'll continue to invest in this area. Throughout the years, we've always made BigQuery faster and faster and faster and faster. So just from this beginning of this year alone, from January 1st, we look at the industry standard TPC DS benchmarks, and we measure our performance improvements to be anywhere from 20% to 30%. And the way you get this benefit is just the next time you run a query, you would just get a better performance. We perform these optimizations for you on the background. We roll out code without disturbing your environment. You just get these benefits, and you get these benefits without any additional cost. So this is a trend that we have, right? Every few months, we add some better performance optimizations. Your queries just become faster and faster and faster and faster, and this trend will continue in the future. So we talked about this quite a bit, right? When you're starting out, you really want the easiest path to go to market. You don't want to worry about things. And so our serverless capability enables you to do that. There's nothing to set up. You only pay for what you consume, and off you go. But as you grow, you care more about different things. You care more about control and predictability. And so we built out a series of capabilities that enable you to take advantage of that. But the key is that all of these things are optional, right? You only need to use admin panel if you care about predictability and control, and you're a certain size. So please be mindful of that, because we have a lot of customers that are on the larger side, but we have lots and lots of customers that are on the free tier or have very, very little data inside of BigQuery, and that's perfectly okay, right? BigQuery is built for everyone. We recently talked about trial slots. So this is a promotion for new BigQuery customers that enables you to get 95% off of slots. So essentially, you can buy 500 slots for a duration of 6 months for $500 per month. This is a 20th of the cost of a monthly contract. Right? So just $1 per slot per month. Of course, it's just slots, so you can combine them with other types of slots. You can combine them with other flex slots, monthly and annual, and so forth. And of course, it covers all of your SQL queries that you run, right? So it's in a good amount of capacity. Now, I should be mindful to tell you that this is a promotion, so certain qualifications and restrictions do apply. So finally, I want to open the floor to everyone to think about the next 10x use case for our tiny little startup, 23andMe. There's lots of things that cats can do, and we're open to collaboration. We're open to more ideas. So send me some of your ideas on Twitter to @TNOT, and I really appreciate all the time that you spent listening to me. Thank you so much.
Hi, everyone. Welcome to our session on building a petabyte scale reporting pipeline on GCP. I'm Minhas Ghazi, a developer advocate at Google, and I'll be joined by Michael Wallman. Michael is an infrastructure lead at Google Cloud Platform. In this presentation, we'll be talking about how GCP and Waze collaborated to implement a solution for a petabyte scale reporting platform. We'll also show how this project aligns with the vision for our analytics program. The database management and analytics vision is on the slide, and as you can see, we focus a lot on an open philosophy. We want to deliver flexible features and apply intelligent Google technologies to help our customers. Throughout the presentation, we'll be talking about business requirements and challenges this project had, and then we'll also talk about the technical architectures and data pipelines. Finally, we'll talk about the connector we created and then the dashboard solution we came up with and the outcomes. But first, here's Tommy Hunt from Waze, who'll be talking about the business requirements and challenges.
Thank you. My name is Tommy Hunt, and I'm an analyst at Waze. Many of you may be familiar with Waze as a crowdsourced navigation app that helps get you from place to place. We have over 130 million monthly active users across 185 countries that collectively completed over 1 billion navigations in 2019. Our partners and users reported over 60 million traffic incidents each month, and our map is maintained by 30,000 volunteer map editors. Best of all, Waze is completely free for anybody to use. Under the hood, Waze is even bigger than that. We're a mobility platform that helps people move more freely in the communities where they live and work. Just as we give users access to real-time information within the app, we also partner with over 1,300 cities, towns, and nonprofit organizations to share that data through a program we call Waze for Cities, helping to inform their mobility strategies and their responses. In fact, we currently help with more than 60 crises each year, such as hurricanes and earthquakes, and we're helping cities get safer through beacons by giving drivers a way to stay connected even when they're out of range of GPS. In our newest initiative, Waze Carpool is helping to combat the rising congestion in cities around the world. Our city partnerships and community-driven approach is what makes Waze unique and sets us apart from other navigation apps. If you're interested in learning more about Waze, or if you're interested in becoming a Waze for Cities partner, visit waze.com/wazeforcities. Now, through our Waze for Cities program, we offer a variety of tools and offerings, which include data sharing, carpool, beacons, and crisis mitigation. Today, we're going to focus on how Google Cloud has helped us improve one of these offerings, the data that we share with partners. Through our data sharing offering, Waze provides real-time proprietary incident and slowdown information generated by millions of Waze drivers to inform our partners' mobility strategies. The data we share includes user-generated reports like traffic jams, crashes, constructions, and potholes, just to name a few. Now, before we began working with Google Cloud, Waze data was shared with our city partners via a geo-RSS feed in JSON and XML formats. Partners had to take a lot of steps to begin using this data. These steps included ingesting, storing, and then paying for the ongoing storage of this Waze data, among several other technical details. Needless to say, it was really difficult for many of our resource-strapped city partners to consider this process, which really limited most of our partners' ability to use our data at all. So that's why we turned to Google Cloud to find a way to manage and share this data with our partners in a simpler and overall more cost-effective way. Now I'll turn it over to my colleague, Michael, to talk about the technical implementation of this tool.
Okay, hi. So starting with the Waze and Google Cloud Platform integration. So obviously, BigQuery, we started with BigQuery, and in combination with Data Studio was the platform or the services of choice. Okay, challenges. So first, we needed to ingest data from an outside source. So Waze provided us an API to hit, and we use that API to pull in data, all the world's traffic data. Another challenge is that the system had to support thousands of partners at once. So there was no telling when partners were using the system or making queries. So therefore, we had to assume that there'd be a lot of concurrency in the thousands. Simply user-aware dashboards, meaning that if I'm a partner and I go to a dashboard, I would like to see the data that's relevant to me, whereas another partner should see the data that's relevant to them without moving around or having to set that on every login. So that was really important. Another challenge would be if I were to make changes to the default dashboards, they should propagate for all partners. So I didn't want to have to edit or have individual dashboards per partner. It was a requester does not pay model, meaning that partners are not charged for this service, and that Google or Waze in this case is providing the service for free. And then one of the major challenges, which wasn't technical, is that it was a small development team with little to no SRE support. Okay, before I go into details on the technical architecture, I want to call out a teammate, Egan Soares from our LATAM customer engineering team, who really helped design and develop these pipelines. I myself worked with Egon, but also mainly focused on the connector and the dashboard development. So number one, we had our data pipelines. So we ingested the world's traffic data in essence, into BigQuery. Number 2, user management, partners onboarded to the system through a simple web portal. And then number 3, they go to a default dashboard, they get access to the data that's of interest to them. And number 4 is like how to use the partner's behavior, how the partners are accessing the data to make judgments on what data is valuable to our partners and what dashboards are they really finding value in, so we can modify the dashboards accordingly. Okay, the data pipeline. We used App Engine Flex and its cron functionality to stream data in from Waze's traffic API into BigQuery partition tables. And so cron would run periodically, and we would basically query the API and pull in all the data for that period since the last run and write it into partition tables. And then from these partition tables, we set up BigQuery scheduled jobs. And so what they would do is they would transform and dedupe the data, writing into cluster tables in BigQuery. Okay, user management. The user management consisted of partners logging into a web portal and selecting the polygons they're interested in. And this gets written into a partner table in BigQuery. We chose to use BigQuery because just for simplicity, it's not, I mean, this is a very small table, so it doesn't really fit the BigQuery use case. But for simplicity, we just decided to keep the user information in BigQuery as well. So following a similar pattern as the data pipelines, we have an App Engine job that that uses cron to run periodically. It looks at the partner table, and based on changes, whether a partner gets added or removed, it creates authorized views for these partners in BigQuery. Now, you see, as you see from the diagram, there's something called intermediate views, and we had to add these because of to work around the 2,500 limit of authorized views per data set. So in essence, we have created views of views, and intermediate views basically use an ASCII regex to doc root partners in different intermediate views, and this allowed us to get over that 2,500 limit. And now Minhas is going to cover the reporting requirements.
Thank you, Michael. Stemming from the technical challenges we had, we determined what the requirements for the reporting would be. First was that the data for separate cities were in separate data sets. They would have to be accessed from separate data sets. And there we'd have to ensure data privacy because we didn't want any of the partners to see other partners' data. So if they were looking at a dashboard or any kind of reporting solution, they would only be able to see their own city's data and not anyone else's one. There was also the requirement for the centralized billing to have that frictionless user experience, because since we didn't want the city's partners to carry the bill for these dashboard, the billing would be managed centrally by the Waze and GCP team. So there would be a central billing account that would be taking care of the BigQuery querying through the dashboard. There would also have to be a single point of change for all the dashboard edits. That means if a future change was made to the dashboard or if any kind of update was to be made, it would have to get rolled out to all the partners at the same time. So there would have to be some kind of a easy deployment system for that. And based on these requirements, we decided to use Data Studio. Data Studio is a data visualization and reporting tool that's available freely from Google Marketing Platform, and it works very well with BigQuery. It has a native connector to BigQuery. If you're using BigQuery data in Data Studio, you can use the BI engine to take advantage of its fast in-memory calculations and get very speedy results. So as the team was looking into this solution, we realized that there were several alternatives available. First was using the native connector to create a single dashboard with viewers' credentials. What viewers' credentials mean is that when someone would view the dashboard, their credentials would get passed through Data Studio into the data source, which here would be BigQuery. And then that credentials would be used to enforce what data they would get to see. And here would be using role-level access, either through Data Studio's email-based filtering or BigQuery's current user function. But the limitation here was that if we wanted to use either of those two features, we'd have to merge all those data sets into one single table or source and then filter from there, which became a little bit complicated because there were over 1,400 partners. The second option was to use, again, the native connector, but there would create one template dashboard and then copy over that dashboard multiple times, like each time, one time for each partner, and then edit the data source so that it would point to the right data set. That had its own challenges because it would be possible to copy over the dashboards, but if we wanted to make any future changes or wanted to do maintenance, doing it over 1,400 different dashboards would become near impossible. So we opted for the third solution, which was the custom connector, and we'll go into that more details later. But what the custom connector would do is it would make a customized solution involving Data Studio and BigQuery. It would meet all the reporting requirements that I just mentioned earlier, and this would require very minimum level of development from the team that was working on it. The custom connectors are built on the community connector platform for Data Studio. These are written in AppScript, which is Google's cloud-based serverless scripting engine, and it takes very low amount of effort to build connectors using this framework. Anyone can build a connector. You can connect to any external data sources and pull in the data into Data Studio, and it's also possible to share and publish those connectors so that others can use. If you are interested in learning more about these connectors, you can check out the code lab we have at this URL on the screen. The Community Connectors is already an established program where there are over 200 published connectors available. And here at Google, we ourselves have used this platform to create several connectors to serve data to the public. For example, the Chrome UX connector uses this connector platform to serve Chrome UX report data to users. So it was already a proven solution for us. However, one thing we have never tried with these solutions was that we didn't implement the user-based view in any of these connectors. So what that means is, in user-based view, multiple users will look at the same dashboard, but based on their credentials, who they are, it would fetch data from different data sets, which is a bit different from row-level access because we're accessing completely different data sets, and then the dashboard would get populated with data from those data sets. So this was something new that the team was trying out with the community connector approach. And our end result would look something similar to this, that the connector would get created, and using that connector, we'd create a dashboard, a single dashboard link, and that would be sent to all the 1,400 different partners. When a partner opens their dashboard link, they will see their dashboard with their own data, and they wouldn't have any flexibility or option to switch over to see a separate user's dashboard. So this is the complete user experience we wanted to have. User gets a link, clicks on it, they immediately view their report. So to do this, under the hood, this is what we had to implement. So once the user clicks on the dashboard link, it opens up the Data Studio dashboard. And the Data Studio will then execute the connector with viewer's credentials. The first time any user opens this dashboard, they will have to go through an authorization flow where they authorize this connector to run on their behalf. But this is done only for the first time they use it. For all subsequent times, the dashboard will open up automatically. So Data Studio executes the connector script, and the connector script then takes the user's credentials and figures out, all right, this is the email for this user who's viewing the dashboard, and then it makes a call to the BigQuery REST API to figure out which data set should this user be viewing. So we had a mapping table that mapped each user's email address with a specific list of data sets. So this REST API call enabled us to query into BigQuery and get the result back where BigQuery would say, all right, this email address X has access to dataset Y. So once this information was back in the connector, we'd then construct a new query. And this query string would contain basically this data set ID that we just fetched. So it would say something like select asterisk from dataset Y. But we would not send this query off to BigQuery directly. What we would do is that then the connector would use the BigQuery, the Data Studio Advanced Services to make the query directly into BigQuery. So let's look a bit deeper into that, what that means. To communicate between Data Studio and BigQuery, the native connector directly works. But when we're working with a community connector, the data will usually have to pass through AppScript. and it will have to be transformed and processed in AppScript, which adds a bit of overhead in calculation and latency. Using advanced services for Data Studio, what we can do is, rather than passing the data through AppScript, we can just pass the query itself to Data Studio, and the Data Studio will pass that query to BigQuery directly and fetch the data from BigQuery using a native connection. The data does not pass through AppScript in any way, so it results in a much faster interaction. All the filters are automatically pushed down, and then the users also get a much better, faster dashboard experience. So finally, Data Studio passes that query into BigQuery, which is the final query for the dashboard, which contains only the data set that this user has access to see. And finally, the results are sent back to Data Studio, and Data Studio renders that data in dashboard, and the viewer finally can see their dashboard with their own data. So since in the return query results step, only the user's data set is passed, there is no way for a different user to see that data set, or for this user to see data from a different data set. So what does the end result look like? This is the whole process, but when the user finally opens the dashboard, they get a view that looks something like this. This is the view that all the users, all the 1,400 different partners see. When they open the dashboard, they get a dashboard like this. At the top, there are filters. They can change the filters, they can interact with it, and this dashboard will interactively present the data for whatever filters or selections they're making. Each partner would see only their view and they won't see anything else. And based on this dashboard, the team made some further improvements where they added further pages. They also added some monitoring where they could monitor how the dashboard was being used through Stackdriver, which partners were using it, which partners were incurring additional data costs. It's also possible to set up data limits by partner. So it's a future potential work is where we could potentially take this solution and then built-in limits where each partner would get, say, a certain amount of limit. If they hit that limit every month, then their dashboard won't become visible. Another potential solution that can be implemented on top of this is using Google Analytics for Data Studio. It can be measured how the users are interacting with the dashboard. Which pages are they looking at? Which pages are they spending the most time on? And then make the dashboard much better and faster and more usable for users that way. If anyone wants to build a similar solution using Data Studio, Advanced Services, and BigQuery, these links would be helpful. The first link basically provides a step-by-step guide on how to build a connector similar to this. And the second link contains a code example of a similar connector. You can just take the code example and customize it to your own needs. So what finally happened after this project? This project was launched in October 2019. After launch, there were numerous positive news stories. Over 200 news stories were published on digital trends and venture beats. Right now, over 6,000 users from more than 1,400 partners across the world are using this dashboard every day. And as Michael mentioned earlier, the connector that he created and the dashboard the team came up with, it's working basically in a no-ops fashion, even with such high amount of usage. And there are over 30,000 accesses of the Data Studio dashboard, and more than 800,000 queries have been made in BigQuery by all these partners. Now, Waze, this was a major collaboration between Waze and Google Cloud, and Waze plans to continue to promote the data tools and build education materials to aid traffic planning across the world. And that brings us to the end of our presentation. Thank you.
Welcome back. We are back from mute, and I will ask my colleagues to join in a minute. We watched two presentations, just not to miss on the naming. Awesome new feature to help you manage BigQuery and building a petabyte scale reporting pipeline on GCP. Quite an interesting story of Waze. Let me add to the screen once more. Marek, Michał, and Adrian, welcome back, team. First thought for discussion is: do you use Waze when you drive?
Yes, I do.
from, I think, quite a long time. Even I started using it even before it was part of the Google company.
Yeah, I also remember times when you were, paving the way with your drive. It's not anymore available. I don't know if you can go to any exotic location to still make the roads with Waze, but I do use it. Do you use, Michał, also the latest Batman edition?
Not yet, because now because of the pandemic, I'm not driving that much, but I think
that's driving. It makes a lot of fun. I really like, for the others who never experienced this, Waze is directing with voice of Batman. Your car looks like Batmobile, and everything is Batman style. I love it, but once my small kid is joining the car, she gets scared a little bit, so I have to turn it off. But it's nice to learn that Waze is sharing these data sets with the outside world for the benefit of the cities, I understand, and not only municipalities, but probably some others, like probably logistic companies, can make use of out of that. Any free comments? What did you like? Also, the session on pricing slots and so on was very intensive and full of new infos.
So I think for management part, that introducing new admin panel for the BigQuery is a very useful thing for the database administrators. They will have one place when they can monitor all the usage of the database and see what's going on inside the system and what are the areas of potential improvement, and also help them to scale reservations and slots accordingly to the users. So it also can be used as a tool for some pricing changes.
There are also some news like that there will be a recommender for that, how much you need, right? On top of it.
Now it's on alpha, but there is a kind of recommender, and we on the project are already using recommenders for the GCP compute engine. So for the virtual machines, that recommends when you should scale up or even scale down your machines. And if it will be working similar on the BigQuery, I think it could be very useful feature.
Very useful feature. And I also like this concept of covering peaks with automated scaling and these flexible slots, which also is quite interesting. I didn't got the understanding what these trial slots mean, which was announced at the end of the session, that there is some promotion and so on. Any of you? Any idea? Did you remind it? The trial slots, like probably slots which could be like you cannot expect when they will be provisioned, but you can enjoy. Similar to flex slots, or
I think that it is something like promotional pricing, and you can try this for specific time. I think so. And if it's
trial, but not for free.
Yes, Adrian?
Some kind of free trial, but not for free.
Not for free. Yeah. But in my understanding, pricing of BigQuery still enables you to jump on that solution quite easily and very cost efficiently, let's say. And then they prepared more to smooth that line, that you don't have like jump with every bit you scale up, or when you have peaks. It's nice that they also will limit the amount of like commitment, how much you have of these slots. that brings benefits to the customers of us.
Yeah, and also you can mix and
that.
match these different types of commitments. So you can have some slots reserved monthly, but after some time you can add flexible slots for that, and even have automated. It's all can be mixed, so you can really tailor this pricing for your very specific needs of the project.
Exactly. Like in different services, it's quite benefitable to have this, let's say, committed VM or something, committed, I think, data proc and so on, because you guarantee that you will use it. And funny enough, in some scenarios, it's better to have this committed for the whole month instead of trying to squeeze timing to get the process or workload running shorter, and then on off. This concept of resume is also interesting.
Yeah, because these committed prices are also much more profitable in case of dollars per slot than the flexible. If you need flex, it are always available, but if you can commit to some, it's always better to make this commitment.
Exactly. And maybe more towards the presentation of ways. I think it's a nice example that from another perspective you can start low and then grow with your needs, because very often setup of BigQuery plus Data Studio is like a good starter for many of the small medium companies, and I also know that not only small and medium companies try to land that stage, right? Because you can do still a lot with Data Studio. It has nice visuals. You guys on one of the projects, I remember you showed me some tricks how to use that, also in relation to the row level security. So how do you think that's? What do you think on the setup, BigQuery Data Studio?
I think that first of all, the ways presentation shows how quickly features of GCP are changing, because they had a challenge to separate data from different partners, and the only way for doing this was creating dedicated data sets in BigQuery, and to base a report on many different data sets. They had to create custom connector. And a few weeks ago, there was a new feature published by GCP. It is permission on table level, so you don't need to create separate data sets in BigQuery. You just grant access to dedicated table. So all this additional stuff which they did is can be
maybe not optimal now, right?
Yes, absolutely. And also they just tried to create its own solution for row-level security, and row-level security is also on the Google roadmap as far as I remember this year, and column-level security is already provided. So this is evolving more and more. So as we mentioned at the start, this is a live environment, and new features arrive in the background in weeks, in months. So just we need to observe the roadmap and to find if it is either new features are useful for our projects. But for sure,
exactly.
Make the life much easier.
Exactly. Thank you guys for these comments. I think we will close the session now, going to a very interesting session on geospatial analytics, one of my favorite topics, in fact. Thank you for that, and let's touch base in half an hour because this is a short session.
Thank you.
Stay tuned.
Okay.
I'm switching now the screen setup. One moment, we will go into the video addressing geospatial, reinventing geospatial analytics as only Google can do. That's the. Let's start.
Hi, everyone. My name is Chad, and thanks for joining us. And today we're going to talk about reinventing geospatial analytics. And I'm joined today by Joe Bettridge from TELUS. And the key point of this talk is going to be to describe what becomes available to users and customers and their users when you really take the brakes off geospatial analytics.
Hi there, I'm Joe Bettridge. I lead the TELUS Insights consulting program at TELUS. We are a heavy user of Google BigQuery as well as BigQuery GIS.
Right on. And Joe and I are both excited to show you what we've been up to. So yeah, here are the two of us. We're your speakers. I'm a product manager at BigQuery, and I'm also the GIS lead for Google Cloud.
And I am the consulting practice lead for TELUS Insights.
Right on. Okay, so without further ado, let's go ahead and get into it. We'll talk about use cases, and Joe is going to go through some of like the algorithms that TELUS is using inside of BigQuery GIS. But to set that up, I'm going to go through a couple, call it terms of art. We're going to go through BigQuery just a little bit and what BigQuery GIS is. And then we're going to get into some more details. So if you're already very familiar with the product, just put me on 1.5 times speed for the next minute and a half. So with that, let's jump in. For those not familiar, BigQuery is Google Cloud's enterprise data warehouse. So looking at the left side of the screen here, we're primarily an analytics tool. And the product's real claim to fame here is that we can scale from gigabytes to petabytes without encumbering the user with having to manage any of that infrastructure. You interact with the product in SQL, so it essentially looks like a relational database that can scale up to petabytes. Data inside of BigQuery is encrypted, durable, and the product is highly available. As a matter of fact, we just launched 4 nines of availability as our new SLA, which is industry leading, which is really cool. We want to make the product as differentiated and useful to users as possible. So we have a couple unique items that I wanted to talk about. The fact that BigQuery is fully managed and serverless those are the things that enable us to scale to petabytes without making users provision hardware and things of that nature. We have a real-time streaming API, so you can stream data straight into BigQuery, and then using the BI engine, which is on the bottom of the list here, you can actually query that in real time. So you can do real-time insights on data streamed right into your data warehouse without having to use any other tools. We've also invented some new SQL verbs so that you can do machine learning right inside the platform. And what this talk is all about is some other SQL verbs. We didn't invent them. We're using the PostGIS syntax, but by bringing geospatial SQL functions and geospatial data types into BigQuery, we're enabling a whole new class of use cases inside the product. So let's dive in. What is BigQuery GIS? First and foremost, it's supporting a new geography data type. We launched this to alpha a couple of years ago in 2018. It's since gone GA. So this is a very solid offering inside the product. And a geography data type, as you can see, can have several different shapes. Points, line strings, polygons, multis, collections, all of these fit inside the geography data type. To operate on those data types, we have a number of different functions. So we've got about 50 or so PostGIS syntax functions that we've implemented inside of BigQuery. And these function types take the categories here. And they cover all the primary and the majority of the functionality that folks use inside of PostGIS. What's really exciting about some of these, though, is that particularly the predicates, you can do geospatial joins based on predicates. So if you want to join two tables based on whether a point is inside a polygon, that is totally within bounds. If you want to do that on data sets that are really big, like terabytes or hundreds of terabytes, that also is totally within bounds. And Joe is going to talk a little bit more about what becomes possible when those limits are relaxed for your workloads. Speaking of workloads, almost any analytics workload, whether it's geospatial or not, has these components. First thing, you need to get data into your product or into the data warehouse. So that's the ingest here. Then you have to analyze it inside the data warehouse. And then, results as a table are interesting for some result sets, I suppose, but really you want to visualize that. And particularly for geospatial, you want to visualize those on a map. And so I wanted to call these out because there are some aspects here that BigQuery and BigQuery GIS are really strong at. And there are some places where we need our partner tools to really flesh out these workflows. So I'm going to go through from left to right. So in ingest, BigQuery has a load API and a streaming API. And so if you want to, a lot of our, for example, industrial IoT customers are using the streaming API to stream instrument or sensor data straight into BigQuery tables. We have customers using the BigQuery load API to load as much as a petabyte per day. And we have customers using the streaming API to load up to 10 gigabytes per second per table. So that handles data that's, that we would just want to flow straight in. But let's say you have data sets that are in specific geospatial formats. For that, we've partnered with Safe Software, and they have written a BigQuery emitter for their tool, FME. So this tool allows you to import and materialize as a BigQuery table any number of the hundreds of geospatial formats that they support. So if you've got shape files or KML or GeoJSON or what have you, geospatial data format X, chances are FME supports it, and you can bring that straight in using a drag and drop tool into BigQuery. So ingest, cool stuff. Now, the real strength of BigQuery shows up in this analyze column. In that BigQuery, as I mentioned before, the strength of this product is that it can process data at the petabyte scale. And so when you add geospatial analysis to this, you can now process GIS data at the petabyte scale, which really hasn't been possible before. And so this type of data, I'm really talking about structured and semi-structured data. For imagery data, we have to turn to tools like Google Earth Engine and Descartes Labs, and I'll talk about those in a little bit more detail later. So once you've done your analysis, let's move on to serve and visualize. Particularly with geospatial analyses, you don't look at a table, right? You want to see your results on a map. And we have a multitude of tools, some of them specified for different personas or different types of users, to put those results in a map and then serve them either as a report or as a portal or just as an image for that analyst. The ones I've highlighted here in bold are ones that have direct connectors to BigQuery. So you don't have to extract a file and then transform a file and then render it. So there's a healthy selection of folks that connect directly to BigQuery. So let's talk about a couple of these tools in detail. First off, let's talk about Google Earth Engine as it performs on imagery analytics. So Earth Engine is a tool, a product at Google. It's been around for about 10 years, and it has an immense data catalog of satellite imagery. It's about 30 petabytes. And the thing that's really cool about their data catalog is that when new satellite imagery comes in, Earth Engine as a service will automatically register and orthorectify that imagery so that it is includable in your analysis with a single line of code. So for example, like pound include, for those that speak C, right? Pound include sentinel imagery from this date, date A. And boom, that's it. And now you've got the entire globe of sentinel imagery for that date. You can then include sentinel imagery from date B to do an A-B comparison, again, with just a couple lines of code. Very cool stuff. Descartes Labs is another image processing tool that connects directly to BigQuery. They themselves have an immense data catalog, and some of these thumbnails here describe elements of it. For example, like SAR imagery, AIS, which is automatic actually, I've forgotten the acronym to that, but that one's actually ship positions, showing shipping lanes all over the world. They also have a dedicated solutions team. So if there's an aspect of this data that you want to process and you need some support, Descartes Labs has a lot of detailed expertise to help you along. So the next few slides, we're going to step in and kind of go persona by persona. So analysts, if you're an analyst, you speak SQL, you're using BigQuery, you look in the documentation, you figure out which ST commands you need, and you write your query. And you just want to see those results on a map to understand what your results are. BigQuery GeoViz is an excellent tool for that. So you can either write the query in the UI, and then there's a drop-down where you can explore it directly in GeoViz. You can compose your query in the GeoViz window, which then runs it against BigQuery. And then that allows you then to do interactive styling and visualization, pan and zoom. This is all on top of Google Maps. We've also done a bunch of upgrades to this little product over the last few months. So we've blown away the visualization limitations. And so it's essentially you can render as many points as your browser can hold. And we've enabled the ability to share maps with colleagues. So this is not a full-featured geospatial analysis platform. Like I said, it's a way to get your query on a screen so you can understand it. But it's a handy little tool that we like quite a lot. So for developers, BigQuery GIS is also supported by the Google Maps API. So you can bring BigQuery data straight into your map applications and map visualizations. So you can see here, this is actually a heat map of taxi trips in Manhattan. So that center image is the island of Manhattan. And then the API has some really nifty ways to call out specific areas, which are shown in the two images on the right. Now, business users, if you're not an analyst and you're not a developer, and you just want to operate in a BI tool, again, we've got you covered here. Both Data Studio and Looker have support for BigQuery GIS types or BigQuery geography types. And so you can use these tools to create dashboards on top of pan and zoomable maps. Now, one element that we haven't touched on yet that I'm very excited to announce today, right now in this section, is the Carto tiler. With BigQuery, you have the ability to process enormous volumes of data. The tools that I've shown you before are very, very capable, but they don't have the ability to render the same level and same magnitude of volumes of data that BigQuery can. And Carto, our partner, has solved that. And what they've done with the Carto tiler is they've created a way to create a hierarchy of data corresponding to zoom levels here. So what you're seeing in the right image is the building locations pulled from the OpenStreetMap dataset, which incidentally is available in BigQuery public data. So you can create this map as well. And there are 300 million dots worldwide on this map. And so if we click into that map, you can see how fluid and detailed the rendering is as you go from street level all the way back out to orbit. And as again, we're announcing this, the availability of Carto's beta today. There's some links over here on the left-hand side, so you can play with this map yourself. And there's an email address there for you to send a note to get more information. So just in case you thought the Carto tiler only worked on points, here's an example on polygons. So we're going to zoom in here again on New York, where the southwest corner has some really interesting shaped apartment buildings. So the links here are on the slide on the bottom left, and we are very excited to announce this with our partner, Carto, as now visualization can approach the same scale as BigQuery's native compute. So very exciting stuff. Thank you. All right. The last section before I hand it off to Joe is I wanted to talk at a high level about the use cases that we are seeing our customers employ BigQuery GIS. So starting on the left-hand side, in retail, the primary operations in retail that we've seen are channel optimization, site selection, and marketing analysis by trade area. Because BigQuery allows you to define your own polygons, obviously, like you can define your own data-driven trade areas rather than using the established ones like either census blocks or zip codes or any other kind of established polygon. You can define your own that are specific to your business's needs, and then run whatever aggregations you need, again, because the scale will support you. In supply chain and logistics, we've seen a number of our customers use IoT, so Internet of Things data, to do traffic analysis, which is what this image shows. This is actually a heat map of ML predicted hazardous driving areas developed by our partner and customer Geotab. So they actually used vehicular data combined with weather data that's already stored in BigQuery to do a GIS plus machine learning tool to say, you can dial in a weather condition and then have that predict what the hazardous driving would be for that weather condition. So very useful for city planners and traffic planners. We see a lot of activity around delivery optimization, and really gratifyingly, we're seeing some significant projects around supply chain sustainability. So this is calculating the human cost, the economic cost, and the environmental cost of taking product from its source, which may be many, many thousands of miles away from its ultimate destination on the shelf before you buy it. And so knowing the true cost of that supply chain and being able to optimize that supply chain to make it economically, environmentally sustainable is really exciting work. We all know how important public dissemination of data is in this time and age. And so we've seen a number of US states and countries around the world use BigQuery, GIS, and our dashboarding tools to support public data portals. Also, very interestingly, this is an air quality map from our colleagues at Aclima and Geotab, where they're actually discovering, one, that air quality can change on a block by block basis, and two, that the reduction in human travel during these COVID times has greatly reduced the pollutants in the air. And they have a lot of research that they've used BigQuery and BigQuery GIS to support. And then lastly, in agriculture, we've seen a lot of usage around a yield optimization, so trying to get the most food production out of a field that you possibly can. And then once you've figured it out for the field, because these tools, BigQuery and in this case, Earth Engine, operate at such scale, you can do these analyses for the entire globe in one shot. And so that way, S4 AgTech, another one of our customers, is doing worldwide production forecasting, where like figuring out how much grain the Ukraine is going to do is just one step of their process, because they can do that for the Ukraine, for Argentina, the entire globe in one shot. So with that, let me wrap up my section. I've given you a very high level introduction to both BigQuery, BigQuery GIS, and some of the partner ecosystem and use cases. And I'd like to hand it over to Joe now to tell you what TELUS is doing in detail.
Perfect. Thank you for that, Chad. So just to get us started, for those of you who are not from Canada and don't know who TELUS is one of the largest telecommunication companies within Canada. So we represent about 9.5 million of the 35 million Canadians on their cellular plans. And one of the things we've been doing for the last while is we've been developing an insights product that allows us to use massive amounts of de-identified aggregate data to answer really complex questions about the real world. And what we want to announce today is that we're creating an API into this data that is launching today that allows for users to query this data directly and get aggregate results back that have no individual information in them, but can answer really complex business problems. This is a first for us, and it's one of the first times in the world that an API into this type of data has been able to be generated, and that's thanks to BigQuery GIS. So the big picture of what we're trying to do is we're trying to solve the problem that many businesses have today of making critical decisions based on gut feel, small sample rate surveys, and strawman business cases. We've had this promise of big data for a very long time, yet we haven't seen a lot of delivery on it. We've just seen mass amounts of data be stored, but no real analysis has been capable to be completed that can really solve the questions that businesses and governments have. Usually this is for one of two reasons. Either the technology is a roadblock or privacy has been a roadblock. And as I'll talk about in the next few slides, both of these things have been solved using both BigQuery and the previous groundwork we've laid around privacy. And we need this to be scalable. This is a really critical issue. Government's existing BI tools need to be integrated and needs to be able to be used within the current supply chain of data. We can't be trying to create a new set of tools. We need integrations directly to the tools today. As Chad was talking to earlier, the BigQuery GIS is really great for plugging into a lot of different tools that we commonly use. So what is TELUS Insights? TELUS Insights takes all the aggregate information being generated by our cellular network. So every time a phone connects to a cell tower, there's a residual event that's created that says this phone was at this cell tower at this time. We take all that information across the country, we remove all the identifiers, we get rid of anything that's personal from that, and we create a row-level record saying this is the data of what happened across Canada. We then upload that data into the cloud, process it, remove a lot of the secondary information that's not necessary, and then we start analyzing it and producing insights. These insights could be that there were 10,000 people in a neighborhood at a time that spent at least 2 days there in the last week. It could be the trade area of a given business, maps around a certain area. The primary area of trade is within 5 kilometers of the business. The secondary area is within 7 kilometers to the east and only 3 kilometers to the west. We're able to pull this all out and aggregate that through. And finally, we're doing these results through an API that's powered by Google Cloud. And all of this, we need privacy. Privacy is a critical cornerstone of everything we do around insights. TELUS has worked very closely with Anne Cavoukian, who's the former Privacy Commissioner of Ontario, on achieving Privacy by Design certification. This certification entails ensuring that all privacy and regulatory issues are met. The language she wrote has influenced the GDPR and has been seen there throughout. What we do specifically is we add in privacy controls, including de-identification. So before we analyze any data, we're de-identifying it. We aggregate all of our information into large data pools, so we don't allow anything about individuals or even small groups of individuals. Further to this, we extrapolate all the data to match to our market share, so it represents the entirety of the country as opposed to only TELUS's share. We also include security within this, so we do a lot of work on security and making sure this product is secure by design. All engagements beyond this are also audited by our trust model. TELUS views trust as a cornerstone of all privacy. If you don't have trust, you can't have privacy. And how we gain trust is through being transparent. So we update all our privacy policies to include what we're doing with de-identified and aggregate data. We also understand that not a lot of people read privacy policies. So one of the things we've done to help this is we've added privacy frequently asked questions on our website that are written in very plain and simple language that help everyone understand exactly what we are doing. And finally, we give users control. So we give users the ability to opt out of any of these large-scale analyses without asking them for reasoning or justification. It's just a simple opt-out if they choose to do so. With this being said, I'm going to take you through our architecture very briefly and talk through a bit of what we do specifically with the data. So all of this data is captured with probes within our network. I'm not going to go into detail about how that works, but once that data is landed on a server, it's pushed out to Google Cloud using NiFi. Once it lands there, it's put into a data flow job, and that data flow job removes all the opted out information. It sanitizes and de-identifies. It strips out all the personally identifiable information from the data. And then it does some analysis to retain secondary traits of that data. So this could be things like area codes or the country of origin of a device that are stored within that personal information, but are not the entirety of that data. Once all of this has been stripped down to the skeleton of the information, it's landed into BigQuery, where further analysis is done to remove things like duplicate devices, undesirable devices. These might be things like roaming devices from an IoT device that's not actually part of what we're looking to analyze. As well as we generate a system-based universal unique identifier. So this identifier is generated by the system as the only identifier associated to any of the information from this point forward, meaning there's no tie back to any of the personal information. Once this is done, our data is pushed through to an analysis layer. At this layer, we do a lot of different work to reduce the amount of data that we're storing. So this includes collapsing down each device into a timeline of what happened to that device as opposed to all the individual events. We also calculate an assumed home and work neighborhood. We'll talk a bit more about how that works and how we preserve privacy in that step on the next slide. We also then include a geo-ID to each location, which is used to apply market share. And finally, we compute all of our API queries against this aggregated data set. So our final layer is our output layer, and this layer is built in App Engine, and it allows users to query and ask things like, what are the number of visitors in a given polygon at a given time? And they get a result returned back from the analysis layer. All of these results meet our privacy thresholds and are about large aggregate groups. We'll talk a bit more about how this is utilized in some real world cases in a couple slides. So the first thing I want to talk about is our assumed home and work neighborhood analysis. So the first thing we do is we look at what towers a device is connected to over a period of time. In this given example, we're going to look at a 1-week period. In this image, we can see two distinct clusterings of towers that this device were to have connected to during the time. The first one being on the left here, and the second being on the right. The one on the left has a much higher total time spent, so we're going to look at that cluster specifically. And there's a lot of research that's showing the time most spent in a given area is likely that home, or the home is likely within that area. So taking this cluster, we're going to place a polygon around the initial tower with the highest weight. We then are going to shuffle that polygon across the different towers to try to find a closer representation of where the home area is. So we continue to shift this towards the higher weighted towers until we eventually hit that lowest weighted tower and get a rough estimate of where the home neighborhood would be. From here, we overlay that polygon onto a set of polygons that are based around Canadian Statistics Canada information of where neighborhoods are. So these are important neighborhoods that are used in statistical analysis of demographics and what we use for our market share. So by applying these neighborhoods, we use an ST-within function to determine exactly where that polygon is. And then we only store that blue polygon that is much larger as the home area for that device. So this again strips away us storing any of this information that's really detailed, and we go to this higher level piece of information to just understand the neighborhood, which is used in that further analysis. One of the big projects we've had come online since COVID-19 started is our Data for Good program. Within this program, we're providing governments as well as academic institutes access to our information at the aggregate and de-identified layer to help them solve problems related to COVID-19. This could be things ranging from how healthcare should be impacted and what should be done for healthcare institutes through to economic recovery as we're trying to reopen our economy. We're doing this under a strict set of rules, which are outlined on our Data for Good website. These include things like these cannot be used for police enforcement. The data cannot be used in any way outside of the typical usages we have outlined within our privacy policies. We will not reduce any of our privacy thresholds for COVID-19. We are staying strict to everything we've transparently given to our customers going forward. But this has been a very powerful offering that many of our provinces, federal government, and several cities are using as well to try to help in the fight against COVID within Canada. This is one specific example of how this data can be used. This is looking at social distancing, which was very important in the early stages of COVID-19. Really understanding where people are leaving the home. So in these maps, you'll see yellow as being more people than normal being out of their home. As we head towards that greenish blue that's in the middle of the scale at the bottom, that's typical behavior pre-COVID-19. As we get into the dark purples, that is less behavior, less movement behavior. Now I want to zoom in on one specific area to show a good example of how this data can be used. So as we're zooming in here, this is the area surrounding Toronto, which is the capital of Ontario, which is the largest province within Canada. To the north of the map, you can see these areas lighting up in yellow. This is a very remote and rural set of communities that are very popular for cottage goers. And one of the things we immediately started finding in the data is that there's a large volume of people traveling to these areas from the big cities to try to get away from where crowds were. The concern here is it puts a real strain on hospitals in these areas that may only have 1 or 2 ventilators available at any given time. And if there were to be an outbreak in these communities, it would affect them much stronger than it would a larger city that has more ability to handle within their healthcare system. So this was being used to understand where to redistribute PPE in order to really help in fighting COVID. Another way of looking at this is the public health lens and trying to understand which communities are interconnected, so that if an outbreak happens in one community, you know which other communities are likely going to be affected. So by looking at large aggregates of how people travel from one city to another, we're able to start determining linkages and how closely linked different cities are. So this is looking at 3 steps from Vancouver. So this is taking Vancouver and then going up to 3 steps away and showing the interconnectedness of communities. This can be used, say, if there was an outbreak in Vancouver, how long would it take to spread to somewhere like Parksville that you see at the northwest side of the map? Or how long it would take to spread to Hope? What's the path of travel for that? And where would you see other outbreaks happening before you see it there? And this can be really critical in trying to figure out how to stop the spread of the disease. So there's a lot of numbers behind these maps, and BigQuery is what really makes this possible. So we have 74 billion records per month coming in. We have 275,000 unique points mapped out to over 5,000 unique polygons across the country. There's 522 days of data being used to analyze this. This includes things like building baselines from previous years, understanding the existing data today, and going far beyond that to try to predict what might happen in the future. And finally, there's 1.2 petabytes of data being analyzed. This is a massive, massive amount of data. And we're able to do this 25 times faster than we could with our previous Hadoop infrastructure. And that's really the power of Google Cloud here, is we're able to do this just because we have BigQuery GIS. We couldn't do this with our previous technology, and we wouldn't have been able to help in the fight against COVID-19 without having the access to this kind of technology. And again, today we're announcing our TELUS Insights API, which allows Canadian companies to get access to this type of information through a queryable API, where they can build out their own reports and analysis of what's happening across Canada. And to get more information on this, you can contact myself or the TELUS Insights team through our website, telus.com/insights. And back over to you, Chad.
So Joe, thanks for joining me in the presentation. Thanks for announcing the launch of TELUS Insights in the presentation. And also, thanks for the work you're doing. I mean, it's just a really great example of how we can bring these tools and this data together, to do good stuff for people, that need to understand this, like public policy decision makers. So I really appreciate that. So to wrap up, everyone, by the way, this is the last slide. So if you're tired, we're just about there. So hang on. But to wrap up, I wanted to talk a little bit about the context that we are or have developed here at Google around geospatial analytics and how we're thinking about all the different areas of it. You can tell a little bit about this, that, we foreshadowed it with the rest of the talk because we talked about imagery, we talked about tabular. So I just wanted to wrap that all up with one slide. On the left side, you see the types of data that frequently go into geospatial analyses, right? Tabular, imagery. On the bottom here, there are preformed data assets, the Earth Engine catalog, the Descartes Lab catalog, BigQuery's own public data catalog. There are a bunch of assets that we have just available for folks to start working on. In the center here, these are the capabilities that a wide-ranging geospatial analytics practitioner will need. They have to work on tabular data, they have to work on imagery. Maybe your use case doesn't use one of those, but we need to build it out for those who do. The bottom ones here, mapping and data visualization, right? You need to be able to get your results on a map, otherwise they're kind of meaningless. And we need to be able to bring to bear machine learning and artificial intelligence into this so that we can do predictive analyses as well. Once you bring all of those capabilities together over these data assets and types of data that are shown here on the left, then you get all of these use cases. So the ones that I described earlier, the ones like Joe described, and it really is our thesis here, and we're seeing this being borne out, which is really exciting, that once you have these capabilities available at the scale that they're available at inside of Google Cloud, you can do your analyses over much larger data sets and do much more interesting and ultimately impactful analyses for your users, for your customers, or for the public. So with that, thank you very much for spending a bit of time with us. My name is Chad Jennings.
And I'm Joe Bettridge. Thank you very much.
Coming back to you from behind of that presentation. Hello, hello. I want to bring two of my colleagues, Adrian and Michał, into discussion on that point. Michał and Adrian. And let's remove the slides. Guys, how do you like that presentation? I personally see plenty of stuff for me because I'm fascinated with this geospatial data sets.
Yes, I really like the new possibility to put on the map the results of analyzing data in BigQuery. It seems to be really handy and a chance to improve many geospatial problems analysis. I love it.
Exactly. With this offering from Carto is quite interesting. I need to dive into that beta soon, because it's a tricky thing to draw so many points on the map, as many points as BigQuery could store. It's hard to then make a map in web-based front end with that. So it's nice that there is an algorithm to simplify that. And I also find this GIS functions of BigQuery quite interesting, because in fact you don't work with geospatial data like with normal tables. This one particular example that you want to match two tables on basis of the criteria that point from one table. So longitude, latitude will be located inside the polygon defined by other tables. With a simple query, that's a nice thing to do.
Yeah, it's great that the BigQuery is providing the built-in functions, because BigQuery, of course, allows the users to build their own custom functions for their functionalities, which is very handy multiple times. But if you have the built-in functions already, you can start developing your solution faster, because you have already tools for doing that. You don't have to first build the tools.
Yeah, and it will scale. It will come without any effort of managing that or tuning that. Google team will handle that. Yeah, for sure. I'm just let's say I'm looking forward that also the tools of BI from Google will work with that, because I don't think Data Studio, neither Looker, can do anything advanced with these capabilities. Both solutions can draw maps and can show points on the map. Even as far as I remember, Looker can do much more with backgrounds of maps. You can put there whatever you wish, but that's just visualizing static data set or unmanipulated data set of longitude, latitude, polygon, or line between points. But the point is, with these functions, you can do some nice tricks.
Yeah, but as long as there is the specialized data types for doing that, I think the Google team will have better motivation to implement the visualization layer according to that.
Exactly. So that even from BigQuery UI, there will be a function from BigQuery UI to run. Sorry, let me state once more. There is already a function in BigQuery UI to make Data Studio report. There is coming up a function to make a Looker report, and I hope any of these ways will give a chance to make also geospatial related report within BigQuery and see something on the map. Once in the past I did some calculation of classifying data points in the city of Warsaw into polygons, into honeycomb polygons, like how it's called, hexagons, yeah?
Yeah.
Because, for example, you can take a map of the city and not divide it into parts of the city like they are divided from administrative perspective, but you can take and divide it into hexagons. And then with simple query, you can classify which data point which you have classified inside that data point. So you can, for example, calculate within, so you have a data set with hexagons on one side, which is a table with the GeoJSON, for example, format. And then on the other side, the data points with, I don't know, where the store is, where the pharmacy is, where is school, and you can calculate how many of stores or pharmacies are in the neighborhood of that particular polygon, which is similar to the case of Waze, yeah? Like from sessions before, that they were showing data within polygons defined by customer, defined by their partner.
Yeah, and it's great that you can do all of this inside the BigQuery without you transporting your data to the external tool. So it gives you all the scalability, all the other performance of the BigQuery to do such an analysis.
Exactly. This can be a large-scale data set, yeah, and with simple query, you simplify that, and Visual BI tool will have much simpler task to do instead of recalculating that. Perfect.
Yes, we can receive quick insights.
To get, exactly. Gentlemen, thank you for that session, and we will not see each other any more longer today, because the next break will be together with our data science team. Thank you, Michał. Thank you, Adrian, and thank you, Marek, who left the session before. And going forward with another 2 videos about artificial intelligence and benefits of it. Bye, guys.
Okay. Bye.
Let me now switch the video to the slides we want. Let me add this. Let me run and disappear.
Hello, everyone. Welcome to Interpreting ML Models with Explainable AI. My name is Sarah Robinson. I'm a developer advocate on Google Cloud. This is an overview of what I'm going to be covering in this session. I'm going to start by defining some key terms related to model explainability. Then we'll see some examples of what explainability looks like for different data types. Then we'll dive into the explainable AI offerings that we have on Google Cloud today. And finally, we'll see them in action with some live demos. So let's get started. I'm going to start by defining explainability. Now, in order to understand explainability, I want to set the stage and tell you how it fits into the larger concept of responsible AI. Responsible AI is essentially the practice of ensuring that AI benefits society and doesn't reinforce unfair bias. So you can think of explainable AI as an umbrella concept, and explainability is a subfield within responsible AI, in addition to other topics like fairness, privacy, and security. So this is a summary of how explainability fits into the larger responsible AI picture. I want to talk about fairness and explainability, since they're 2 terms and concepts that work together and can sometimes be confused. So when I talk about fairness, I'm talking about ensuring that machine learning models don't reinforce biases, and subsequently that they treat all different slices of users of a machine learning model fairly and equitably. Explainability is one way to ensure fairness. Explainability refers specifically to understanding how and why a machine learning model makes predictions. But explainability can also be used outside the context of fairness to do something like maybe explaining why a fraud detection model flagged a particular transaction as fraudulent. Explainability is a broad concept and can invoke a variety of related concepts depending on who's looking at it. So maybe for an executive that's overseeing AI investments, they might think of explainability as transparency, accountability, or governance. In this presentation, we're going to focus specifically on model explainability, which is understanding how machine learning models make predictions and communicating the insights from that to external stakeholders and folks within an organization that are building these models. So now let's see some examples of what model explainability looks like. This depends largely on the type of data that you're working with, the data that you use to train your model. So explainability is going to look a bit different for image, text, and tabular models. So let's take a look. For image models, explainability can highlight the specific pixels or regions in an image that caused a model to predict a certain label for an image. So in this example, the image on the left of the dog is the original image, and the other two images show different methods of getting attributions for the pixels in an image that signaled the model's prediction. For text models, explainability can tell us the words in a block of text that contributed to a model's prediction. So in this example, the sentence, "How could you not love cake?" which our model gave a sentiment score of 0.9, we can also see the words that contributed most to that model's prediction of a high sentiment. And this is an example of how explainability and fairness can go hand in hand. So in a text, specifically a sentiment analysis model, you'd want to make sure that your model wasn't using identity terms to determine the model's sentiment. In this example, it looks like our model is performing correctly because it's picking up on emotion words and words like not to make its sentiment prediction. And then finally, for tabular models, explainability gives attribution values for each of the features in your model to show how they influence the prediction. This particular example shows a model that predicts the duration of a bike trip, and we can see here that the distance of a trip, of this specific trip, caused the model's predicted trip duration to decrease, whereas the max temperature on that day caused the model's predicted duration to increase. When we talk about model explanations, there are a few different groups of people that need explanations. The first group is data scientists, people who are building models, maybe people who are managing the operations and productionizing those models. And for that group of people, they want to use explanations to understand maybe strange behavior in their model and help debug it, see why the model's not performing as they expect, and try to improve the model. End users of ML systems could refer to a few different types of groups of people. First, it could refer to someone that's benefiting from a prediction of an ML model. Maybe you're using an application that gives you a product recommendation. It could also refer to a practitioner, maybe a doctor or medical practitioner who is using a machine learning model to determine whether an X-ray contains a particular disease. In this case, they're using explanations to verify that they can trust the model's output. Finally, we have public stakeholders, anyone involved in regulatory or compliance for machine learning models. And this could be somebody both within or outside your organization. They're using explanations to determine whether a model complies with certain regulations and if the model is safe and fit for purpose. And each of these types of users will take different action as a result of explanations. So just to go over this a little bit, so data scientists, model builders, people who are actually building these models might use explanations to go back and see where they could improve training data, maybe refine features, or change the model architecture. End users are using explainability to have more trust in ML systems and be confident that the model is leading them in the right direction. Finally, public stakeholders might take action from explanations by using higher level summaries of models to develop guidance for different industries on responsible AI. Now let's look at how we can use explainable AI on Google Cloud today. I'm going to focus primarily on what's called feature attributions, but first I want to talk about two categories of explainable machine learning. The first is referred to as post hoc explanation methods. This involves looking at relationships between feature values and a model's given prediction, independent of model internals, things like learned weights. The other type of explainability is called methods that are interpretable by design, And this refers to simpler models like linear regression models or decision trees, and looking specifically at the architecture of those models to understand explainability. TabNet presents some new research in interpretable machine learning models for tabular data, and we recently released a solution for it on Google Cloud. Today, I'm going to be focusing specifically on post-hoc explanation methods, and within that category, we'll be looking at feature attributions. Now let's look at the products on Google Cloud where you can use explainable AI. This pyramid provides an overview of the different machine learning offerings that we have on Google Cloud, organized by levels of abstraction. So the products that are on the bottom half of the pyramid are targeted more towards data scientists and machine learning engineers, folks that have more of a background in machine learning. As we move towards the top, these products are targeted towards data analysts, application developers, folks that want a way to integrate machine learning into their application, but may not have as much ML experience. Now, right now, you can use explainable AI on TensorFlow models that you deploy to AI platform prediction, along with tabular data models that you deploy to AutoML tables. And with AutoML tables, you get access to explainable AI by default. Later on in the presentation, I'm going to show live demos of both of these tools and how to use explainable AI with them. The first demo is going to show how to use AutoML tables, and in this demo, I'm going to show a fraud detection model that was trained on a public data set that's available in BigQuery. And we'll show how we can use explainable AI to get both global and instance level explanations. For the second demo, I built an image classification model trained on medical images using TensorFlow and deployed that to AI platform with explanations. For the first model, I trained this model using a publicly available data set from BigQuery, and explainable AI provides both global and instance level feature attributions in AutoML tables. So this means I can see overall which features my model relied on most to make predictions, and I can also zoom in and see at an instance level for an individual prediction which features were most important for that one prediction. For the second demo, I trained a TensorFlow model on this chest X-ray data set available in Kaggle, and I'm going to show how we're going to use explainable AI's new local experience SDK to get explanations without deploying our model. This SDK is available in Cloud AI Platform notebooks, and I can use it to get explanations on a model that's available within my notebooks instance as I'm developing and prototyping my model without needing to deploy it to AI Platform. When you're deploying a model to AI Platform with explanations, you can choose the explanation method that you're going to use. So I want to introduce the 3 explanation methods that we have available. All of these explanation methods are based on publicly available research that you can check out by going to the links on this slide. The first method is called integrated gradients. This works with all types of models built with TensorFlow, tabular, image, and text models. Sampled Shapley works for tabular models built with TensorFlow, and the X-ray method is built on top of integrated gradients and does some smoothing to show, instead of pixel-based image attributions, it shows region-based attributions. And this is one way that you could deploy explainable models to AI Platform. Here we're showing how to do this using the Google Cloud CLI to do it. So this looks very similar to how you would deploy a model version without explainability on AI Platform. The only things you need to add are the explanation method you'd like to use and the number of steps you'd like this method to use, and I'll get into that a little bit more in the demo. So now let's go to the demo. I'm going to train my fraud detection model using this public BigQuery dataset of credit card transactions. Here's the description of the data and the schema. Most of the columns in this dataset have been obscured. And here's a preview of what the data looks like. I'm going to run a quick query to show, as in the case of many fraud detection datasets, the data is heavily imbalanced, meaning that only a very small percentage of our examples are fraudulent transactions. So to account for this, I have done some downsampling, which means that I've taken just a small sample of the data from our majority class. And to keep things interesting, I've also taken the liberty of renaming the column names that were obscured. So let's look at AutoML tables. So to import my data, I can import it directly from BigQuery, so I don't need to move my data anywhere. I've already done this, so let's take a look at what the data looks like. I can see a preview of my columns and the different types here. As you can see, I have renamed many of the columns. And I've selected my target column. Now to train my model in AutoML tables, all I need to do is press this train model button. And to account for that class imbalance that I mentioned, in addition to the downsampling I did, I can also use this optimization objective provided by AutoML tables. So in this case, I chose to maximize my model's performance on the less common class. In this case, our fraudulent transactions. Now I've already trained this model, so let's take a look. Here we can see many of the different evaluation metrics for our model. The confusion matrix tells us the percentage of examples in our test set that our model classified correctly for each class. And here we care most about our fraudulent examples, and we can see that our model did a pretty good job with no false positives, and it was able to classify 88% of our test examples correctly. Now let's get into explainable AI. So we get this out of the box once we train an AutoML tables model. We don't have to enable anything. What this provides is global model level feature importance. So across our test set, this shows us which features our model used most in influencing its prediction. And looks like the most important feature here was whether or not there was a smiley face on the credit card signature, followed by the credit card color. Again, I just made up these feature names. And so once we have trained and evaluated our model, the next thing we'll want to do is use it to get predictions. And there's a couple of ways to do this in AutoML tables. We can do it right in the UI, which I'll show first. AutoML tables has just populated each feature with a random value. And what I want to do here is check this generate feature importance box. Here we can see the model is 99% confident that this is not a fraudulent transaction. And here we can sort our feature attribution values by the ones with the highest absolute value. So here we can see that smiley face signature caused the model's prediction confidence to go down, whereas the time to expiration caused the prediction confidence to go up. And we can scroll through and look at the other feature attribution values here as well. So that's how we can try out AutoML tables and see feature importance at an instance level in the UI. But chances are we'll also want to use the AutoML tables prediction API to generate predictions and get feature importance. So I'm going to show you how to do this in a Python notebook using the AutoML tables API. So first we'll create an AutoML tables client, and we'll set up some variables for our project and a specific model version. I have provided my inputs in this format. This is an example of a fraudulent transaction, so hopefully our model will predict fraud for this one. And notice here that I am setting feature importance to true to get those feature attribution values back in my response. Here I'm visualizing the feature attribution values. We can see that our model predicted this correctly, 97% confidence that this was a fraudulent transaction. And here I've graphed the feature attribution values just for the top 5 features. And we can see which features influenced our model's prediction of fraud here. Now that we've seen an example of a tabular model using AutoML tables, I'm going to show a few examples of how to get explanations on an image model using Explainable AI. I'm going to show you how to do it in Cloud AI Platform notebooks using the Explainable AI SDK, which comes pre-installed in notebooks instances. So I'll open up my notebook instance here. And in this notebook, I'm going to show you 2 examples of image classification models that I've built with TensorFlow. What I'm going to highlight is how you can do this all locally from within your notebooks instance. So I'm going to get explanations on my models without having to deploy them to the cloud. Both of the models that I'll be using for this demo, I've already saved in the TensorFlow saved model format in these directories here. The first model that I'm going to show you is a model that's been trained on the ImageNet dataset, which can classify images into 1,000 different labels, ranging from different types of animals, food, plants, etc. So I've already saved the model assets in the TensorFlow saved model format into this directory. And note that I'm importing the Explainable AI SDK here. When I point the SDK at this directory, it's going to generate some metadata that it will need to provide explanations. We can see it saved this in a JSON file here. And now we're ready to send a test image to the model. I'm going to send it this image of a jellyfish. I'm going to see both what label the model returns for this image, along with the feature attributions to explain that prediction. And again, to do this, I am using this load model from local path method, and I didn't need to deploy my model to the cloud to take advantage of this. What we see here is the label index for the label that my model was most confident in. And below, we can see that the index of 108 corresponds with the label of jellyfish, which is a good sign because this is indeed a jellyfish. And looks like our model was 96% confident in that prediction. And just so you understand what these color-coded explanations mean, the yellow, brighter regions in the image are the regions that contributed most to my model's prediction. The darker purple colored regions are the regions that were least important in predicting this label. And so what we're trying to see here is that our model is picking up on the right shapes that are associated with this particular label. And in this case, we can verify that our model is performing correctly. It's looking at shapes in this image that are specific to that of a jellyfish, which we can see here. The next model we'll look at is a model that was trained on a chest X-ray data set in Kaggle to predict the presence of one condition that can be found in these images. So the first thing we're going to do is save our model metadata, and here we're explicitly setting the baseline for this model to be a solid black image. And that's what all of our explanations will be relative to. We can preview the metadata here. So we're going to test out our model using this image. And our model output is a sigmoid output, which means that it's going to output a value between 0 and 1, with 1 indicating that the model thinks a specific condition is present, 0 indicating that it does not. So we'll first get an explanation, and notice here that we've set our model's step count to 10. This is the number of integral steps that the explanation method is going to use in computing the pixel attribution values. And we can see here that the approximation error exceeds 5%. Now, what this means is that we may not be able to trust the explanations in this particular example. One way that we can decrease this error is to increase the number of integral steps we're using. So let's try increasing the step count to 50 and generate a new explanation. Now we can see that the approximation error did decrease significantly, but looking closer at this image, the regions that our model seems to be focusing on are not the correct regions associated with this particular condition. For this particular image, our model should have predicted closer to 1. This is likely pointing to a problem with our model or a need to improve the data that was used to train our model. Since explanations are only a direct reflection of your model, they're only going to be as good as your model itself. So it looks like here we need to go back and improve our training data, perhaps provide a more varied representation of X-rays that have this specific condition present and healthy X-rays. Once we have a model that we're happy with and the explanations confirm that our model is performing correctly, we have everything right here ready to go to deploy our model to AI platform. So all we would need to do is copy this directory with this metadata file to Google Cloud Storage, and we could do that here. And then we would run this gcloud command to deploy our model. And now let's go back to the slides. And finally, here are some resources if you want to get started with any of the products that I covered in this presentation. I definitely recommend checking out our sample code. We have some example notebooks that show you how to deploy explainable models on AI platform. Thank you for watching. If you want to get in touch, you can find me on Twitter at srobtweets, and I hope you enjoy the rest of Next on Air.
Hi, welcome to our session on driving business transformation in retail using AI. I'm Carrie Tharp, and I lead up retail for Google Cloud. I'm excited to be here today to chat a little bit about the state of AI in retail and how Google Cloud is helping implement AI in businesses like yours. We'll also share a little bit about our solutions and then share some best practices. When you think about what's going on in retail today, the landscape is certainly changing. The pace of change is accelerating, and COVID-19 has certainly thrown a wrench in many plans. What's more important than ever is the use of data in your business to help unlock value, whether that's changing customer experiences or improving operational performance. When you think about AI and ML in your business, it's a crucial component to the future of retail strategies. And choices that you may be making today on your platforms and capabilities can be a big part of your performance tomorrow. We're very passionate about driving the adoption of AI and ML in retail. Research shows that there's certainly value to using AI and ML in your business. It can help you make more data-driven decisions, 5 times faster decision-making, and 3 times faster to execution. However, AI is really still seen in its hype cycle for retail. We did some recent research in the specialty and department store space and found that 60% of retailers had 20 or more pilots in progress. But when you double-clicked on that, only 45% of those pilots had been transitioned to full implementation in production. And then looking at those that had been implemented, retailers only thought 40% of them represented the high-value use cases. So it's great to have a mix of potentially low-hanging fruit opportunities, but there's also still a big opportunity to go after where the biggest value in retail is. So what's holding people back? In our discussions, we find that data availability continues to be an issue. This really covers a whole host of problems. Everything from data being siloed and not being able to get at all the different combinations of customer, transaction, product, and supply chain data, to having issues with data tagging and data modeling. Second is technical talent. Do you have enough resources on your team from a technology standpoint or the data and analytics team to really go after a lot of these more complicated use cases that take more preparation of the data and a deeper understanding of the business? Last is financial constraints. So we all have kind of scarce resources when we think about the capital and expense we're able to deploy in our businesses. And so do you have the right amount of resources to go after the opportunities that you see ahead of you as a team? With all the challenges of implementing AI in retail, it's more important than ever to focus and prioritize. We've done research to understand where the value is locked up in retail and have found that the top 10 to 15 use cases is actually where most of the value lies, out of hundreds of use cases you could potentially be thinking about working on. Whether it's in food, drug, and mass or specialty and department store, you'll see on this list that there's a couple of key themes around inventory, customer experience, and store operations. Google can join you in these conversations of prioritization to help you understand what might be the best opportunities for you to go after short term and in the longer term. How Google can help from an AI perspective is in 3 key buckets. First, we're building industry-specific solutions that are pre-built and ready-made to help accelerate your digital transformation. An example would be Vision Product Search. You can plug in this API and allow your customers to take pictures of product and automatically find it within your catalog. Second is using the building blocks that we've already established. One of the examples here is dialogue flow. Rather than trying to take on natural language understanding to create customer care chatbots or voice interaction with your customers, you can use dialogue flow as a jumpstart to creating those experiences. And third is then just using our platform to custom build yourself. There's a variety of use cases that you may feel are very specific to your business or don't leverage components that already exist. When we think about these pre-built solutions, we're focused in 3 key areas. First is helping drive digital and omni-channel growth. So this is, think of everything that's a part of driving digital experience and your e-commerce business. Second is helping you become a data-centric, customer-driven retailer. This is all of the data platforms and AI and ML that's needed to help you drive new personalization, customized experiences, and understand your product and inventory data better. Third is operational performance improvement. So this is helping you unlock operational value inside the P&L, whether it's store operations or reducing your cost in your infrastructure. First, let's talk a little bit more about pre-built solutions. What are these? Well, pre-built solutions are driving digital and omnichannel revenue growth. One of the key priorities here is helping evolve product discovery. When you think about e-commerce today, it's based on very rigid structures, from site nav to using a search text box. And customer shopping journey looks very different than that. So we've been focused on providing solutions that help you evolve that customer interaction. All retailers are dealing with several key trends. So first is the changing dynamics in shopping visits. So COVID-19 has changed how much retailers have customers visiting their stores, how big their basket size is when they visit. And so it's become more important than ever to provide new digital discovery experiences. Second, this environment has certainly made customer experience a big priority. Making sure that your customer has all of their expectations met, whether or not they can interact with an associate, has become critical. And then personalization. This has been a theme in retail for years, but it's now very important to make sure you're putting the right product in front of a customer wherever their journey may be taking place. Our offerings are focused on reducing friction for shoppers. First is Vision Product Search. This is the capability that I mentioned that allows you to use visual images to search your catalog. So think of a grocery store customer, instead of building their list by writing it down or searching for it on your app, they could simply take pictures and preload their shopping list. Next is Recommendations AI. This is focused on providing the best personalized recommendations for your shoppers with a broad understanding of their journey. And last is Search for Retail. This is bringing the power of Google search directly to your e-commerce websites. When we think about recommendations, Google Cloud brings best-in-class recommendations based on our experience in building recommendations as a foundation for several of our products that are serving billions of users worldwide. Recommendations AI works in 3 key steps. First, you seamlessly integrate your catalog and user events data with Recommendations AI through many of the tools you're already using, like Merchant Center, Google Tag Manager, Google Analytics 360, Google Cloud Storage, and BigQuery, as well as other data sources, in most cases without having to write any code. Once your data is in, with a few clicks, you can choose your model type, define your objective, and begin training your model. In 3 to 7 days, the initial model training and tuning will conclude, and you'll see a visual indicator in the dashboard that the model is ready to query. You can then begin serving recommendations to your customers. You can now also visually preview the recommendations being generated by the model before you serve them in production to make sure that your setup has been satisfactory. The recommendations are then constantly improving and optimizing with daily AI model refreshes. Sephora is a customer that's using our Recommendations AI. Beauty is certainly a space that recommendations can be very important to that purchase journey, and they've seen an increase in both their click-through rates as well as their conversion. Next, let's talk a little bit about being a customer-centric, data-driven retailer. How can you use data to effectively predict customer needs and what your demand might look like? Demand forecasting is an example of an area that is critical to retail. All of retailers belabor their forecast, trying to make sure that they don't miss out on revenue opportunities, but also make sure that they don't have excess products sitting around. This is a product that we have that's in our early access program. We took on this space because demand forecasting is still a challenge for many retailers today. Retailers often have trouble integrating new signals and insights into their forecast. They're often based on static views of what happened last year and maybe some more advanced statistical modeling, but most retailers see that there's more opportunity in their forecasts versus where they're sitting today. There's also challenges understanding new products and new categories, not having enough information to really understand what the demand for that product could be. Maybe making those decisions based on intuition, gut, or similar product performance. And then last, many forecasting models don't really understand local demand impact of things like weather, consumer behavior, and even now, shelter-in-place orders. Our Google demand forecasting leverages our best-in-class AI and ML and data sets from across Google. It's designed to integrate with your current systems and does not require a rip and replace of platforms that your merchants and planners may be using today. Explainable AI then helps you better post-forecast review where you're getting performance and what's really a signal inside your forecast. As of today, we've developed ML algorithms for demand forecasting that are driving more accurate forecasts for customers. The solution allows retailers to model future demand for both long horizon order planning as well as short horizon use cases to feed into allocation, replenishment, and planning systems. We are now building out the end-to-end solution and partnering with a handful of retailers in the early access program to take this solution from development to launch. In addition to this productized solution, we are also working with retailers who are investing in their own efforts in this space using our AI and ML platform offerings. And finally, we also work with an ecosystem of partners in this space, system integrators like Accenture and Deloitte, and ISVs like O9, who can help you get results quickly and realize value from your data with integrated and out-of-the-box solutions. One example of a retailer that we're working with in this space is Carrefour, one of the largest grocery retailers in France. We've partnered with them across a variety of facets of their business, but one very exciting area is they've stood up an artificial intelligence lab in Paris. This is a place that their Carrefour engineers partner closely with our Google AI expert to work on solutions like optimizing their product assortment. It's very important, as you guys know, to have a deep understanding of what's most relevant at an individual store location. And so using our recommendations and AI capabilities to understand that assortment tailored to the local store level has been a great value to Carrefour. Next, let's talk a little bit about driving operational excellence. Providing the best-in-class customer care and support through your call centers and chats has always been important, but has become ever more important in the times of COVID-19, as call centers have been overwhelmed with all sorts of questions from, do you have certain inventory in stock, and what are your special shopping hours? Like all organizations, retailers are facing a revolution in customer care. 33% of retail customers will consider switching to a different retailer if they've had a bad experience. And estimates show that over the next several years, AI will be a large component of providing service to customers in call centers. So it's important to be thinking about how you can leverage artificial intelligence and make impact in your business. Google Cloud's Contact Center AI solution is built for this new world, based around a conversational core that understands human interaction and incorporates the context. At its core, this virtual agent AI handles incoming calls or messages and engages in natural human-like dialogue to handle common use cases and flows, including having to go off script. When the call can't be handled automatically, it's passed to a human agent, and the Agent Assist AI steps in to support with the relevant content from the knowledge base and context about the user and their situation. The Insights AI then surfaces trends and analysis to help the entire system improve. For retailers, the fact that it's centralized means you can apply consistent intelligence across every application in the customer journey. The biggest cost savings can often be found from deflecting voice calls into your contact center. But there's been challenges in the past because conversations can meander and IVR trees may not be able to adapt. The inability to flex to human conversation style has also historically limited the ability to assist agents in real time. Contact Center AI has the ability to go off script so you can work outside the predefined flow, answering complex questions full of unexpected stops and starts, word choices, or implied meanings. Contact Center AI also has the ability to handle multiple use cases for your customers, like taking a payment, updating information like a phone number, giving them information about store hours, which then allows you to fully automate routine tasks and further deflect calls. You can start with an easy use case and grow your adoption depending on your organization's needs. During COVID-19, for example, many retailers were faced with a deluge of customer inquiries specific to store timing and special hours. Our team offered up a rapid response virtual agent that could be set up in days and take the volume of calls off your busy agents, and most importantly, make sure that customers felt supported through this period of heightened anxiety. Marks & Spencer is one of the customers we've worked with in the contact center AI space. They work with our partner Develop to leverage Dialogflow to help manage their contact center interactions. Marks & Spencer is one of the best beloved retail brands in the UK with over 30 million loyal customers, and they had switchboards in 13 different store locations across their store footprint, and they were taking 9 million calls a year. You can imagine that's a lot to understand the different things that customers may be calling about specific to that store, but also broader questions that can be answered more effectively. Using Dialogflow, they were able to reduce that call volume to the stores by 50% and route more than 7 million calls into the centralized call center. Now that we've talked more about our solutions and some of the challenges that retailers have using AI and ML in their business, I'd like to share a little bit about some of the best practices we see across all the customers we're working with. First is understanding your data-first strategy, making sure you're thinking about your data in a holistic, platform-based approach that really expands to meet all the needs you have going forward. Unlocking those data silos and bringing together the product, transaction, customer, and supply chain data. Second is AI is truly a team sport. Getting the value out of AI can often sit at the intersection between several different stakeholders in retail. Whether it's the merchants, the planners, or the marketers, they may have a very different view of where value sits and how your brand should really take on using AI. Your CEO is often your top advocate to help bring the adoption of AI and ML in the business. Third is thinking about how you can test for scale. So given there's so many different use cases you could go after, it's a best practice to use proof of concepts to prove the value to your leadership team and then get kind of resources and more attention to move forward with more use cases going forward. It can give executives and your stakeholders a firm sense of what type of value they can expect and how they can be interacting with data to drive value. And then last is going mainstream. So thinking about how you can better expose data and insights to all of the users within your organization. Thinking about tools like Looker to help visualize and help people understand what the data might be telling them. This will speed your rate of change and bring people along the journey much faster. This is kind of taking data out of the rearview mirror and putting it into something that directs the future of your organization. So now that we've talked about solutions, best practices, I'm excited to see what you can do to drive the adoption of AI and ML in your business. We have a variety of resources available if you're interested in learning more about each of these solutions, customer reference examples to go a little bit deeper, as well as partners that can help you on your journey. I'm excited for what comes ahead in retail. Data is at the center of all digital transformations, and there's great things to come.
Coming back from this session videos, welcome, whoever stayed with us still. Nice to see you still. Let me close the slide. We watched two videos in regards to advanced analytics AI topics. One was about explainable AI. Second one was about possibilities so that the retail can boost their productivity and boost their sales thanks to AI. I'm really grateful that Dominik and Aleksander could join us here on stage, and let's discuss together these areas which we watched for last couple of minutes. Welcome, Dominik. Welcome, Aleksander. Can you hear me? All good?
Hey, yeah, I can hear you well.
Hello, everyone.
So, small explanation. A gentleman called Dominik's screen is our favorite Dominik Lewy, team lead for data science, with very nice, freshly designed surname, which I was not expecting, and Aleksander Molak, our data scientist. And guys, I watched these two selected by you movies, and first question, which I would shoot directly, is please explain to me what is this explainable AI, because I didn't catch this quite well.
So,
Alek, want to take this one?
I think, yeah, I can take it, sure. So I think there are a couple of layers actually of explainability, but what is the most hot topic lately is like a high-level explainability, I would call it. So what does it mean? If we have a very simple model like linear regression, for instance, we can kind of easily analyze the coefficients that we have for all our features. So for instance, let's imagine that we have a model where we have 3 features: age, experience, and previous job, let's say,
okay.
Right? And we are predicting someone's income, for instance. So if we use a very simple model like linear regression, where linear regression is actually a neural network, one-layer neural network, then we can kind of easily say how much each of these features, age, what I said, so I don't remember, age and previous job and the third feature. Yeah, to what extent they contribute as predictors to our prediction. So if I want to predict your salary, Pavel, for instance, it might be the case that your previous job title would be more important than your age or than your education, for instance. And we can easily grasp this information from the coefficients, from the model. But when we are using more complex models, it might be neural networks, like deeper neural networks. It might be some tree-based methods like boosting, for instance. It's very hard to understand how which feature contributes to a prediction in what way, because the model is very complicated. If we have a very deep neural network, it's like a function within function within function, very complicated, very long mathematical function. We can imagine a model, trained model, as a very long, complicated function, which is actually not human understandable. So we are not able to say, okay, this feature contributed to this extent to our prediction, and this to another extent. At least not when we take a model out of the box. And all those explainability methods are trying to address this challenge. So, for instance, in the talk, we're talking about integrated gradients. So this is one of the methods that is, in a way, it's easy. It doesn't require you to change the architecture of your model. You just follow your gradients with respect to your features, and you are able to say, okay, for this picture, for instance, I was classifying some pictures, right? This particular set of pixels was important for my prediction, and other pixels not that much or not at all. So this is an analog of what we have in linear regression, actually. Yeah, we can say that particular features contributed to a particular prediction. And we have different methods, other methods like Shapley values, which is rooted in game theory, for instance. It's a very interesting method as well, which lets us say which features and interactions of features as well contributed to what extent to our predictions. So this is something that can be used.
This is also like nicely exposed by UI available on Google Cloud, or did I understood it correctly?
Yeah,
or this
yes.
is more a Jupyter Notebook feature.
So this is actually, I think it's both actually, depending on your toolkit, right? So you can use both. And when you're using this API from your Jupyter notebook, as we seen in the video, you can just get information about which pixels were also important. So you're getting back actually a picture just in a digital form, and then you can, you can plot it then.
I even recently had a discussion with client about the same exact topic, and we arrived at a nice, concise definition of what the difference between interpretability and explainability. So interpretability, it's like something that comes from the theory of the algorithm that it's used. So as Oleg mentioned, the linear regression. It's based in theory that we can interpret the coefficients and quantify the magnitude. And explainability comes when we have more of a black box model, and we need to somehow reason what's the impact of each feature, and we need to apply a meta model on top of the deep learning model or the black box model in order to find out what's the impact of each feature. So I believe it nicely separates those two interpretables models and those that need explanation, and that's why the explainability comes in.
Yeah, sure. I could that. Okay, I'm getting the point, because getting in front of senior executive and discussing on the level of functions of neural network model might be challenging. So going on that level, that it's explained to you, and then this explanation can be also given forward to people who do not deep dive into data science, gives a benefit. Clear. Any other interesting things which you catched? Guys?
Exactly, like referencing your meeting with the senior executives. So what's the, and it was already mentioned somehow in this movie that we watched, that there are some
I lost you for a moment. I don't know if it's just me, but Oleg is moving and Dominik is frozen.
Yeah, I see Dominik frozen as well.
Dominik plays the frozen character from the movie. It got. Now you're back, and we heard you for the last time that in this video it was clearly shown as a.
Yeah. There are some merits to this explainability, and one of those is adoption. So how we can ensure that the model is adopted throughout the organization. It's by talking to the business people with their language and like explaining what from the world that they know, from the world that already exists around them. So the input to our deep learning models, like for example, this years of experience, this previous job, like talking in the same language, what's the impact of each feature. And this is actually offered by this explainability.
Understood.
Yeah,
what else, guys?
If I can build a little bit on top of what Dominik said, I think it's also important to understand that explainability is a buzzword today, is a kind of a buzzword today. And I'm not mentioning this because I want to say that it's not important. I think it's very important, and also in some broader context, like social context and ethical context sometimes. But I think it's not. It's also not worth remembering that it's not always necessary. So, for instance, sometimes it's just good enough for a given business case to just have a model that works. And we know that it works because we checked it on our validation test set and so on. And we don't really need, there is no need to explain this model. So on the other hand, we have other cases like, for instance, detecting cancer, or maybe building a credit approval model, right? So then we really want to know why the model gave us certain prediction, gave us certain input. So I think it's also worth to remember that sometimes explainability is something that we really need and something really important. But sometimes it's not really necessary. So it's always good to discuss this and make your customers aware that there's a choice as well, right? And when it comes to adaptability, adaptation, I think it's also it might be critical for adoption, right? So it might be the case that without explainability, the model will just not be accepted, because this is just one of the necessary conditions in a certain kind of business, right?
Especially when you discover something counterintuitive, right? And you want the business to adopt that in, I don't know, in the change of process, change of setup, and so on, and they don't want to follow because it sounds too risky.
Yeah, exactly. Basically, at any point, the business requires some, switches or leverages that they want to impact the future business state by changing something in the input data, or basically whenever they want to impact the future, they need to have the explainability in order to be able to influence those factors that are truly important for future predictions. So like I'll mention a couple of cases where this explainability is required, and here I instantly thought about credit scoring. I probably used it already, but here the actual reason is that it's obligatory from the regulatory perspective. And at the same time, when we were talking about a situation where we do not need actually any explainability, I thought about, for example, online ads. Yeah, what actually matters is if person clicks on the ad, and it doesn't matter like what's the hidden pattern there. It's simply about generating CTR and conversions.
Yeah, and the second session, let's refer to this one a little bit. Plenty of hints where retailers can get benefits from AI. I saw a couple of examples. What drives my mind, my question is that sometimes we are in that struggle. There is a solution out of the box. Let's point to demand forecasting, which was mentioned on the presentation. And there is this path of getting custom. How you discuss that? Of course, I know I heard it several times how you discuss it with customers, but could you refer to it here? Like I have two solutions, yeah, ready to go demand forecasting from Google or someone else, and a custom project. Where to find the good decision? Let's say split.
So actually, it's usually a matter of pros and cons, because both solutions offer some merits. Like for example, with the out-of-the-box solution, like this demand forecasting, we can get a lot of external data sources that would be hard to acquire and costly to acquire on our own, and this comes with scale. But the scale of the company is also an important factor, because if we, for example, have a lot of ERPs, like 8 or 10, and all of those produce data in a different format, and there's a lot data onboarding that needs to be done to an off-the-shelf solution, which is usually expecting a certain format of the data, then it's worth to consider something custom built. So I would say that one of the important factors is the complexity of the data model within our organization, and how hard would it be to actually adjust it to the input that is required. And the other one is the customizability, I think that's the word. So how much influence do we want to have on this solution? Yeah, is our business somehow specific, and we want to be sure that the specificity is somehow reflected in the models? in that case, also a custom solution would be a better choice, because here we have like full influence on in which direction we want to move. And with the off-the-shelf one, it's less probable. But the off-the-shelf one also has its merit when it comes, for example, to doing something quickly, dirty, and testing some hypotheses. Yeah, if you want to do, let's say, a POC, that's a really viable alternative. Yeah, and Oleg, what's your view on this one?
Yeah, I think you mentioned like most of the things that I think are important here. But if I would to add something, that would be probably also a case of building a way of interaction with the solution. So when you have a custom solution, you can really design the interaction from ground up. So if you have people who work with certain types of software, they are used to the interface.
And this time we lost Oleg. Am I right?
Yeah.
One by one.
Probable.
I didn't. Yeah. I haven't predicted that. Oh, Oleg is back.
Is it? Yeah. I think I'm back. Thank you. From my experience with projects, it seems that for many companies and many stakeholders, it's very important to understand what is going on in the project, what is going on in the project, how we approach modeling, how we build and how we design user experience. And this is something that goes back to adoption that we mentioned briefly before, because we also believe that user experience, how people interact with machine learning and artificial intelligence solutions, is something that really matters when it comes to adoption. So that would be the aspect that I think is also important for many customers and stakeholders.
Sure, we can either go quick and dirty and have a ready black box solution, or go more custom at later stage. All of that realizable on Google Cloud Platform, either with managed service or with infrastructure which we'll put for that use case. Sure. Gentlemen, I think we will end that live session. Thank you for your comments and for your attendance here. Enjoy the evening, and see you tomorrow at work. And I will quickly go into the dimension of closing of that session. So, ladies and gentlemen, that sounds like we have it all. I want to thank you for your focus, for these who stayed with us. I think if it comes to nominating one particular winner is Mr. Truszkowski. I will pop up one of his questions. So he's the winner. 1 hour of free consulting from us is there for you. Try to contact us, you know how. Thank you for that. If anybody from live audience still wants to catch this opportunity to be in the game, and just send some comment, because there is some delay. I need to wait a little bit to see your comment on any of the live streams which we are live now. But to summarize, you will find that video, which you can scroll on YouTube, for example, backwards, topics around roadmap for the overall smart analytics suite of Google, a roadmap for BigQuery, new features of BigQuery, roadmap for Looker, interesting story about Looker deployment, discussions on data lakes, streaming, BigQuery optimization, geospatial analytics with Google BigQuery, and AI talk, which we just finished. around explainable AI and around benefits for industry of retail and fast-moving consumer goods. Enjoy it. We will leave it recorded on our social media platforms for a longer while. Maybe slightly edit that to make time marking for certain chapters, because it's a long 8 hours video. But that would end the stream. Thank you. Hope to see you next time. Stay safe. Thank you.